Good evening. Ah, I always make this error. Good morning, good morning, good morning, good morning, my dearest NEET warriors. I can see myself, so that means I am obviously visible. Just give me a confirmation that I'm audible or not. Good morning. Good morning, good morning, my dearest NEET warriors. So, beta, 21st June is just 5 days from today, and yes, you definitely need your revision. So, let us start the amazing session for today. For chemistry, a long marathon, and what we plan to do with this marathon, beta, we will be revising everything. Obviously, the long marathon, you make it however long you want to. Obviously, the time always remains restricted. So, in order to maximize the efficiency, I will definitely be taking all the relevant concepts, mastering, helping you to master all that revision. But yes, if any of you definitely feel, uh, yeah, so thank you for the confirmation, guys. So, good morning, Surya. Good morning, Shivam. Good morning, Padmawati. Good morning, Gaming. Good morning, Arum. Good morning. I hope, chalo beta. I hope everybody is sitting with their pen and copy. Make sure if you have any relevant chemistry notebooks of yours, then definitely keep that notebook with you. Yes, Surya, Padma, then BL Verma. Good morning, everybody. Beta, sir, the most expected concepts, please. Yes, beta, obviously. Soumya, beta, obviously. With although this will be lasting, I guess we will be having dinner also together. But yes, I will rather try to finish around 9 or 9:30, because after that you have your biology session also. So, although time is definitely a constraint every time, but you have to promise that you will be sticking with the complete marathon, because beta, we will be discussing whole of chemistry and what areas of chemistry from where the maximum number of probable questions are going to land. So with that, but yes, I definitely want each and every one of you to please participate in the questions, solve them, take out your rough copy, bring out your class notes wherever they are, just bring everything in front of you, so that you can continue to revise also, because what formula you are missing, and in order to actually know that what is your area where you actually need more of preparation, you definitely have to select those relevant questions. So with that, let us begin the journey. I am getting a message over here. uh, eh? Okay. So keep it everything aside. Chalo. So I was just getting a message from my studio helper, but yes, let us focus on the main thing over here. That is to revise for the best of our marks in our NEET examination. Now, sir, where you are going to start from, beta? I am going to definitely after my start, I will be asking you that what topic you want me to start, because I have segregated all class 11th and class 12th PDFs for you. I have made those PDF very properly so that I may only be discussing the relevant questions. And yes, I will be starting with the most highest ROI bearing topic, which is definitely the basic of organic chemistry. So we will be starting with GOC, and then directly we'll be moving to the other areas of chemistry. But yes, what you will say, definitely we'll start with that. So everybody is good that we shall start with organic. Acha. Good, then definitely I will be answering then I will be asking you which topic. Acha, Ananya is saying class 11th. Beta, so GOC is class 11th only. Sir, message, will the session help me? Yes, beta. No, I 100 plus. Say 150 plus, because beta, if you stick with the complete session, yes. So we are starting with GOC, but if you stick with complete session, beta, then it is going to help like anything. So people are also Gokul, and these people are also mentioning GOC. So beta, a high yielding topic. So let us start the discussion with GOC only. I have a beautiful set of questions which will help us to revise the complete GOC. Obviously, the process will be the same. We will be learning using the relevant questions. So the first question is in front of your screen, and the time for the question is 45 seconds, but obviously you can mark the right answer before that. I hope so. So yes, so we are starting with GOC, General Organic Chemistry, but in GOC we'll be discussing all the electron displacement effects, the aromaticity, all the relevant topic which you should know, but yes, with precise number of questions. So I hope you have started. Yes, you will definitely score 150 plus, my friend, in chemistry. Uh, Likhit Gaura. Yes, beta, definitely you will. So people are answering A. Ananya is saying A. Let us explore. Sir, this is a compound which is having polyfunctional group. So who is supposed to be the most senior functional group? Sir, carboxylic acid. That means this will be 1. After that, sir, definitely there is no branch at second position. So this will be 2, 3, 4, and 5 and 6. That means in benzene I have COOH. That means my root word, my word root along with the suffix is definitely benzoic acid. Benzoic acid is there in all the options. After that, sir, at position 2 I have OH because it's a branch now, so it will be termed as hydroxy. This is bromo, starts with a B. That is nitro, starts with an N. So after that I should have 3 bromo. That means 2 options are gone. After that, obviously I will be having hydroxy, but hydroxy is at position 2, so definitely A is my answer. Chalo, 100%. So now I will not be wasting time and rather will move directly to next question, giving you 30 seconds for this. Time starts in 3, 2, 1, go. Let us brush the basics of IUPAC so that we can move to the yes, perfect. Speed, okay. Speed, perfect. So 30 seconds has already started. I hope everyone is making most of it. People are answering. Okay, they must be answering in the poll. Ha beta, beverages as in coffee is definitely a must for me. C. Sir, the only important thing I want you to keep remembering is beta, this C triple bond N carbon must also be taken in the main chain. That means at third position I have amino with 4 carbon as my main chain, that is butane 1 nitrile. So definitely answer is option C, 88%. So the option B, most of the students who have picked, they have definitely, although they have considered this, but they have taken that branch as 2 beta, the functional group which contains carbon. Obviously that carbon has to be included in the main chain. Please make sure you do not commit this error. Although 88% are right, but still I can see few students not answering correctly. Moving to the next one. Time starts in 3, 2, 1, go. Yes, again a topic which will help you to even assign the RS configuration or the EZ configuration. The RS configuration is used for for optical isomers. The EZ configuration is used for naming of geometrical isomers. So I guess this is a geometrical case. So please try this one as well, beta. Beta, yes. Lick Gora is asking, sir, RE-NEET. Beta, yes. I mean, definitely after this, they will be making a good or rather more conceptual paper. So if you are good with your logics, then you need not worry. It will be good. Perfect. Perfect. D. Shivam Singh is saying D. Time done. So yes, D is your right answer, 60%. 30 next people are saying A also. So let us explore this question, sir. Obviously naming is quite doable, sir, because this is 1 2 from this side also, this is 1 2 from that side also, and that side is having a branch, so obviously that will win. So this is 1 2 3 4, 5, and 6. That means I have 6 carbons with double bond in 2 3, so that means 2 ene, with triple bond at 4 5, that means 4 ine. So definitely name is good. Now what about obviously at second position you have bromo. Now what about this E and Z? Obviously all options are E, so for this case, even if you do not know EZ configuration, but still you should at least know how to name that EZ configuration. If this is your alkene, rather let me make this alkene over here. If this is my alkene, then I have these two substitutions on that side, on the right side, one being the methyl group, one being the bromo. You just have to check which atom, which attached atom directly to the sp2 hybridized carbon is having most highest atomic mass. So obviously bromine is having most highest atomic mass, because you just compare carbon and bromine, the directly attached atom. So among carbon and bromine, bromine is heavy, is having highest mass. So according to sequence rule, according to CIP rule, this becomes your senior group. And on this side, so definitely there is one carbon chain, long chain, and one definitely will be hydrogen. And among them, this is senior. So when senior groups are on same side, when senior groups are on same side, it is called Z configuration, because you can't use cis trans, they are not same group. When same group are on same side, that is cis, but when senior groups are on same side, it is a Z configuration, while if they are opposite direction, it is an E configuration. How you should remember this? Always say opposite, so that you can at least learn that opposite stands for the E form. Now over here the second carbon is acha, this is this side is the second carbon, it is saying E. Okay, all option are saying E. So in that ways, it should be beta, because bromine is a senior group, and on this side, okay, beta, this is oriented that way, so it has to be trigonal planar. So if this carbon has to be trigonal planar, one bond is this, another bond is this, then this shall be the third bond, which will make it a triangle. So that means, sir, H is oriented on the same side as bromine. So definitely that means your chain, your carbon chain is on that side, while H is on that side. That means senior group is here. So definitely it goes with an E configuration. Yes, you definitely have to check that, because sp2 hybridized carbon are trigonal planar. So you have to watch the structure carefully and then definitely decides. That definitely gives you D as your answer. I hope everybody is clear. Perfect. Moving to the next one. Yes, a good question to revise GOC also, and a good question for your biomolecules knowledge also. So a statement based questions. So let me give you a different, not statement based, integer type question, but giving you 45 seconds to attempt this. Quick. 45 seconds to attempt this one, beta. Please have a look at the name of the molecules and try to draw their structures also, because for biomolecules, obviously my JE students are not very comfortable with biomolecules, but you NEET warriors are definitely very much, because you learn biomolecules in your biology as well. So definitely a favorite one for you. But yes, a very relevant questions as per NCERT, so make sure you mark that answer very properly. Perfect. Perfect. People are answering too. Perfect. Chalo. Perfect. I hope everybody is attempting. The number of compounds among the following which contain sulfur as heteroatom. That means you need a heterocyclic chain which should definitely contain sulfur also. So people are answering 2, and I hope time is also done, and definitely answer is also 2. 50%. So perfect. Harish, future doctor, Tanay, Sara, Anu, Ananya. Ananya is a regular student. So definitely I have these structures for you. clearly mentioned. So all of you students who are missing any of these structure, I definitely highly suggest, beta, please make these structures very important structures. Furan, obviously aromatic, how many pi electrons you see? Sir, 1, 2, 3, 4, 5, 6. What about the other lone pair on oxygen? No, sir. It will be directed away, and because it will be directed away, that means, sir, it should not come in the delocalization. So only one lone pair will be counted. So this is aromatic also, but not having any sulfur in the heterocyclic chain. This is also aromatic. How many pi electrons are participating? The lone pair of nitrogen is not allowed because of the same reason. Hence, this is also a good base known as pyridine, again an aromatic compound as well. This is pyrrole. Here the lone pair of nitrogen is participating in the delocalization. So definitely how many? Again pi electrons, 6 pi electrons, which makes pyrrole. This is a beautiful alpha amino acid known as tyrosine. Tyrosine is having, sir, it is having a chiral carbon. It is having aromatic benzene ring, but sir, it is not having any sulfur. Now the two compounds which are having sulfur are thiophene, again an aromatic compound. The another lone pair will not participate in delocalization, and the last one is cysteine, and cysteine also contains a sulfur. Obviously this is not aromatic but a beautiful alpha amino acid. So very important structures for you as well. So I hope everybody is good with this too. Moving to the next one, again a question on aromaticity. Now time starts in 3, 2, 1, go. You are given how many structures? 4 structures, and you have to assign the stability of these carbocations. Sir, carbocations are stabilized by A, resonance. The extreme case of resonance stabilization is what? Sir, the extreme case of resonance stabilization is aromaticity. But in order to be aromatic, you have to satisfy 3 definitions, my friend. What are those 3 definitions? Definition 1, the structure has to be cyclic. Definition 2, it has to have that complete current loop of non-sigma electrons. And 3, the current loop of non-sigma electrons, the complete delocalization must be done by 4n plus 2 pi electrons, right? Chalo, perfect. So let's try and attempt this one as well, beta. Quick, let's try and attempt this one as well. B. Perfect. Students are answering Bombay. Beta, I guess, as per, if you're answering Bombay, then you feel A. I definitely do not feel so, beta, because definitely, sir, this is, beta, if you have a ring of 8-member carbon chain, then that ring cannot come in a plane. But ring, carbon containing ring, or any ring containing 7-member, if having profit of aromatization, that ring can definitely come in a plane. So this is a 7-membered ring, my friends. This is 1, 2, 3, 4, 5, 6, 7. That means that this 7-member ring is definitely can come in a plane. It is having complete delocalization. Yes, sir, because that positivity will be having that empty p 2p orbital. So, sir, it is having that current loop also, and that current loop is created by 6 pi electrons. That means this carbocation is making this compound aromatic. So definitely, beta, C should be your most stable structure. That means 2 and 3 are gone. Sir, that means this is more stable. Now you have to compare between B and A. So let us compare between B and A. Sir, this is 3-degree benzylic and this is 2-degree benzylic. So obviously A is more stable. That means after C I have A. So definitely you, if you just do option elimination also, you will get your answer. And why this is least stable? Because it is just hyperconjugation stabilized. How many hyperconjugating hydrogens? 3. Yes, definitely there is a factual area, sir. The maximum hybridization hyperconjugation stabilized carbocation is tertiary butyl carbocation. So that tertiary butyl carbocation, because it is having maximum hyperconjugating hydrogens 9, that's why it supersedes aromatic stabilization or resonance stabilization of 1 degree benzylic. But that is an exceptional case. But yes, that exceptional case also you should take into consideration. Else, for all the other cases of comparing carbocation stability, always remember this: if I'm being a carbocation and because of me being a carbocation, the complete ring is getting aromatic stability, that becomes the most stable structure. I hope everybody is clear. So let me see the percentage as well. 32, because I was seeing in the comment section also people were answering option 2. So this is a question, I guess that will be a takeaway for the first takeaway for your class. Okay. Sir, after GOC with chapter. Beta, after GOC, Soumya, whatever you say, you just write what you want after GOC. I'll start that. No issues. Now, just a bit of confirmation, beta, just a bit of revision, a very thorough but a very precise revision from my side, because I feel most of the students miss this, because obviously I was having less percentage of students answering the correct question. Beta, electron deficient species are stabilized by electron donating group. So if I have a carbocation, or rather a radical, it will be stabilized by electron donating group. Who is the most powerful electron donating group? If you are having aromatic stabilization, then that is most stable. After that, resonance effect is dominating. After that, hyperconjugation, and least stabilizing or least electron displacement effect is inductive effect. Point number 1, everybody should know. Now, if I am rather electron rich, I beg your pardon. If you are supposed to stabilize an electron-rich species rather, then they will definitely be stabilized by electron donating groups. So what are these plus R and minus R groups? Sir, if I have a vacant orbital, then I can attract those pi electron clouds. So I will be a minus R group. Rather, if I have no empty orbitals and I have excess of electrons as in lone pair, then I will be a plus R group. I hope everybody shall keep this thing in their mind from now. Moving to the next one. Time starts in 3, 2, 1, go. Please make sure you're keeping that conclusion in your mind. Quick. Perfect. Perfect. Next, start in organic chemistry. Sir, next, start in organic chemistry. Beta, we have already started. Acha, you want me to continue with organic? Definitely, beta. Whatever you guys will say, I'll do that. Because we have to do the complete syllabus. So starting with GOC, obviously, but we will go where you want me to go. Nahi beta, don't write this, Karan, don't write this. Just attempt these questions, and once the live is done, na beta, I will be giving all these notes. So you can download all these notes from the PW-NEET English WhatsApp channel. So don't write beta. Soumya is saying inorganic. Okay, Soumya. Or else we can start chemical bonding also, periodic table and chemical bonding also after this. People are answering, time is also done. People are saying D, so let me mark D. 75%, so 25% are still confused. So let me help them to not be confused. Sir, this is 3 degree. So obviously in the question you are asked A should be more stable. So sir, here B is more stable, so not an answer. Sir, if you compare these, then again a very important logic. Order of Bayer strain. Beta, what is Bayer strain? This tetrahedral carbon wants to be in 109 degree 28 minute, but rather you are forcing this carbon. If you are forcing this carbon to form a cyclic ring, then that means you are forcing this carbon to come close. If this carbon will come close, beta, then it is restricted to come at an angle of 60 degrees. Sir, bond pair repulsion will make this molecule go crazy, and that was given to the community, the science community, by the scientist Bayers, and it is hence known as Bayer strain, which suggests that 3-membered propane is highly strained, the bond pair repulsions are super strong. So this will be very reactive, followed by four member cyclobutane is rather better than cyclopropane, but still having strain. Again, five membered is also having strain, but obviously least among them. And if you just compare, if you just calculate the enthalpy of hydrogenation experimentally, it was done by Beers, but you can just have this conclusion that six membered carbon chain is free from any kind of Beer strain, and hence all the compound wants to acquire a membered cyclic configuration. That's why you see these organic compounds more bearing six member carbon chain. That means, sir, if this is a radical, then this is Beer strained also. So although degree is same, but this is strained, hence this will be more stable. So not an answer. Sir, this is obviously resonance stabilized. It is called an allylic free radical stabilized by resonance. So, sir, this guy is more stable. Sir, I want the first guy to be more stable. So, obviously, option D will be your answer, where this is 3-degree benzylic, and that guy is maximum hyperconjugation. Agreed. But this maximum hyperconjugation is only stable with a 1-degree benzylic. So, rather, if I have 1-degree benzylic, which is phenyl CH2 radical, then still this will be a correct order, because this will be most stable, followed by this and this. But sir, that is resonance stabilized. This, now this you have to, this is a experimental fact also, that 3-degree 1-degree benzylic carbocation of free radical is relatively a very small, but it is relatively less stable than tertiary butyl carbocation of free radical, because this is having the best possible case of hyperconjugation. It is having 9 hyperconjugative hydrogens. I hope this basic precise exception you should definitely keep into your mind, which brings us to the next question. I have started the timer. Quick. You are again given with 4 structures, and you have to give the decreasing order of hydride affinity beta. Make sure you are making this interpretation. What does hydride affinity mean? Sir, if I am a positively charged species, electron deficient species, if I am stable, why I will want to react? So who will have highest hydride affinity, which will be least stable carbocation? So again, you have to obviously do the carbocation stabilization, but the most stable carbocation will be happy. It will have least affinity towards reaction with a hydride ion. I hope you're getting it. So obviously you have to do that stability order, but then you have to keep into your mind that if that carbocation is stable, then sir, it will have least affinity to react because it is stable. So I hope that point is clear to everybody. Now, people are answering B should be answer. B should be answer. So let me just, yes, Bombay is your answer. Hey? People have answered A and D. Beta, definitely that means I have definitely thought that you will be needing this proper order, and hence I have made this for you. So let us explore this again. Why is it so? As I was telling, the stability of carbocation will be inversely proportional to the hydride affinity, because if I'm stable, why the hell I will want to react? I will be very happy in my state only. So first, let us do the stability order. So the stability order will be D is most stable. Why this D is most stable? Because of this dancing resonance. What is this dancing resonance? Sir, you have already told us that 3-membered carbon chain ring is highly strained. So this, although it looks like a sigma bond, but it behaves like a pi bond because it wants to open. It wants to open up. That's why there will be sigma conjugation, and this sigma bond will be going there. Although according to resonance, non-sigma electrons, pi electrons delocalize. But this highly strained cyclopropane ring, even the sigma bond want to delocalize because they want to open up. They want to open up and free themselves from the highly strained cyclopropane ring. Hence, cyclopropyl, this dancing resonance, the cyclopropyl, the carbon next to a cyclopropyl group will have stabilization from this ring also, that ring also, and this ring also. This will make it even more stable than a aromatic system. So a classic case of dancing resonance, so this will be most stable, followed by obviously Bombay, because now this is 3-degree benzylic, followed by A, because this is allylic also and 3-degree also, and this guy is a simple tertiary butyl carbocation, just hyperconjugation stabilized. That guy is having hyperconjugation stability also, and allylic as in resonance stability also. So that means A will come third and C is least. That means affinity of C will be highest. So your answer will be obviously option 2. I hope everybody is clear. I hope everybody is clear. Chalo, perfect, 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 great. Now, uh, next one. Try and do this one as well. You will have to read through the question properly. So do the reading. Do the reading. Quick. Ha beta. Vismay, it is decreasing order. Yes. Vismay, that was decreasing order. Perfect. Aditya. Perfect. Ananya. Perfect. Ah, superstar is here. Now we will get all our answers. Superstar is here. Good morning, Neha. Karan is also here. Everybody is saying D. Chalo, perfect. I hope a perfect question to make you revise the plus R and minus R groups. So 87%. Great. Let me just give you a quick revision. Sir, plus R, sir, plus R, but this is cross conjugation, so not that much activating because it is under cross conjugation, but definitely plus R. So electron density will be created at ortho para position, hence A and D are correct. Here, sir, definitely plus R, in fact, strong plus R, even strong plus R than any soul. Sir, here, this carbon, once the resonance once you draw the resonating structure, this carbon will be C plus, and that plus will be giving this carbon an empty orbital, and this empty orbital will make this carbon a minus R group. So this will rather create positivity at ortho and para position. Similarly, it goes for the sulfonic acid group, because sulfur definitely has that empty d orbitals, which will suck the pi electron density of the ring. That will make the sulfonic acid group also a minus R group. Now, fluorine, although resonance is plus R, but sir, it is the highest and strongest minus I group, highest electronegative atom. So because of its super strong minus I, its plus R gets deactivated, and this also behaves as a electron withdrawing group. And if you talk of the remainder of halogens, then definitely their plus R is very weak. Why? Because a strong bond is formed when bond is formed between similar energized orbital. Once they will form a pi bond, carbon will employ the 2p orbital, chlorine will employ 3p, bromine will employ 4p, and iodine will employ 5p. So dissimilar orbitals, when they form bond, that bond is definitely is weak. So the pi bond formed is weak. That means a resonance, their plus R is very, very weak. Hence, For them also, what becomes operational? Minus I. So all of them are electron withdrawing groups, although they are applying plus R, but ultimately they are electron withdrawing groups. And if at all an electrophile is created, then definitely that electrophile will be directed where? Then the directive influence will be decided by their resonance, which definitely says that ortho and para position, the electron density is more, but they are not activating groups. Again, a point to remember, if although a very precise point, if somebody is asking you, then you compare that who among halogens is highest electron withdrawing, then a important conclusion, beta, chlorine is highest electron withdrawing, then fluorine, then bromine, and least is iodine. So you should definitely have an idea that if you compare fluorine and chlorine, then who is most electron withdrawing? Chlorine. You should, most of the students do not remember this, but a very important conclusion that among fluorine and chlorine, most electron withdrawing group is chlorine. I hope everybody is clear. Chalo, perfect. Moving to the next one. This is an easy one, so giving 30 seconds for this. 3, 2, 1, go. Quick. 30 seconds for this one. Quick. 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 Good morning. Good morning, Sanjana. I hope I'm not interrupting the board. Yes, I'm not. Chalo, perfect. So I guess time is also done. And I feel option 1 shall be your answer. Huh? D is your answer, what? Let us check. For the given compounds, the correct beta, you have to give the increasing value of pKa. So sir, if Ka is more, then pKa will be less. And when K will be more, once you will be a strong acid. So who is strongest acid? Sir, this is phenol. Sir, this is phenol with a electron withdrawing group. So this is electron withdrawing. Sir, electron withdrawing group increases acidic nature. This is again phenol, but this is plus I, because at meta position you cannot apply plus R. So this is also phenol, but at meta position this will be minus I. And this is phenol, at para position it is plus R. So electron withdrawing group will increase the acidic nature. That means Bombay will be highest, most acidic. So most Ka, that means least pKa. So you have to give the correct order. So least pK will be Bombay. So least pKa will be Bombay. If you just go by this, then only you can have your answer. Least pKa will be of Bombay because of the electron withdrawing group. I hope now it is clear to everybody. But yes, I have this generalization also for you, for all the students who still want a proper revision. So I have definitely done this for you, so that whenever you get these notes, at least you can make the best use of it. That acidic nature is increased by electron withdrawing group, rather decreased by donating group. And obviously if you just reverse your thinking, then if you want to see a base, then a strong base will be having more basic nature if it is complemented by an electron donating group, and rather if you have an electron withdrawing group, this will rather have less basic nature. So that definitely gives you option 1 as your answer. Moving to the next one. Yes, coming to isomerism, you have to mark how many optical stereo center you can see. The optical stereo centers are nothing. Yes, definitely you can have lots of optical stereo center, but the most common optical stereo center is a chiral carbon. What is a chiral carbon? A carbon which is having sp3 hybridized carbon, as in making four bonds, and all those bonds shall be differently substituted. Cool. Chalo, perfect. all those four bonds shall be differently substituted. So Superstar is saying 6, Karan is saying 6. Perfect. Chalo, let's see. Acha, time. Obviously, you can directly mark those sir, you just watch. If at all any carbon, अरे यार, beta, I have given wrong pole. I am sorry. I have given wrong pole. I am sorry. I have given wrong pole. It should be an integer. So, sir, this is sp2 hybridized. This is CH2. So, sir, not possible. This is CH2. So, not possible. This is sp2 hybridized. sp2 hybridized. Yes, sir. This carbon, because this is methyl, some other group connected to carbon, one methyl group and one hydrogen. So this shall be your first chiral carbon. Similarly, this guy becomes second, this guy becomes third, this guy becomes fourth, this guy becomes fifth, and the last guy becomes sixth. So how many chiral carbons you can see? Sir, I can definitely see 6 chiral carbons. Moving to, yes, a good one, a good one, a good one. So 45 seconds for this, a good one. Please make sure you are attempting the question properly so that you can understand the logic also behind it. Cool. Perfect. Perfect. C. Ananya, C. Most of the students are saying C. Chalo, let's check. Acha, time is still there. So kindly attempt, everyone. I guess time ended. 94%. Fair enough. Great beta. So let me quickly give you a analysis. So this is your enol form, and this enol form, in presence of base, so this H plus can be released, the conjugate base can be formed. So this H plus can also be released, a conjugate base can be formed. I can definitely see that conjugate base, and this conjugate base is resonance stabilized, making the 2 pi cloud, because there are 2 pi electrons. So Huckel's rule is also followed. So this is aromatic also. Hence option C will be your perfect answer. A very good and practical question to actually understand tautomerism also, because this is if you see this compound, then it can definitely undergo tautomerism also. So a very good example for learning these important concepts of organic chemistry. But yes, most of you have attempted it quite beautifully, so great. Acha, here you definitely have that. Chalo, oh, chalo. So this brings an end to the GOC. Just let me, obviously the answer you must have seen, so let us at least discuss this, that sir, if you have conformational isomer, then if bonds are just eclipsing each other, that means an eclipsed form, and if you have 60-degree angle between them, then this is your staggered form. Definitely staggered form has Gaussian staggered configuration also, and anti-staggered also. Generally anti-staggered is most stable because internal energy is least. But if you have a case of intramolecular hydrogen bonding, then even Gaussian form can become more stable. And if you compare fully eclipsed and partially eclipsed, then obviously fully eclipsed is having highest energy because of van der Waals strain and torsional strain both are very high. That means fully eclipsed is least stable conformer. Now if I have the dihedral angle between 0 and 60 degree, if it is 60 degree, it is staggered. If it is 0 degree, it is eclipsed. Between 0 to 60 degree, whatever forms you have are called skew form. Whatever forms you have are called skew form. So if you have any of that skew form, then in this question you are supposed to give angle of H dash, C, and H double dash. So this is my H dash, this is my front carbon. So that will be my back carbon, the circle, and it is connected with this H dash. That means they are talking of this angle. So definitely this angle is 120 degree, that we know, sir. This is basic geometry, sir. What about this difference, sir? This difference is already given there. So because it is having a 29-degree angle, so here also it will be a 29-degree angle. So the total angle will be 149 degree, which obviously you can see. Now, I hope everybody is with me till here. Now it is your choice. I am done with the practice of basic GOC questions. So that brings an end to GOC. The first hour is also almost done. So what do you want me to start now? Rather, we shall continue with organic because we have options. So you can very well tell me that what shall we start after this? Quick. Let me remove this thank you because I will be giving these notes also to you. So any preferences, guys? Class 12th physical chemistry or atomic equilibrium and thermo. Then we have then we can practice more questions on hydrocarbons because we have already started GOC. So any choice. Inorganic. So I am seeing inorganic, so I'm starting with inorganic. So then let us jump to periodic table and chemical bonding. Let us quickly jump to periodic table and chemical bonding. Chalo. Yes, beta. So let us jump to periodic table and chemical bonding, and definitely then we'll go to the D block coordination compounds, and class 12 we'll be doing together because you know for class 12 all these chapters of class 12, the organic part, the 5 chapters, alkyl halides, alcohol phenol ether, aldehyde ketone carboxylic acid, amines, biomolecules, and the 2 inorganic chapters, D block and coordination. We'll be mixing them up. So a large chunk of inorganic chemistry is through periodic table and chemical bonding. So let us start periodic table and chemical bonding. Quick. So the first question that we have in front of us is definitely related to the electronic configuration. So the time for this one, 30 seconds starts now. Quick. The element which do not belong to the same period of remaining elements. So remaining will be from same period, but one is not belonging to that period. So who is that element? So for that we have to learn our periodic table. So yes, Neha, perfect. Muskan, perfect. Obviously, sir, these for platinum, sir, for platinum, you must have remembered that rhyme that beneath nickel I have PD and PT. So nickel is a 4th period element. So that means this is 5th period and this is 6th period. So platinum belongs to 6th period. Sir, osmium belongs to 6th period. Iridium belongs to 6th period. And this palladium, nickel, PD, PT, PD belongs to 5th period. That means definitely option 3. So make sure you have a clear-cut idea of the periodicity, the periodic table, the trends that we have done, the periodic table that we have made. If any of you is not comfortable with the theory, then beta please go to the lives that we have done. They are already there in PW-NEET English live section, the YouTube channel, and you can definitely please revise because those theory sessions were also very precise. है ना? Chalo, perfect. Moving to the next one. Time starts in 3, 2, 1, go. Again, a very basic periodicity question. I guess this is a question from JEE Mains. So quickly try and attempt this one as well. Because see, Mains is asking this, then definitely NTA is interested in such areas. So you are supposed to tell, obviously use the option elimination option property as well. That will help to do such questions with less time. So the question is telling us that What are pnictogens? I mean, who among them belong to a pnictogen, which is definitely group 15 element. So this pnictogen, if you say, sir, the MC, definitely the last element name, sir, we remember that rhyme. What rhyme? The group 15 is New Zealand, Pakistan, Australia, sab bikau. After that, what is there? After that, you have MC. Now, what the seventh member of chalcogens, what the seventh member of chalcogens is nothing but LV. The last member of halogen is nothing but TS. The last member of noble gas is nothing but OG. Hello, hello, chalo, perfect. So that means option 2 becomes your right answer. Let me see. 25%. So beta, please make sure you remember and learn that periodic table very, very properly. The last element also has been asked, although for atomic number more than 100, we have that IUPAC naming. But yes, because this is a JEE mains question, and in my inorganic live, I have again made you revise the complete mnemonics of that periodic table. So if anybody is not comfortable still now, then definitely please go to that live of the inorganic session, and then you can definitely attempt such questions. But please make sure beta you remember the symbols, at least the symbols and their position in the periodic table, because that is a very, very probable question. Chalo, moving forward. The next one, acha, this is the same one. Now, as I was saying, so not even 30 seconds required, but still the IUPAC, sir, if I have element with atomic number more than 100, then I use nomenclature. What nomenclature? IUPAC nomenclature. What does it tell me? You just name the numbers and suffix, use a suffix which is IUM. Use the suffix which is IUM. So let us explore these options. I have to name 119. So one is un, then another one is un, not nil. Then I have non. So non is n. Sir, this is cot. Oh, come on, cot is. The oct is 8. So n, yes, sir. So NEM. NEM. Acha, this nil has been cancelled, and this is un. So this is 111. So definitely option Bombay is your answer. 84%. Perfect. Great. Moving to the next one. Practice one more. Practice one more. But now you have to link that name with the symbols of periodic table. Now you have to link the name with the symbols of periodic table. Name with symbols of periodic table. हाँ, ये केमिस्ट्री के नियम भी अजीब होते हैं बेटा. इफ यू रीड प्रॉपरली देन nothing is strange, and rather if you invest less time to your inputs, then definitely it can become difficult. Chalo. Perfect. I hope time has ended. Very less percentage. Why? Very less percentage, bhai. Chalo, let's see. Why, sir? You have to identify the incorrect match. And incorrect match is beta 1, 1, 1 EM. What is this 11th element, sir? This 11th element, if you just remember this rhyme, what rhyme, sir? Sir, of the after actinium, what is atomic number of actinium, sir? 89. So after actinium, I have atomic number 90. Starting for the starting for the 5F series, the actinoids. So actinoids start with a 90, and if you add 14 and 89, sir, 89 plus 10 is 99. That means it will end with 103. So definitely that means this 111 will be my actinoid. Now what is the rhyme, beta? So 90, so I'm saying 90 will be, sir, it will be after actinium you have थोड़े पहलवान, उनसे निपटेंगे, पुराने आम कम बिकेंगे, कैफे में ऐसे फरमाओ मैडम, नोबल लाउरे. So that means noble laure. So which element I need, sir? Sir, 103, 102, 101 and 100. Okay, I wish to get 111. I wish to get 111. So this 111 will be post actinium. I beg your pardon. So it will be after actinium. So this will be 104 and it will be ending at 108. So the D will be ending at what, sir? This is 104, then 105, sir, 106, 107, 108, 109, 110. That means, sir, first, second, third, fourth, fifth, sixth, seventh, eighth, and then ninth. So the ninth element, sir, what will be that ninth element? For that you have to remember the rhyme of this this D block, and this D block will be acha. After that, what was the rhyme that we had? Acha, raftar, raftar, raftar. Dubbing और singing बहुत हंस के करता है. मत देस, what do not give? Rugged cones. So it will be RG and CN. So that will be RG. That will be RG. And RG, no sir, it is not RG. That will be RG and CN. So sir, it is in for D, it is saying it is related to DS. This is DS. So it should be RG, sir. So this is wrong, sir. So definitely this is incorrect, but yes, definitely a very good question. And those questions you can only attempt once you are familiar with periodic table. Sir, how can I be familiar? But obviously you have to try and practice more questions, beta. Then only you will get an idea of getting the clarity of that periodic table relatability. And obviously the approach will also, the fine tuning, that is the fine tuning of you landing to our answer properly, will also increase. Anna, chalo, perfect. Good one. This was a good question. Chalo, attempt this one also, although a very doable one, but still attempt this one also. Quick. A question again based on logic, but clear, a very basic logic, but yes, a good one. The previous one was rather good one. The previous one was rather very good one. Quick. Quick. C. C, yes. Why? Because if, sir, I have 118 element, so 19th and 20th is not found. If at all it will be found, sir, it will be placed in the next period. So 119 will be alkaline, and obviously 120 will alkali, and then 120 will be the second group as an alkaline earth metal. So definitely option C, 95%. So great. Great. Moving to the next one, a statement based question, beta. Please read it properly, because a statement based question, so giving more time for this. Quick. 45 seconds. Quick. Perfect. D. Nihai is saying D. Superstar is saying D. Time is still left. So let us attempt the question. Beta, we have to select that statement which is not true. Make sure you are marking this not true or true. So which is not true? A, the properties of elements are function of atomic weight. No sir, atomic number. So definitely this is not true. So an answer. The properties of elements are function of atomic number. Yes, definitely correct. So correct. So not an answer. Elements having similar outer electronic configuration are arranged in same period. No sir, they are arranged in same group. So incorrect, hence an answer. An element's location reflect the quantum number of the last filled orbital. Sir, location will be mentioning, yes sir, if you have that electronic configuration, then the last electron will decide where it will go. So definitely correct sir, correct. So not an answer. Then E is the number of elements in a period is same as number of atomic orbitals available in energy level. The yes, sir, it is definitely. Acha nahi, it is saying number of elements in a period is same as the number of atomic orbitals available in the energy level that is being filled. No sir, it has got the number of elements that are filled in a period has to do with the Aufbau principle, that what orbitals shall come first, and that decides that number of elements that will be coming in a period. And obviously it is successively and gradually increasing as your number of electrons those are filled increases. So definitely this has got no meaning, and because this is obviously got no meaning, so it is obviously incorrect and hence an answer for us. So I guess, yes, rather good statement based question. I guess this is JEE Mains 2025 only. So see, practically the question was nothing, but because statements were asked, so it has created a fuzz, and that's why ACE. But yes, if you do option elimination also, then also you can land to a proper answer. But I guess over here, yes, 71%. So great. Moving to, okay, this is basic. This one. Quick. 3, 2, 1, go. Beta, boron family is always very precious because this is the most notorious family. So please make sure that you remember the periodicity, the trends, the not following trends order of at least boron family. Very important. The atomic size, the ionic size, although ionic size periodicity is simple, the ionization enthalpy, the electron gain. So make sure you do that. Like for example, it is just discussing the atomic radii. Then obviously we know atomic radii should gradually increase, but because they just come after D, and because of the effective increase, the increase in Z effective, the sir aluminium gallium has a disruption. So aluminium gallium will have that disruption. Aluminium should come here, but it has came here. Gallium should come third, but it has come second because its Z effective increased. Although Z effective of thallium is also increased because here F is introduced, but rather this is only seen in ionization, not here in atomic size. Now this is a fact. This is a fact which you should have to remember. So definitely option C is your right answer. But yes, for boron family beta, make sure you remember these trends very properly. It is very, very important. But yes, 80% of you are correct. So I'm also happy. Moving to the next one. Time starts now. Quick. The pair that has similar atomic radii, so that means it will be definitely due to the lanthanoid contraction. So just check those the pair that is belonging to maybe 4D series and 5D series transition elements. They will have same size, which you can clearly see. If you remember the symbol and the periodic table which we have done in our inorganic live. So quick. D. 84. Beta, still the percentage should exceed 90%. So because I am definitely again and again repeating, please go and watch. If you are not comfortable with periodic table, I have used an animated slide and made all the mnemonics revision for you in the inorganic session live that we have done. But yes beta, theory we cannot repeat today. At least the complete theory we cannot repeat today. So kindly go and learn all the mnemonics for these elements, है ना? So definitely this molybdenum and tungsten belongs to 3D and 4D series, so definitely they will have same size because of that lanthanide contraction. Great. Moving to next one, again a doable one, but rather a probable one. Quick. The out of the following isoelectronic species are. So you have to mark that isoelectronic species. Who shall this isoelectronic species be? What are isoelectronic species? So species which have same number of electrons. Species which have same number of electrons. D. Satish is saying D. Rushda is saying D. Yugank. Perfect. So let me just stop this poll and check this out. 77%. People are confused with C also. So why C beta? Why you are confused with C? So sodium Na plus will be having 10 electrons. This guy will be having 10 electrons. This guy will be having 9 electrons. This is not O2 minus, this is O minus. This guy is having 10 electrons. Just because of this, it is incorrect, and definitely this is your right answer. But yes, sometimes it creates a problem. So beta, please make sure you have opened your eyes and you are attempting question. है ना? Chalo, moving forward. These are some traps. When you feel that is a probable question option, but it turns to be incorrect. Rather feels bad also, but yes, you have to open your eyes while attempting these questions. Chalo, perfect. Perfect. D, C, dash, 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 D, 2. Chalo, let's check. The question says the element expected to form largest ion to achieve the nearest noble gas configuration. Now, who shall form largest, sir? Anions are supposed to have that largest size. So, sodium will form a cation. No, sir. Oxygen will form 2 minus. This will form 1 minus. This will form 3 minus. So, largest, sir, more be the negative charge, more electrons will be added. So, they will be going more farther. Hence, anions are for isoelectronic species. Anions becomes the more negative charge I attain, the bigger I become. The more positive charge I gain, the smaller I become. So, definitely Delhi will be your right answer. 50%. I hope everybody is clear now. I hope everybody is clear now. Chalo, perfect. Quick. Arrange the following elements in increasing order of first ionization enthalpy. First ionization enthalpy yes, perfect. First ionization enthalpy. Arrange them in increasing order of their increasing first ionization enthalpy. So let us check, sir. Sir, I have to compare lithium, beryllium, along the period. So along the period, sir, lithium, beryllium, boron, carbon, nitrogen, that's it? Yes. So along the period, size decreases, so ionization enthalpy should increase. So who should have least? Sir, lithium. All options are saying lithium only. After that, sir, beryllium is 2p2, sir. This is 2p2 and 2p1 because I am sorry, 2s2, come on. This is 2s2. Beryllium is 2s2. This is 2s2 and 2p1. Then obviously, sir, beryllium is having fully filled subshell. fully filled orbital, that is 2s, and penetration effect of sir s is more embedded inside the nucleus, so there is a anomaly. Rather, boron has less and beryllium has more. So rather, boron has less and beryllium has more. Only one option is suggesting you that. That means Delhi is your right answer. 78%. Great. Great. Moving to the next one. Yes, again a question. I guess this is also JEE mains. So yes, we should definitely make sure that we are attempting at least these relevant questions from JEE also. So हाँ बेटा. So 4 bar is less. You should do more number of times because ultimately this is going to be asked beta. The same NCERT is asked all the years. So students do, I do not know how many number of times. Then only they see the question which they have attempted so many times and then they do it, saving time for attempting more and more number of questions. So this is what practice mean beta. Chalo, perfect. A. Correct order of metallic character. So sir, metallic character, sir, silicon, beryllium, magnesium and potassium. Then definitely sir, you have to arrange them as per periodic table. So and we definitely know along the period metallic nature decreases and down the group it increases. So potassium will be here with atomic number 19, magnesium will be here with atomic number 12. So this belongs to second period, this belongs to the third period. Beryllium will be above magnesium and silicon will be after magnesium in the same period. So definitely sir, the down the group size increases, along the period size increases, electropositivity also increase, and along the period sir negativity increases. So definitely potassium wins. That means these two will be the right answer. It is gone. After that I should have magnesium. So both are saying the same, but yes, after that I should have beryllium or silicon. Sir, beryllium is although amphoteric but still it is an alkaline earth metal. Sir, that has gone to the p block element, so obviously electronegativity will rather increase. So beryllium will be a better metal. That means option 1 will be your right answer. Perfect. 73%. So great, but yes, you have to be very vigilant with your periodicity logics. So chalo, this is also a RE-NEET question, so try and attempt this one quickly rather. Okay, people are saying C, some are saying A. Let me read this for you. The first ionization enthalpy of element X and Y are this and this respectively, and the second ionization enthalpy are, okay, for X from 4000 it is increasing to 3000, and here from around 600 it is okay, this increases, so that is becoming around very around 8 times, and this is becoming almost, sir, not even double, sir, because this is 600, this is not even 1200. So that increase is very less. Obviously successive ionization enthalpy is increasing, but here after this it has increased to a very large value. That means, sir, this will definitely be a metal, and metal after losing electron has got inert configuration, and that's why the amount of energy required to remove the next electron is very high. So that means X is definitely a metal. So X is no, sir. Why alkaline? Because for alkaline the second will be not very, after removal of 2 electrons I'll attain that inert configuration. So that definitely mean X is a metal, alkali metal, and Y is an alkaline earth metal. Why? Because from 600 to not even double of it. That means it wants to lose that second electron. So definitely Y can be an alkaline earth metal. I hope everybody got that. Good question. Good question. Conceptually sound question, and yes, percentage is also less. So I hope everybody is clear now. Moving to, okay, let us do this also quickly. 3, 2, 1, go. Again, a basic conceptual thing for electronic configuration writing. So let's check who can write that electronic configuration properly. Good afternoon, Sonam. Rishabh is saying Delhi, then C, then Delhi, then again C, then Delhi. Chalo. The third ionization enthalpy is minimum. So you have to check the third ionization enthalpy and it has to be minimum. That means you must be willing to lose that third electron. So who is willing to lose that third electron, sir? Cobalt is 4s2, 3d7. So this is 4s2, 3d6. So this is 4s2, 3d8. So this is 4s2, 3d5. Man, Fe, Ko, Ni. So 25, 26, 27 and 28. Now, after losing 2 electrons, these 2 electrons are gone, sir. This will be 3d7. So each will lose 2 electrons and will have this D configuration left. Now, the third will be removal of the third electron will be from this D. Will be minimum. Sir, this will be removing, this is also partial. After removal also it will be partial. Sir, this is partial, but after removal it will attain half filled configuration, sir. After, sir, partial again partial. Sir, here it is half filled, so this, it will be having highest, sir. So this guy will be technically wanting you take my one electron and give me half filled configuration. So it will definitely be minimum for iron. I hope everybody has got less percentage. So now I hope beta everybody is clear with this. Guys, chalo, perfect. Chalo, attempt this one. Quick. In which of the following pair electron gain enthalpy of constituent elements are nearly the same? It can either be same or almost identical. So in which of them you have either same or identical values? Quick. Ionization enthalpies. Either same or approximately same. Neha is saying C, Muskan is saying 1 and 3. Then we have C or 4. Okay. So C, let us quickly explore C. Sir, one everybody is saying 1. So rubidium, cesium, yes sir, they are alkali metals, and down the group, because their size is so much increased, sir, then practically removing electron from rubidium and cesium will hardly make any difference, because the size increment is also compensated by the increased Z effective. So yes, they will definitely have same. Now, for sodium and potassium, no sir, because initially as you move, sir, the values are, sir, we have learned those trends. Obviously these values are different, sir. Astatine is a metal, sir, although halogens, but it is down the group metallic nature will definitely increase, sir. And yes, argon and krypton will also have approximately same, because of the same fact, both are inert, and after argon going to krypton, although size increased, but sir, Z effective is also increased, and because of that they will also have approximately same ionization. So 1 and 3, a good question, rather a good question to keep in your mind and copy also. Moving to the next one. Obviously, let me quickly give you the beta. Generally, electron gain enthalpy is negative. So generally, this is negative. Generally, it is negative. But you can have positive electron gain enthalpies also. For whom? Sir, for nitrogen it is very famous because size is also small and half-fill configuration, and for inert gases also. And what is the trend for inert gases? Sir, technically the positive value you just don't think of neon, then it should increase, but this neon has highest value. That means, but yes, you can learn the data also, but let us not learn the data, rather learn the trend. So neon has highest value, and then gradually then after, sir, helium will definitely have least, and down the group technically the delta, the positivity value of electron gain enthalpy increases, but neon has highest value. So option C is your right answer. Learn the trend beta for inert gases, learn that trend, don't learn the values, but at least learn the trend. Chalo, again a logical question, so attempt this one too. Time starts in 3 2 1 go. Please make sure you are reading the complete question properly. Quick, quick. D. 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 Most of you are confident. Great. Most of you are confident. Great. D. 88%. Great. The question says the formation of oxide. First process is gaining oxygen O minus, sir, delta H is definitely negative, the electron gain value. And sir, once I am already a negatively charged species, then this minus and this minus will definitely repel each other, sir. So you have to give energy in order to force the electron to enter, because you have to make the process endothermic. You are forcing it, because technically by virtue minus minus will definitely repel each other. So always the during successive ionization enthalpy, the second ionization enthalpy is obviously positive, because minus will definitely oppose the entrance of another minus. So then you have to say that this process of formation of oxide ion is favored through O2 minus, is iso electronic with neon. It is due to the fact that, then this is due to the fact that electron repulsion outweighs the stability gained by achieving noble gas configuration. So because it is achieving that noble electronic configuration, that is the reason because of which it is outshadowed, है ना? So theoretically a great point, beta. Theoretically a great point, a point that you should keep in your mind for longer duration of time. So moving to this one regarding the amphoteric oxides. I hope you remember that rhyme that I've given you for amphoteric oxides. सुनो जनाबे आली और उनके बेकार भाई. सुनो जनाबे आली और उनके बेकार भाई. सुनो जनाबे आली और उनके is nothing, it's just a rhyme. बेकार भाई. Now who are these bhai? Just elements beneath them. So Kashi गए Shankar Parvati, zinc, cadmium, mercury, and बैगन आलू गाजर. These metal form oxides which are amphoteric in nature. And then you have to, it will be easy for you to reply. Quick. Good afternoon, Chandni. Good afternoon, Chandan. Okay, I'm sorry, Chandan. Good afternoon. Chalo. So answer for this one, so Delhi. less percentage. I hope I've helped you with the rhyme. Let us see why this is Delhi. Why this is Delhi? Because I have initially NO. You have to give the correct sequence of first is neutral oxide. What are the famous neutral oxide? Sir, nitric oxide, sir, nitrous oxide, and carbon monoxide. These are your famous neutral oxides. Now, then definitely NO is my neutral oxide. What about acidic oxides? Sir, acidic oxides generally will have tendency to, sir, what is an acid which has tendency to gain electron? Who has tendency to gain electrons? Are non-metals. So technically, a non-metallic oxide, or rather an oxide where positive oxidation state is present, because even metal can form acidic oxides if their oxidation state are quite positive, because plus will try to gain minus. So which definitely shows carbon in +4 oxidation is an acidic oxide, CO2, hence it reacts with NaOH and form sodium carbonate. Now, what is basic oxides, sir? Obviously, which will try to give electron. Who will try to give electron? Generally, metallic oxides are basic. Generally, metallic oxides are basic. So, definitely calcium oxide is a metallic oxide. Now, sorry, what about amphoteric? For amphoteric, I've already given you a rhyme, but yes, please remember this, that chromium is amphoteric just in +3 oxidation state. If chromium is rather in some other oxidation state, then it is only amphoteric in +6 oxidation state. If you compare chromium forming compound in +2 or chromium forming compound in +6, then sir, this +6 is having high oxidation state. So high oxidation state will make it acidic. This +2, sir, chromium has stable T2G configuration, so it will try to reach +3. So if it is +2 oxidation state, it will try to give electron. That means it will become basic. So chromium is amphoteric only in +3 oxidation state. And this rhyme, what is this rhyme? Suno janabe Ali, or unke is nothing, bekar bhai. Who are these bhai? The elements just beneath these metals. These are the famous example of amphoteric oxides. Just remember them and you will be good. Great. Chalo, perfect. Moving to, chalo, let's do this also quick. The last one from periodic table. Then we will be moving to chemical bonding. Ha beta, next. After this, we'll be moving to chemical bonding. Chalo. Just attempt this one, and then we will be moving to chemical bonding. Option A. Less percentage, yaar. Why? Chalo, let's check the correct order of basicity of oxides of vanadium. Sir, you have already told us. If metal will, generally metal oxides are basic, but if metal will attain high positive nature, then it will try to gain electron. So just mark the oxidation state. So here this is +3, here this is +4, here this is +5. So sir, more be the oxidation state, more acidic nature. So more acidic as in less basic. So obviously this will be least basic. So option 1 only will give you your, with common sense. I mean, for inorganic chemistry, if they are not asking, this is also JEE mains question, if they are not asking regarding the factual thing and rather asking the common sense, that then I guess such inorganic question is very much welcomed. So you should also try not to leave such questions in your exam. Moving to chemical bonding. Quickly moving to chemical bonding. So with the first question, let us try to learn the theory also. Yes, but relevant theory. I will be making you practice more, and whenever I feel that you need more explanation by this percentage, so that's why I'm giving you less time. The reason I'm giving you less time is because of the same fact, because I definitely know you must have attempted these questions, but ultimately beta, if you are serious enough, then you must have seen all those NEET questions somewhere in your copies also. So the only reason you do not do those questions properly, because you have got some error, some drawbacks, some limitation, and what is our job to recover those limitations. So this is, with this session we are just trying to achieve the same. Chalo, so among the following, the total number of species not having, beta, please make sure you're reading these questions properly. Not having 8 electrons around central atom in outermost shell, which are not having eight electrons. So this guy is definitely having 8 electrons. So this is not my case. Yes, sir. It is not having because this is electron deficient. Sir, this is also not having. Beryllium is also electron deficient. So it is having 4. It is having 6. Sir, this is also electron precise. So no, sir. Now, sir, if you compare PCl5, then PCl5 phosphorus having 5 electrons in its valence shell, making, so this is also expanded octet. So in 3, it is not followed, which is option Bombay. So 64%. I'm very sure people have, see, this is also a JEE Mains question. What they have done, option 2 is 3, option 2 is 3 number, option 3 is 2 the number. So yes, with this they play with the options as well. Chalo, perfect. Chalo, again that octet rule thing, but yes, you have to try to read properly, beta, because this is, you are going concepts, you have to practice reading the question and then do calculations. So in or in physical chemistry, I will definitely give you 1 minute to attempt questions so that you can do calculations also. Perfect. B, A. Chalo, let's see. Molecules obeying octet rule. So A is saying which is obeying octet rule. So obviously carbon family always obey octet rule. So that means A is 4. So we are just left with Bombay and A. Then B is 1 or 2. So molecules with incomplete octet. So who is having this incomplete octet? Either 1 or 2. These guys are having incomplete octet. Yes. These guys are having incomplete octet. They are definitely having incomplete octet. So 2 is definitely, B is definitely 2. So if B is 2, that means A is your answer. But still, let us explore also. Molecules with incomplete octet and odd electron. So they are incomplete also and have odd electron also. That means C is definitely 1. Just make the structure. So nitrogen double bonded O, that means this nitrogen will have an odd electron. What about NO2, sir? So nitrogen double bonded O, and this oxygen will have a coordinate bond. So again, this has an odd electron. So definitely option A becomes your right answer. So that means, yes, percentage is also fine, 72%, but I hope now it is clear to everybody. Chalo. The basic question, how the structures are arranged, sir, because sir, molecule try to minimize those repulsive forces. What is the maximum repulsive force as per valence shell electron pair repulsion theory? Sir, lone pair repulsion. Less than that, so lone pair bond pair repulsion, and least repelling electron pairs are bond pair. So definitely that means VSEPR theory says option 2 is your right answer. Now hybridization, okay, now attempt this. Doable, conceptual, quick. make the structures, identify the hybridization. Very probable question, beta. Very, very probable question. C, C. Chalo. The hybridization of atomic orbital of nitrogen. Then first I am having NO2 plus. Sir, obviously that nitrogen attaining plus charge will be having double bonded O and double bonded O. So that means that this is definitely having two bond pairs, no lone pair. So this is sp hybridized. So NO2 is definitely sp hybridized. That means first is sp. So either this or this. Two options are gone. Next, two options are gone because sp. Yes. Now what about NO3 minus? Sir, nitrogen double bonded O. One oxygen is having minus, so this is one minus, sir, and the lone pair will be getting coordinated. So everybody's octet is complete. Sir, one sigma, another sigma, third sigma. So this is simply sp2 hybridized because steric number will be 3. So that means option 3 is your right answer. Obviously, NH4 plus will be sp3 hybridized with steric number 4. So that means option 3 is your right answer. 72%. Great. I hope everybody is confident now. Moving to the next one. Time starts now. Given below are two statements. Statement 1, ClF3, all three possible structures can be drawn. So I have these three structures. Obviously, the lone pair will be equatorial position because it is at maximum distance of 120 degree. Obviously, the here repulsion will be more. Here it will be obviously very much because lone pair needs to be occupying the equatorial position in a trigonal bipyramidal arrangement. So yes, but you can draw all, but yes, obviously this will be most stable. So you can draw all. So this is correct. Statement 2 is saying structure 3. Obviously 3 is not more stable because they have to be in the equatorial position. So that means this is wrong. Obviously, option 2 becomes your right answer. Less percentage, people are saying 50% are saying C. So, acha, you are feeling that second two. No, beta. Although from the picture it may feel, sir, they are at 180 degree, but beta, they have increased the lone pair bond pair repulsion. They have significantly increased the lone pair bond pair repulsion at 90 degree. So that's why whenever we have this AB5 configuration, the lone pair are always directed at equatorial position. At equatorial position, not axial, because axial will make bond pair lone pair repulsion. How many bond pair lone pairs are? 6 from top, 3 from top, 3 from bottom. Every will be at an angle of 90 degrees. So overall it will be de-hampering the molecule. Thinking just about the lone pair will make you feel that, but at least you should definitely have this idea in your mind. Cool. Chalo. Moving forward. Now next one, again good one for revising the structures. One of these questions, one of these logics will definitely be there, maybe two. So high probable question beta. C. Chalo. So let's check. Time done. So let me first check the percentage. 100%. So definitely correct, beta. C is your right answer because ammonia will definitely be trigonal pyramidal because of one lone pair. It will be not be tetrahedral having less angle than 109 degree 28 minute. Bombay, which is BRF5, will definitely be square pyramidal, four in a corner and one forming a pyramid. So square pyramidal. XEF4 will definitely be square planar because of two lone pair. All the four bonds will be coming in a same plane. And SF6 is definitely what is left octahedral. So six bond pairs are no lone pair. A perfect example. Yes, an old question, but yeah, definitely good one to revise. Chalo, not this one. Attempt this. Attempt this quick. Attempt this quick. Statements you have to read through. Statements you have to read through. Statements that you have to read through. Make sure you are reading them very properly. Chalo. The question says you have to identify the incorrect statement regarding PCl5. Three equatorial phosphorus chlorine bonds make 120 degree with each other. Yes, sir, this is correct. Two axial Cl bonds make an angle of 180 degree. Yes, sir, because they will different. Three are the equatorial bonds and two are the axial bonds. So they are making an angle of 180 degree. So this is also correct. The axial bond are longer. Yes, sir, they are longer because they are having more repulsion. They are at 90 degree. These are at 120 degree. So yes, sir, this is also correct. PCl molecule is non-reactive. Nahi sir, these axial bonds are very large. In fact, SF6 is non-reactive because the S bond, the fluorines are very small also. Rather, this is having lot of crowding because chlorine is bigger molecule, and moreover the bond length is also of these axial bonds are high. So in fact, PCl5 just with small amount of heat can easily decompose to form Cl3, and these axial bonds of chlorine are actually removed as Cl2 gas. So this is not inert. So definitely this is incorrect, hence an answer. So answer is definitely Delhi for me. Less percentage, but I hope now it is clear to everybody. A good question, but yes, why good? Because you have to read through the statements, and reading through the statements require practice. So this is what we are doing right now. Quick, next one. Quick. Quick. Array, very less percentage. Let us work on this. Structure of PCl5 in the solid state. Now beta, see, technically PCl5 as gaseous molecule is trigonal bipyramidal. You have already drawn that structure. But beta, once it acquires solid state, then what happens, sir? You have already told us that the chlorine are bulky, and because they are bulky, the molecule will rather try to release these chlorine. But why? If they are approaching each other, then what is the strongest force of attraction, sir? Ionic forces of attraction. So can they form ions? Yes, definitely they can. If one of the PCl5 molecule break as PCl4 plus and Cl minus, then this Cl minus can easily be accommodated by another PCl5 molecule forming PCl6 minus. So I will be having a perfect symmetrical structured cation and a perfect symmetrically structured anion. This is octahedral, this is tetrahedral. So I will be having a tetrahedral cation and an octahedral anion. Rather, if you just think the same for phosphorus pentabromide, then obviously this also in gaseous state is trigonal bipyramidal. But when this goes to solid state, in solid state, this will also try to do the same. So it will form PBr4 plus and Br minus. Why not, sir, PBr6 minus? Because now bromine is very bulky. 6 bromine cannot be accommodated around a small phosphorus atom, and hence it will remain as Br minus. A very beautiful chemical bonding also, but p block logic also. Moving to the next one. Yes, attempt this one, beta. Quick. Yes, Gaurav, definitely you can, Mr. Reddy. Yes, Gaurav. Yes, Gaurav. Yes. Okay, not Gaurav, you are Guru. Yes, beta. Reddy, yes. Guru. Make sure you are attempting them very properly, Mr. Reddy. Chalo. Arey, very less percentage are here also. Let's check why. The correct increasing order for bond angles between, sir, one is BF3. Sir, BF3 will be perfect trigonal planar, so bond angle will be 120 degree. Then, sir, I have PF3. So phosphorus will be having one lone pair and three bond pairs forming a triangle. But this angle, sir, I do not know what it is, but this theta will be definitely lesser than the tetrahedral angle, which is 109 degree 28 minute. What about ClF3, sir? Sir, it will be having two lone pair and three bond pair. That means steric number is 5. That means you should think of AB5, and for AB5 what we know, sir, lone pair will occupy equatorial position. So this is chlorine, one lone pair, another lone pair, giving more repulsion. So these axial bonds will also be tilted, and I have fluorine over here. If it was not tilted, then the angle was 90 degree. Now it will be even lesser than 90 degree. So who you are asked about the bond angle. So sir, here bond angle will be even, this theta is even lesser than 90 degree. So who is having least angle? Sir, ClF3. After that, sir, PF3, and highest will be BF3. So definitely a doable question, beta. But yes, you have to be vigilant with the VSEPR theory. I hope everybody is clear. I hope everybody is clear. Chalo, perfect. Good, guys. Chalo, moving forward. Good one. Attempt this one too. 30 seconds. Quick. Quick. The correct order of dipole moment for molecules NH3, H2S, methane, and HF. Now it is asking about the bond dipole moment, sir. Dipole moment is a property of charge. Obviously, we know fluorine is highest electronegative. So this is minus and this is plus. it is a vector quantity directed from positive to negative. So definitely this is not getting cancelled also. So this is perfect. Sir, CH4 will be having this, although polarity of C bond H is very less, although but you even if you consider that polarity, sir, this is a symmetrical molecule. So mu net as a net dipole moment vector will be getting cancelled, and individually the C bond H polarity is also negligible, and even if you are having anything, it will be cancelled. H2S, sulfur is a sulfur will form a bent shaped molecule because of the presence of two lone pairs. So among hydrogen and sulfur, sir, obviously sulfur is electronegative. So this will be like this, but yes, sir, ultimately it will be getting added. It will be getting added. It will be getting added. But if you just compare this with fluorine, sir, then polarity, sir, fluorine is highest electronegative. So the magnitude of this minus is quite large. And over here, obviously sulfur is definitely a polar molecule, but the delta negativity will not be comparable with fluorine. Although it is not cancelled also, its Y component will be getting added, but at least X component will be getting cancelled. Coming to ammonia, the same happening will be there here also. Sir, ammonia is definitely a polar molecule, sir. What about polarity? So this plus minus, this plus minus, this plus minus, and because of lone pair also. But ultimately here also, sir, you are not seeing fluorine is also having its lone pair. Fluorine will also be having its three lone pairs, and those will also be directed over there. So because fluorine is most electronegative, that's why I'm not getting cancelled also. So I will say HF will have highest, then ammonia, then H2S, because of mere electronegativity of the central atom attached. That means for this particular question, option D 4 will be your right answer. 72% are correct. I hope now everybody got that. Moving to the next one. Good one. This is a J mains question, I guess. So kindly attempt, beta. Now, again, beta, please make sure you're reading it properly. The correct order. The correct order. The correct order against the property mentioned. So, water, ammonia, and chloroform. About that dipole moment. Sir, you have already told us oxygen being most electronegative, highly polar. Ammonia, yes sir, less, because oxygen is more electronegative, so dipole moment vector, the magnitude of charge will be more. And yes, chloroform is also polar. Chloroform is also polar because this is, although a symmetrical molecule, but sir, all the bonds are not equal, so the net vector will not be getting cancelled. So yes, dipole moment is definitely is in correct order, so that means A is correct. A is correct. I have not checked B, so let us check B. XeF4, Xe, and number of lone pair or central atom. Okay, so this guy will have two lone pairs. This guy will just have one lone pair because each oxygen will employ 2 electrons, so 6 utilized. And this guy only 2, that means it will be having 3 lone pairs. So this is having maximum lone pair, so this is definitely incorrect. So 2 options are gone. Now you just have to check D and C. So let us check C. OH, CH and NO. Sir, H is obviously smallest. And sir, hydrogen, is a first period element, sir, and it is saying bond length. Sir, definitely it is incorrect, sir, because if you have hydrogen, sir, the bond length of hydrogen, the hydrogen is a first period element, sir, and down the group size increases like anything. So obviously that will be yes. If you are going to make it correct, then keeping hydrogen as constant, along the period size decreases. So O bond H will be least, then you have C bond H, and highest will be N bond O. Obviously that is incorrect. That means this is also gone. That means option A is your right answer, where you have to compare the bond enthalpy. How to compare the bond enthalpy? Sir, bond order, you do not even have to apply molecular orbital theory. For nitrogen it is N triple bond N. For oxygen it is O double bond O. For hydrogen it is H single bond H. I hope everybody's done with this too. That means A is our right answer. 68%. Fair enough. Fair enough. Moving to the questions from molecular orbital theory. You should obviously know for oxygen or for fluorine what configuration we follow. So sigma 1s, sigma asterisk 1s, sigma 2s, sigma asterisk 2s. So then we fill, after this for oxygen we fill sigma 2pz and then pi 2px, pi 2py. But once intermixing happens, when intermixing happen, when the nucleus is not that strong, and if it is not that strong, that is for lighter elements like nitrogen and even the elements which are lesser heavy than nitrogen. For them the molecular orbital diagram reverses. Because of intermixing, pi 2px and pi 2py is filled first, then you fill sigma 2pz, then you fill the anti-bonding molecular orbital, which is pi asterisk 2px, both energy are equal, pi asterisk 2py, and at last you fill sigma asterisk 2pz, because NCERT considers z axis to be the internuclear axis. So that means for nitrogen, option 2 is definitely a right answer. So I hope you now remember the basic MOT from which definitely you are going to land one question. So try and attempt this one, beta. Quick. Which one of the following pair of species have the same bond order? So you are asked about the bond order, and you are asked that which of the following pair of species have same bond order. Sir, if you just have to compare the bond order, sometimes even you do not have to apply molecular orbital theory. Just apply VBT. Sir, what is carbon monoxide, CO? Sir, C double bond O. This oxygen is having lone pair. It will be coordinating to this. So bond order is 3. What about cyanide ions as C triple bond N? This nitrogen will be having excess electrons. So octet is complete here also, here also. Bond order 3, 3 both sides. But yes, sir, then we have to, but sir, if not, then we have to check by MOT. Yes. If we have to check by MOT, yes. But beta, it will require time. So at least have a good view on the option and then try to apply MOT. Rather directly applying MOT will obviously make require more time, beta. So first have a healthy view on the options also. So I hope this one becomes very easy without applying MOT, but I can see students mentioning A and C as well. I hope everybody is clear now. Chalo, great. Moving to the next one. Quick. Match list 1 with list 2. The question says psi, which is the eigenfunction, which is how you represent the interaction between molecular orbitals. So psi of molecular orbital is psi A minus psi B. So if you have a molecular orbital, you do not know, it can be a bonding molecular orbital, it can be an anti-bonding molecular orbital. But if it is resulting from destructive interference, that means the wave function of combining atomic orbitals are getting subtracted. That means it is a destructive overlapping. So what type of molecular orbital you are going to obtain? Sort of high energy, less stability. So that means this is anti-bonding molecular orbital net wave interaction. So definitely that means A is 3. So all the options are saying A is 3. So now what about B, sir? It is mentioning about the dipole moment, because we know it is charge into distance between charge. That means this is dipole moment. So this is calculation of bond order. Once you fill those electrons, how to calculate bond order? Sir, bond order of any molecule is number of electrons in bonding atomic molecular orbitals minus anti-bonding molecular orbitals. So this clearly represents bond order. That means it is 4. And sir, if wave functions are added, then bonding molecular orbital is formed. So definitely that lands you with C as your answer. 75%. So see, they are just asking about the NCERT basics, whether you are confident with it or not. Moving to the next one. During the change O2 to O2 minus, the incoming electron goes to the orbital. When O2 is becoming O2 minus, then where the incoming electron is going? Sir, oxygen has two unpaired electrons, where we have already done that electronic configuration. So sigma 1s, sigma stic 1 is done, sigma 2s, sigma stic 2 is done. So sir, 8 gone. After 8, sir, pi 2px, pi 2py, no, oxygen, so sigma. So after that, it will be sigma 2pz. This will be sigma 2pz. After that, I'll be having pi 2px and pi 2py. So this becomes 10. So this will be 11, 12. This will be 13. This will be 14. After that, I will be having this 15th and 16th electron, which will be filled in pi stic 2px and pi stic 2py. Now, if you're going to allow one more electron to enter, then the 17th electron will enter here in the pi stic orbital. So it will be entering. Acha, it is also saying pi, it is also saying pi. So one should be pi stic beta. So make it pi stic. This is typo error. Chalo, yes, my bad. Options were not written properly, but I hope now you know the logic. Moving to the next one. Quick. Now, the question says given below are two statements. Okay, sir. Hypothetical diatomic molecule with bond order 0 is quite stable. Sir, if bond order is 0, molecule cannot even exist, sir. So that means this is definitely false, sir. As bond order increases, bond length increases. No, sir. As bond order increases, bond length decreases. Sir, they are inversely proportional. So that means this is also incorrect. So both statements are false. That means option Bombay is your right answer. Less percentage. I hope, guys, you are confident now. Moving to the next one. Yes. Time starts in 3, 2, 1. Go. Quick. Select the compound from the following that will show intramolecular hydrogen bonding. Sir, in chemical bonding, we learn about intermolecular forces also. So intermolecular forces, the strongest intermolecular force is hydrogen bond. Hydrogen bond is applicable in case of fluorine bonded hydrogen, oxygen bonded hydrogen, nitrogen bonded hydrogen only. And so hydrogen can be intermolecular also intramolecular. Intramolecular hydrogen bonding is only applicable. Intramolecular hydrogen bonding is only applicable when you are forming at least 5 to 6 membered ring structure, because as we have done in GOC, 6-membered ring structure is free from any type of angle strain. Hence, this ortho substituted phenol will definitely be having this N, coordinated bond O, double bonded O, this O with an H. So they will be clearly attracting each other via intramolecular hydrogen bonding. That makes Delhi as your right answer. 81%, fair enough. Moving to the last question for chemical bonding. Moving to the last question from chemical bonding. Then we are done with chemical bonding as well. We have discussed the quite relevant questions of bonding and periodic table. So, good. Acha, I have not started the poll. So if not started, so be it. Okay, let me start and do it together. Chalo. Now, the correct order of covalent nature you have to give, sir. So what is the first option? Sir, KF, KI. So let us compare KF and KI. Sir, that means this is just a simple application of Fazan's rule. What does Fazan's rule say? The covalent nature of an ionic compound increases with what? Sir, small cation. Sir, large anion. And before that, you should first check the charge, because charge being the most dominant factor. More be the charge, more will be the covalent nature. More dominant factor. And if these are also tied, then definitely you can say, because for D block the Z effective is large enough, so large Z effective will give high polarization power. That is, charge upon size is nothing but polarization power of cation. So D block cation are obviously more covalent than S or P block cation, but this is valid for cations. So these are some basic Fazan's rule application which you should know. If you apply that, here cation is same. So I is a large anion, so it will be more covalent. So no, sir, Kf is not more covalent, Ki is more covalent. So Ki is more covalent, so this is wrong. Ki is more covalent, so this is right. Ki is more covalent, so this is also wrong. Here Ki is not there. So but with this we have eliminated option A and Delhi. So wherever I have A or Delhi, it is gone. Only A is there. Now after this, sir, we have to check B already. So check C and E. So either check C or E. So let us check C. Where is E? I don't find E anywhere. I guess E will not be there because I don't see E here. So let us remove E, because although maybe it will be a typo error, but because we don't find E, so let us remove E and then draw it. So let us check C then. So sir, here charge is +4, here charge is +2. So yes, sir, this will be more covalent. What about this? Sir, D block cation is more covalent, sir. So C is definitely correct. So let us check this B. Sir, here anions are same. So cation, smaller cation is more covalent, sir. So this is also correct. So Bombay is also correct and C is also correct. So option 2 is your correct answer. Yes, a definitely probable question for Fazan's rule application, because as covalent nature increases, ionic nature decreases. What does an ionic compound has as its properties? Are more melting point, more boiling point, more solubility in water. So as ionic nature increases, these properties will also increase, and you can definitely check these properties using Fazan's rule. Chalo, fair enough. Now beta, this is a 112. Now what chapter you want me to start? Shall we start with class 11th now? Because I guess let us explore this with this rhythm only, that we have done periodic table, chemical bonding, we have done GOC. So let us finish some physical chemistry also of class 11th. Let us finish that mole and redox. Mole and redox. Shall we start mole and redox after this? Chalo. So first let me just save these lecture notes for you, because I have already exceeded 75 slides, and yes, my teaching panel gets hanged. So let me save these slides for you, and then we'll be starting with mole and redox. But yes, after having, let us take a 15 minutes break. So let us take a 15 minutes break, and post this break, what we have done till now, sir, we have done GOC, sir, we have done periodic table, sir, we have done chemical bonding. Now these three chapters we have done, and after this we will be starting with mole plus redox, because they will be obviously bridging a confidence for the physical chemistry also. Okay, so but a 15-minute break, so this is, let us consider 1:15. So we will now meet at 1:30. Cool. Chalo, we will meet at 1:30. So bye. Come back at 1:30 after having a lunch. Only 15 minutes break. That's it. Chalo, bye bye. Yes. Good evening, afternoon. I always make this error of wishing the wrong time stamps, wrong time duration. So, good afternoon again. I hope everybody had their lunch in the break time. I definitely had, and I regret for being 8 minutes late because I guess I said 1:30 and rather I took 8 more minutes. Chalo. So let's start. I mean, the extra 3 minutes, no, you required for the notes because definitely as promised, beta, once I just have, I was going out for the lunch. I have seen the comments that where we'll be getting these notes, beta. I'm again announcing you will be getting all these notes from where? Just after the live beta, we will be downloading all these lecture notes at PW NEET English WhatsApp channel. So once the live is done, please go to PW NEET English channel and you will be getting these notes for download. Okay, chalo. So let's start beta, sir. Then we will be starting with physical chemistry area. What physical chemistry area we are going to discuss, sir? Mole concept, redox reaction, and then we'll be adding a few good questions of atomic structure also. So then we'll be finishing that area of physical chemistry, the class 11th area, and after that we'll be doing that equilibrium, chemical ionic equilibrium, thermodynamics. Cool, chalo, perfect. So from this, from the afternoon, we are starting with the physical area. So the first question, in order to best attempt giving, because it's a physical chemistry question beta, so giving you 1 minute, but yes, obviously I will be attempting this with you. So take out your pen and copy and start attempting with me now. Perfect. Chalo, hi beta. uh, okay, perfect. So chalo, now let's start. So the first question is from physical. The first question from mole concept says that 1 mole of atom X has mass, sometimes mass of 1 mole, or 1 mole of atom Y. Sir, what is mass of 1 mole? Beta, mass of 1 mole is the molar mass. So molar mass of atom X, let's say molar mass of atom X is 0.444 times molar mass of atom Y. This is the first statement that we have. Second statement says atomic mass of X is this much times the mass of one atom of C12 isotope. So now it is discussing about atomic mass. So atomic mass of X, it is saying, is this much times of mass of one atom of C12. So sir, first of all, what is mass of 1 mole atom? Beta, mass of 1 mole atom will be 12 gram. So as in mass of Na atoms of carbon 12 isotope will be 12 gram. So mass of one atom will be, sir, 12 upon Na grams. So this is how you will be having the mass in gram. So that means into, this is mass of one atom of C12. So that is 12 upon Na grams. So technically I have atomic mass but in form of gram and Na. I have atomic mass in form of gram and Na. Can I convert this? Sir, if I have atomic mass of, that is, this is mass of one atom of X. So can you tell me mass of 1 mole of atom? Sir, that we already know is mx. So mass of 1 mole Ax will be, sir, 1 is having this much of mass, so 1 mole will be having into Na. So that will give you directly mass of X will be Na into value of Ax. Sir, just multiply this, so Na and Na will be getting cancelled. So this is 2.96 into 12 gram. This is the molar mass of X. Now, sir, I already have molar mass of X is equal to 0.444 times molar mass of Y. And sir, this is mass of 1 mole. So what will be mass of one atom? Sir, it will be Na into atomic mass of Y. Let's say atomic mass of Y is Ay. And in the question, you just have to give atomic mass of Y only. That means I need this value. So value of atomic mass of Y will be nothing but 2.96 into 12 gram upon 0.444 upon Na, because that Na will also come. Now, what unit I have, sir? We have to report atomic mass in AMU. AMU is just 1 U, and we know, sir, 1 gram is nothing but 1 Na into 1 U, or rather AMU. This AMU is previous convention. These days we term AMU as unified mass. So that means, sir, you can definitely replace this ratio, because 1 gram upon 1 Na is nothing but 1 U, rather that 1 AMU. That means this is nothing but U. You just have to do the multiplication now. So 12 into, let's say, 3. So 12 into 3 is 36. This is approximately more, let's say 0.5, so 1 by 2. So double of 36 is 72, or maybe more. So what option you have more than 72? Option A. Yes, you can definitely calculate also, but the common sense will definitely give you an idea. I hope everybody is clear. Now I want confidence, beta. I want confidence that I am actually helping people around. So just whoever is there with pen and copy with me, just write in the comment section that yes, 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 it is clear. Because at least even if I'm able to help one, my job is done. Ah, yes. Thank you, Ayu. Thank you. Because I just had my lunch, so I'm thinking even you people are having, because I can see the live watching has also dropped. Chalo, so at least I got one confirmation. I was actually expecting more. Ha, chalo, Harshit, good. Yes, Chaitanya. Then perfect, Harshit. Chalo, beta. Cool, perfect. Moving to the next one. Moving to the next one. Yes, attempt this one, beta. Attempt this one. Acha, let me check how many of you. The answer was B, I guess. Less percentage. So fair enough. I hope that discussion helped. So moving to this question, and your time starts now. Now, what does this question says? The question is telling us that which one of the following pair of gases contain same number of same number of molecules. So now again, there are basic three number of moles formula. First one is given weight upon molar mass. Second one is given number of species upon Avogadro's number. And third one is volume occupied by gases upon molar volume, which is generally 22.4, or rather 22.7, depends what standard pressure you are taking, 1 atm or 1 bar. Now but yes, that number of moles calculation can only be applied for gases, that too at STP. Now here we just have to calculate number of moles. So number of moles applying formula as weight upon molar mass. So number of moles, but sir, it is not asking about moles, it is asking molecules. Beta, number of moles is also equal to number of molecules upon Na. So Na is a constant. So if I have same moles, I will be having same number of molecules also, proportionality. So let us calculate for oxygen. So this is 16 upon 32. That means it is half moles. This is 14 upon 28. That means this is also half mole. So you do not have to check all the options. Just calculate number of moles, and that definitely gives you an answer. I hope most of you have attempted this as well. 70%. Fair enough. Great. Moving to the yes, attempt this one. Attempt this one, giving 45 seconds for this, not 1 minute. Attempt this one. If mass of one atom is this is mass of one atom, mind you, then you have to calculate number of nucleons. What are nucleons? The nucleons are number of protons and neutrons present in what? Then you have to calculate number of neutrons present in two atoms of element. So let us calculate for one first. So mass of one atom is this. Sir, what is mass? Beta, mass is nothing but summation of protons and neutrons approximately. Because yes, you have to add those electrons also, but sir, mass of electron is nothing in comparison to proton and neutron, so why bother? So that's why if the question is saying that an atom is having this much of gram, one atom, that means one atom, whatever number of protons and neutrons it is having, must be having this much of weight. Okay sir, then you tell me how many number it will be having. Let's say, sir, I do not know, and mass of protons and mass of neutrons are also approximately same, sir. So let us say it is having what number of nucleons? Let's say it is having n number of nucleons. So one atom having n nucleons, what is, sir, nucleon is proton and neutron, both masses are same, so total number let's say is n. Now after this n, sir, you have to multiply with the mass also of either proton or neutron, which is approximately same you're saying, which is approximately 1.6667 into 10 raised to the power minus 24 gram. And this total mass of an atom is given out to be 3.32 into 10 raised to the power minus 23. Rather, to ease my calculation, let me do 33 into 10 to the power minus 24, because this will be then cancelled. Now, this is in gram only. So this gram and gram is cancelled. Now, so that means number of nucleons, this is number of nucleons in one atom, because here we are discussing only for one atom, is nothing but 33.2 upon what, sir? Upon this denominator, which is 1.6. Obviously, now you have to do that into divide. So just do that multiplication, what you are getting. Let me do this for you, because options are also 33.2 upon 1.66. Beta, it will come out to be 20. It will come out to be 20. It will come out to be 20. Please do the calculation very righteously. And sir, if one atom is having 20 nucleons, then 2 will have what? Beta, 2 will have 40. So that will definitely give you your answer as option A. Chalo, perfect, perfect. Harshit, are you perfect? Moving forward. Next question says, yes, these type of questions are also probable beta. So take 45 seconds to attempt this as well. You have to calculate minimum molar mass. Now, how shall you calculate minimum molar mass? Some minimum molar mass can easily be calculated using, you just take atomicity of whatever species they are given, just take atomicity as 1. So if that atomicity is 1, then definitely you can have whatever mass of the molecule that you will be having will be 1 only, will be minimum only. Cool. Chalo. So the question says a compound has hemoglobin like structure, whatever be its molecular formula. It has 1 Fe. It is also telling you it is 1. It contains 5.6% of Fe, then the approximate molecular mass will be. So this is just then into divide after you have properly mentioned your mathematical equation. So let us formulate that mathematical equation, which will be nothing but weight of Fe upon weight of the compound, which is molecular mass, into 100. So this is given out to be 5.6%. Atomic mass of Fe is what, sir? It is because it is written 5.6, so let us take 56 only, because obviously it is around that only. So this is 56 into 1 upon molar mass into 100 is 5.6. Sir, it is getting cancelled also. This will be 10. So 56 gone. So what is molar mass? Beta, molar mass will be, you just have 100 and this 10 will be divided, multiplied. So this, sir, not even any calculation. So because molar mass will be 1000 gram or molecular mass will be 1000 U. So obviously 1000 is your value. So I hope everybody is clear with this too. Perfect. Percentage is less, but I guess people are confident now. Chalo. Yes. Coming to stoichiometry type of questions, because those type of questions are also very relevant. So coming to stoichiometry types of question, this question says just have a look and have an attempt of the stoichiometry. Quick, quick. D. Superstar is back. Chalo, D. Shivam is also saying D. Chalo, let's check. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. A classic reaction, hydrogen will react with nitrogen to produce ammonia. If you try to balance this, I just need a 2 over here. So number of moles of hydrogen required, let's say N, to produce, okay, I have to balance this, so I need a 3 over here, and this will definitely be 1. Now, to produce 20 moles of ammonia, so I need 20 moles. Sir, this is very easy, sir. So 3 will create 2. So if you need 20, rather you take 30. Sir, nothing. But yes, beta, such nothing concepts also sometimes find application in your examination. But yes, if you're feeling this is nothing, then good. That means you're confident with your content. Moving to the next one. The question says, the right option for the mass of CO2 produced by heating 20 gram of 20% pure limestone. Now you have to do some mathematics as well. So let's say, attempt this beta, guys, quick. The reaction is also written, calcium carbonate giving CO and CO2. So you have to give mass of CO2 produced by heating 20 gram of 20% pure. So you're heating 20 gram, but out of that 20 gram, only 20% is pure. So what is number of moles you have taken? So 20 upon molecular mass of limestone, which is calcium carbonate. So if you calculate for calcium carbonate, I hope most of you should remember also, because this is very famous. It is 100. How? Sir, 40 plus 12 plus 16 into 3 is 48. That means this is nothing but 1 by 5 moles. Now, whatever moles of limestone you have, is all limestone pure, or it is impurity? Sir, it will be impurity. So how much of this is pure? Or rather you can, you don't calculate moles, or rather one option will be directly to calculate using weight. How, sir? If you had, because you are not confident that out of that 20 gram, 20%, so you should just do the mole calculation for that 20%. So rather just calculate in terms of weight only. Like what? If you had 100 gram of this, how much CO2 you will be getting? 1 mole. So 1 mole is 44 gram. So just think of that stoichiometry in the head. So 100 gram will be giving me 44 gram. So 1 gram of limestone will be giving you 44 upon 100 gram of CO2. So how much limestone you have? So now just calculate 20% of 20 gram. You do not have to calculate moles that ways. So 20% of 20 gram will be 20 into 0.2, which is nothing but decimal gone, so which is nothing but 4 gram. So if 1 gram is having this much of, this will give this much of CO2, so 4 will give the 44 into 4 upon 100 gram of CO2. And yes, you just have to give this only. So what this data will be, beta, I will be having this much of weight na. So just calculate this in that case. 1 gram will give this much, 20 gram, but 20%, 20 by 100 is 0.2. So decimal gone, so this is 4 gram. 100 gram of this is giving me 44 grams, so 1 gram will give 44 upon 100. Yes. So just calculate this beta. 4, 4 is 16, carry over 1, 4, 4, 16 and 17, divide by 100. So 1.76 gram. You have options also. So yes, this will be your correct answer. Yes, Neha Superstar has definitely answered perfectly. Moving to moving to the concept of limiting reagent now. Moving to the concept of limiting reagent now. So attempt this one, which will help you to understand concept of limiting reagent also and percentage yield also. So mixture of both the questions. Please try. Quick, quick. B. Perfect. Perfect. Now Manish is also saying B. Perfect. Chalo, let's try beta. The question says you have to find the number of moles of C formed when 20 mole of A, reaction is here, 20 mole of A is reacting with excess of B. Okay, so this is not using concept of limiting reagent that ways because one reactant is in excess. So sir, just do the stoichiometry. 2 will be forming 3, so 20 will be forming 30, but it will be forming 30 when efficiency was 100%. As of now, efficiency is 80%, so 0.8, as in 8 into 3 is 24, so you will be producing 24. So this is just application of percentage yield, but yes, there is no concept of limiting reagent for this particular question. So I hope, let me find a limiting reagent question. Yes, attempt this one beta. Attempt this one. This will definitely allow you to have an idea for calculation of limiting reagent. Attempt this one. Quick, quick. Chalo. People are saying, acha, Sonam Yadav said A. Chalo, let's check. 12 moles of A and B each are allowed to react. Okay, sir. That means I have 12 moles of this, 12 moles of this. Now the question is telling me if 60 gram of D is produced, if 60 gram of D, so I have weight of D which is 60 gram, then you have to give the atomic mass of D. Sir, just do the stoichiometry. So 3 moles will require 2 moles. So 1 will require 2 by 3. So 12 will require, so 3 requires 2. So 1 will require 2 by 3. So 12 will require into 12. That means I need 8 moles. So for this, I have 12, but I only need 8 moles. Sir, it is present in excess. So this is my excess reagent, which makes A as my limiting reagent. So who decides the product? Sir, limiting reagent. So whose stoichiometry I shall use? Sir, of A. That means I will say 3 moles of A will be producing half moles of D. So 1 mole will be producing 1 by 1 by 6 moles of D. So ultimately, how much moles of A I'm trying to react? Sir, 12 moles. So how much moles of D will be produced, sir? Into 12, as in 2 moles of D will be produced. Now, if 2 moles of D has been produced, so what will be the weight, sir? Sir, weight is given, sir, 60 upon, sir, you should divide by the atomic mass, and that atomic mass we have to calculate. So let's say that value is D. So this D is clearly 30 rupees, which I guess most of you have answered correctly. Nahi. People have answered 60 beta. I hope guys it is clear. I hope guys it is clear, because it will be 30 na. People have answered C. So that's why I'm iterating again. Chalo, moving to reactant left and how much. So this was a question I was searching for. So limiting reagent question. Come on, do it. I have been searching for a limiting reagent question since 2 questions, but yes, now we have got one. So please attempt this limiting reagent logic. Quick. 1 gram of magnesium is burnt with oxygen. Which reactant is left in excess and how much? You have to check how much of excess reagent have been left unreacted. Cool. So what will be the reaction, sir? Reaction will be magnesium reacting with oxygen, forming magnesium oxide. In order to balance, I will just put half over here. So that means I have my reaction with me. So how much of magnesium I have? Sir, 1 upon 24. I'm directly writing moles given weight upon atomic mass. How much oxygen I have? Sir, 0.56 upon 32. So these are my moles. For 1, I require half. So for 1 by 24, I'll be requiring 1 by 12. So 1 requiring half. So 1 by 24 will be requiring how much of oxygen? Sir, 1 by 24 upon 2. So this much moles I require. And how much moles I have? So yes, you just have to some basic calculations you have to do, beta. So these are my moles required for O2 and these are my moles given. So just let me help you with the calculation. I guess you guys are calculating at your end. Let me just confirm that calculation for you. So the first data given is 0.175. This data is 0.175 and this is 0.02 something. So technically, sir, given amount is much more, sir, and this amount is the actual required amount is very less, sir. Given amount is much more and required amount is this given amount is very more, sir. That means this is excess, sir. Because how much I require? Negligibly small. So because that is an excess, so this is my limiting reagent. Now, if this is my limiting reagent, then what are we supposed to tell? That which reactant is left. So what is my excess reagents are obviously, are we doing some calculation error or what? Magnesium. 1 gram magnesium is burnt with 0.56. Okay, haven't I taken 0.56 into consideration or what? Let me check again. 0.056. 0.56 divided by 32. Okay, I'm sorry, beta. This is actually, this data is actually 0.0175. I'm sorry, there was a 0. So that means, sir, what I am given with 0.2, what I'm given with less, what I require is more. I require more of this, and whatever this is given is less. I guess beta there is a printing error in this. Because logic says you just have to calculate. Yes, I guess there is some error in the data. Has anybody done, sir? 0.16. What is this data beta? Have you calculated this? This is 0.0175. Chalo. Let me just give you an idea about it. The idea says 1 gram of 1 mole of this will require half mole of this. So if what is the weight for magnesium that is given to us? 1 gram. So this is my moles. So 1 mole will require half mole of this. So how much moles I have? 1 by 24. So how much moles will be required? Sir, 1 by 24 into half. So calculate these moles and calculate these moles. I guess there is some data error in this. Most of the students are saying A. Okay. So technically beta, given whatever amount is given to is this much. How much amount you require? Sir, you require more of the amount. Sir, it is not given. I require more of oxygen. So technically given data is less, na? So if given data is less, then this should be your limiting reagent. Then this should be your, because whatever is given is less. Whatever you require to react 1 by 24 is more. So technically your limiting reagent should change. People are answering A. That means you must have Sir A. Chalo beta. So I hope you have got your answer. But yes, I feel this data is irrelevant. So because people are answering, so let me move forward. I hope you have an idea that whenever you need to calculate, you have to calculate in a better way. And once the given data is more, then that becomes your excess reagent. And what product is produced? A product is always produced in accordance with limiting reagent. Acha, IU is helping me now. Sir, 0. Okay, that means I am doing some calculation error, so be it. Chalo, moving to the next one because we can't invest much of time in a question. So moving to the next one. Time starts in 3, 2, 1, go. Quick. Chalo. Maybe I was doing some calculation error with that. Yes, beta, only 4 days left. That's why even you are attempting question in an examination na beta, sometimes some data trickles you, they plays with you, so leave the question and move forward. If you do the same question with a fresh state of mind, sometimes some calculations you get stuck. So rather investing much of time in that, you should definitely move forward. Anna, chalo. Quickly moving forward, the question says what is concentration in ppm if this much gram of KCl is dissolved in 100 gram of water. Sir, parts per million can be weight by weight, volume by volume, or weight by volume. Obviously, we can calculate ppm by what? Sir, weight of solute upon weight of solution into 10 raised to the power 6 will give you ppm. Now, sir, what is weight of solute? It is 25 into 10 raised to the power minus 3 because this is 0.25 upon what is weight of solution. Sir, this is 100 gram and this is technically solution is solvent plus solute. So let's say solvent I'm mentioning as 1 and solute I'm mentioning as 2. This should be weight of solution. But sir, if solute is very less, then mathematically if you add or you do not add, hardly it will matter because 100 gram compared with 0.025 is negligible. So approximately writing this also as 100 into 10 raised to the power 6. So that means this is this will make minus 5. So this becomes minus 5. That means this is nothing but 10. So your answer is 250. So these are the concentration terms. 62% has done this correctly. So these are some concentration terms which you should definitely invest your focus and attention on. Attempt this one, beta. Attempt this one. Time starts now. Then you should know concentration terms definition, and apart from knowing their definition, you should also know the interrelation because many times these question comes. Cool. Chalo. Chalo. 4D. Chalo, let us attempt. Mole fraction of solvent in aqueous solution of NaOH having molality 3. So beta, actually concentration term do not depend upon the amount. Concentration term do not depends upon the amount. That's why whatever data you are given with, you can just take that data and consider your solution, which will help you. Molality is given out to be 3. Sir, molality is number of moles of solute upon weight of solvent in kg. So let us assume I have 1000 gram as in 1 kg of solvent. Why? If you have 1 kg of solvent, that means in that 1 kg of solvent, what is the number of moles of solute? 3. So that's why, but now you will do all the calculation for this 1 kg solvent having 3 moles of solute, because concentration of that will remain the same. But do the calculation for that now. Now what I have to calculate for that particular solution? Sir, mole fraction of solvent. Sir, solvent you already assumed. So number of moles of mole fraction of solvent as an x1 will be number of moles of 1 upon number of moles of 1 plus number of moles of 2. What is mole fraction, number of moles of solvent, sir? Sir, 1000 upon 18. This is number of moles of solvent upon 1000 upon 18 plus what is number of moles of solute? Sir, 3. So now you can just have that calculation, or you can even see, sir, this 3 rupees, this is 55. So 55 upon approximately more than 55. So sir, it will be very, very less than 1, sir. So what option you have very, very less than 1? Sir, option 4. Yes, you can definitely calculate also, but yes. Acha, there is one more, let me check the percentage. There is one more interrelationship, and rather this is not the time for that derivation, but yes, this is rather a best time. This is rather a best time to learn these conclusions, that molality with mole fraction is related as x2 into 1000 upon x1 m1. Please sir, then I can write this x2 as 1 minus x1. So without doing anything, I can clearly calculate answer directly. But yes, so let me just give you a brief about this, so that whoever is not even confident can come up to this conclusion and can remember it during for a longer duration of time, at least till 21st of your June. So sir, molality you have already told us is number of moles of solute upon weight of solvent. Now number of moles of solute upon weight of solvent. So sir, how can you write weight of solvent as moles of solvent? Weight of solvent will be equal to moles of solvent into molar mass of solvent. Now what you can just do mathematically is, sir, n1 plus n2 if you divide both ways. But sir, this weight is in kg. Here you have taken weight in grams, so you need 1000 in the numerator. Now definitely everybody can see, sir, this is nothing but mole fraction of solute. This is nothing but mole fraction of solvent. So see, x2 into 1000, x2 into 1000 upon x1 m1, x1 m1. So this will also have an idea to remember and learn these interrelationship for a longer duration of time. I hope everybody is clear. Chalo, perfect. Next question. Yes. Next question. Yes. Yes, attempt this one. These interrelationships, beta, are not important. They are hugely important. Hugely important. Because definitely on the basis of these interrelations, you are definitely going to land one question. 100%. Chalo. Okay. B. Gaurav Humar is saying B for, okay, B for BMW. Now, sir, aqueous solution of solute X, molar mass is given, has density this much. So this is density of solution in gram per ml or gram per cc. If molality of solution is 3 molar, that means I know molality, I need to calculate molarity of solution. How it is related, sir? Beta, density of solution is nothing but molarity. Please remember this interconversion. Density is equal to molarity into 1 upon molality plus molar mass of solute upon 1000. Now, if you just put the data, you will be getting Bombay, because most of the students have calculated also 100%. But beta, very important conclusion in NCERT example. So obviously you can understand why NCERT examples and these stuff are not important. They are hugely important. Chalo. Moving to some areas of redox reaction. So after mole, for mole you should learn concentration terms, you should know stoichiometry, you should know how to calculate limiting reagent, the question where we stuck, but you must have 100% of you have selected the correct option. So do the calculation religiously, and then you should mix mole concept with redox reaction. How, sir? We'll be seeing this. Now the question says, now the question says the conversion of potassium dichromate to potassium chromate, the oxidation state of chromium. So let's say it is changing or whatnot. Sir, how to calculate oxidation state? You should know the formula to assign oxidation state or calculate oxidation state. So potassium is alkali metal, so remain +1 state because I have 2, so 2x +2. I do not know state of chromium, so let's say it's x, so it becomes 2x minus 7 2 ja 14 equals 0. That means that here chromium is in +6 state. What about chromium over here, sir? +2 plus x minus 8 equals 0. That means here also it is in +6 oxidation state. So this is not a redox change, sir. Here oxidation state is just the same. So yes, some students may have been tricked. Yes, half of you have been tricked. Half of you have been tricked. The oxidation state is just the same. It is not getting changed, my friends. Moving to a theoretical question from the chapter of periodicity only. Here you just have to give the oxidation state of oxygen atom in potassium superoxide. Actually, um, technically, lithium being very small, it forms oxide. Sodium being relatively larger in size, sodium cation, it forms peroxide, and remaining alkali metal forms superoxide, because these oxides, peroxides and superoxides are solid, and you are supposed to form a better solid when the cation and anion are of comparable size. Hence definitely potassium forms a superoxide, which is potassium is definitely in +1 oxidation state. But this O2, what is oxide? Sir, oxide is oxygen with 2 minus. What is peroxide? Sir, when you have molecular oxygen taking 2 electrons, as in both the oxygen are present in -1 oxidation state. This is my peroxide. And what is superoxide? When molecular oxygen carries only 1 negative charge. That means, sir, this O2 is having -1. So formula of superoxide will be KO2. But you should definitely know this 2 is not the charge of potassium, because potassium is an alkali metal. That means O2 is having -1. So for one oxygen atom, you are having how much of charge, sir? -half. So attempt this one. Quick. Attempt this one. Attempt this one. Quick. Chalo. The question says, the reaction of H2S and H2O2 giving this and this shows. So, sir, here oxygen is going from -1 oxidation state to -2 oxidation state. That means, sir, H2O2 oxidation state is getting decreased, so it is getting reduced, then definitely somebody will be oxidizing. Yes, sulfur from -2 oxidation state is increasing to 0 oxidation state. So this is oxidation. So in this question you are asked, sir, because this is itself getting reduced, so acting as an oxidizing agent. So oxidizing action of H2O2, yes. Reducing, no. Alkaline nature, no. Acidic nature, no. So option is definitely 1 for us. 85%. Great. Moving to the next one. Yes. You have to balance this reaction. Again, not a question, but yes, you should at least have an idea of how to balance. Sir, I have permanganate ion, which is nothing but MnO4 minus. In basic medium, it oxidizes iodide ion as an I minus ion. To produce molecular iodine, so I minus is changed to I2 and MnO4 minus is changing to MnO2. Now you have to write a balanced reaction. How to write this balanced reaction? Sir, you can use oxidation number method, you can use ion electron method, both. Yes, definitely. Ion electron method is more prevalent because oxidation number method, maybe, just maybe, sometimes it will not give you the correct result. It can balance many reactions but not all. So that's why I always ask my student to at least know oxidation number, ion electron method also. In ion electron method, what we do, we write the two half reactions separately. Like this is the first half. Now first, balance all elements except oxygen and hydrogen. So manganese is balanced. Then in order to balance oxygen, add water. So I need 2 oxygen on the right side. Now to balance hydrogen, add H plus. Because medium is, question is saying basic. So what you do in basic medium, just do this much as you do in acidic medium. But because medium is basic, add equal number of OH minus ion on both sides. Because mathematically it will same. H plus and OH minus ion will definitely associate and form water. That will definitely simplify some water, and now you balance charge. So here I have -1, here I have -4, so I will add 3 electrons. Now, how to balance the second half? I guess this is much easier because I minus is getting to I2. There is no oxygen hydrogen, so adding 2 will just balance all the atoms, and adding 2 electrons will obviously balance the charge. If you add them, but sir, how can I add them? By equating the charge transfer. This guy is giving 2 electrons. This guy is taking 3 electrons. So multiply this with its equation, coefficient 2, and multiply the bottom reaction with above coefficient, that is 3. Then add and write the complete balanced reaction. So let me write the complete balanced reaction for you. First write LHS. So twice of MnO4 minus plus I have 4 times of water, the LHS from the first reaction, and plus 6 times of I minus. So LHS of both the reactions are done. Now RHS, so twice of MnO2 plus, sir, 8 OH minus plus thrice of I2. So I hope this will satisfy, or yes, definitely let me help you. Yes, let me help you with oxidation number method also. Let me help you with oxidation number method also. How to be that oxidation number method? Yes, sometimes it helps because it balances the reaction just with a single line. What is oxidation state of manganese? So oxidation state of manganese, X minus 8 equals -1. That is, it is +7. Over here, it is +4. So what is the charge transfer from this to this? So 7 to 4 as in 3 electrons. So this is going from -1 to 0. So transfer is 1. But sir, this is 1 manganese, this is 2. So I need 2 iodine. 1 is going from 1 to 0. So 2, I'm having 2. So 2 will need how many? So 2. Now again, you directly see that the charge transfer is not getting cancelled. So in order to equate or equalize the charge transfer, you will multiply 3 here and 2 here. So 3 of I2 will be formed, and 3 2 just 6 times of I minus will be required. Multiply this 2. So twice of they will be used and twice of they will be created. Now you balance charge. Now you balance, first you balance atoms, oxygen, hydrogen by adding water. So what amount of oxygen I'm having here? So 4. 4 into 2 is 8. Over here, sir, 2 into 2, 4. So how much oxygen is left, sir? Here I have 8, there I have 4. So I need 4 water. So I need 4 water. That means 2 into 2 is 4, and that 4 will definitely balance the oxygen. Now you need to balance charge. Sir, this is minus 2 and this is minus 6, so this is minus 8. So ultimately I need 8 OH minus to balance charge. Okay, so first if we only think of balancing the charge, then let us first balance charge, because I guess then oxygen will be unbalanced. So if we first balance charge, so this is minus 8 and this is 0, so add 8 OH minus. Now you add water. If everything is correct, now you add water and it will be cancelled. So how much hydrogen I'm having in the left hand side? 8. How much hydrogen I have over here? No. So just add 4 water, and if everything is correct, then oxygen will by the way be balanced. You can definitely check. These two are just the same. Some students feel, sir, oxidation number method is easy. I am not denying to that fact, because in oxidation number method you can directly use balance the complete reaction in a single line. But yes, I am definitely telling you, you should definitely know ion electron method also, because it will help you to do that number of gram equivalent calculation questions also. So I hope with this we can practice one question again for balancing of redox, and your time of 45 seconds start now. Quick, attempt this one, beta. Quick. Quick. B. 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 Chalo, let's check. Chalo. Perfect. Chalo, fair enough. I mean, you just have to do the same application and you will be definitely getting your answer, because, okay, let me just do this also for you. Medium is acidic. So, sir, manganese is in +8, sir. Here it is, okay, not +8 beta. I guess this will be MnO4 minus. Acha, okay, you must have seen MnO4 minus here. So this is +7, sir. +7 to +2, so change is 5 electrons. This is carbon, so 2x minus 8 equals -2, as in 2x is equal to 6, as in this is +3 going to +4. So change is definitely 1, but I have 2 carbons over here, so it will be multiplied by 2. Now, sir, it is asking for 5, but it is only providing 2. So in order to again balance the charge transfer, I need 5 of these. That means this will be 5. So, okay, that means this will be, I need 5 of these, no? So, so if you take, ultimately I have not balanced carbon first. If I will definitely multiply a 2. So after multiplying 5, this will become 5 and this will rather become 10. Now, what about this? So it has to be multiplied by 2. So this is a 2. This is also a 2. That means for manganese, I definitely, for MnO4 minus, I definitely know my coefficient 2. For Oxalate ion also, I know my coefficient, which is 5. Now I just need coefficient for H plus ion. Now atom is balanced, and after that we add H plus to balance charge. So here charge will be plus 4. Here charge will be minus 10 and minus 2, as in minus 12. So because I have minus 12 here, but I have plus 10 here. So what I have to do, plus 10, na? Yes. Sir, I need to have H plus ion. This is 12, that is 10. So how many H plus ion I will be requiring? Sir, first I need to do 10 plus, but first I have to neutralize this. So it is showing 16 H plus. MnO4 minus, C2O4 minus. So if I take 5 of these, then this is creating minus 10 and this is minus 2. So my plus 12 I need, but I need more to balance this. Oh, so you need how much? 4 more, because this is 2 into 2, 4. So this is plus 4. So I will be needing 16. Why? 12 to make this neutral and plus 4 to make it 16. So 16 electrons. But yes, if you ask me personally, I am more prone to ion electron method. So, but yes, in order to balance for a NEET level of question, generally oxidation number method people uses, you must also have used. Chalo. Then this bring us to the questions from atomic structure. This bring us to the questions from atomic structure. So I have some beautifully scripted atomic structure questions for you from a series. So let us attempt those questions also. The first question is in front of you, and let me make you visualize all the options properly. Yes. So time for this question will be 1 minute and it starts now. Attempt these questions very properly, beta, because atomic structure is an area which will help you to excel and master at least 2 questions. Maybe you are lucky. If you're lucky, you may get 3 questions, although atomic structure definitely helps for your physics also. So a very important and a very productive chapter, because this chapter is, if you just learn these few basics, the chapter is definitely yours. So please do attempt this one. I guess we will be having some 15 questions of atomic structure to help us excel and master atomic structure very easily. Hai Chalo. So quickly attempt this one. Quick. There are 5 electrons for which there are 5 electrons. The question is saying there are 5 electrons for which ms is plus half and 4 electrons for which spin quantum number is minus half. Now you are justifying this. You have to select the correct statements, but correct statement for what? For element with atomic number 9. So if I have element with atomic number 9, then so definitely if you have 9 electrons also, so you will be requiring to fill 1s2, then 2s2, then so 2p, because 4 is done, so I need 5 more. So sir, each orbital will be having 1 electron, which will be having plus half, but yes, minus half will be of the second one. So how much electrons I'm having, sir? You are having 3, 4, 5 orbitals. So 5 plus you will have, sir, but 4 electrons will be minus half because this is not having that. So definitely this is correct, sir. Now, there is only 1 electron in pz orbital. Now, sir, I have a 2p subshell which is having 1. but sir, they are degenerate. I cannot be sure which is px, which is py, which is pz. Yes, because they are degenerate, so anybody can be px, anybody can be py, anybody can be pz. It is precisely telling us that it is present in pz. I cannot be sure that this is pz, it can be any. That's why it is not correct. Now the last electron goes to orbital with last electron is going here, where is your last electron, sir? Here is my last electron. It is going in orbital which is having n equal to 2, so this is clear. And for p, l is definitely 1, so this is also perfect. So c is correct and a is correct. Now d, the sum of angular nodes of atomic orbital is 1. The sum of angular nodes of all the atomic orbitals. So you have to add nodes for all. Sir, for S, L is 0, so I can't add 0. For L, it is 0, sir, I can't add 0. For P, L is number of sum of angular nodes of all the atomic orbitals is 1. Now what is angular node, sir? Nodes are of two types: radial nodes and angular nodes. Formula for radial node is n minus l minus 1 and formula for angular node is l. If you just add them, formula for total nodes will become n minus 1. Now this statement is saying the sum of angular node of all, beta, this all is creating disturbance. The sum of angular nodes of all the orbitals is 1. 0 plus 0, sir, they are also orbitals. 2p subshell is having 3 orbitals, sir. Angular node for, sir, this is also 2p, this is also 2p, this is also 2p. So for all the nodes, as in 1 plus 1 plus 1 will be 3, sir. Because for this orbital, it is not talking about the subshell. So for all the orbitals, I have 3 orbitals with L equal to with angular nodes as 1 for px also, for py also, for pz also. So definitely sum will be 3. I hope you are getting the English. A good question, but let me see. So answer will definitely be Bombay. And let me see how many of you have actually done this English properly. I knew D was not a correct option, beta. I hope now everybody is with me. D was a question which was actually playing with you. So now this is a integer type question, I guess. So giving you options for integer type only. Quickly attempt this one. I've given you sufficient time to attempt this, because beta, please make sure you are focusing and attempting these atomic structure questions properly, because these are some 15 good questions, 15 good selected questions. So please attempt them properly. Cool. Great. Attempt it properly. Three. Neha, check your calculations, beta, because I guess this is not 3. Check those calculations, beta, once. I guess I've given you option for integer type only. Yes, study hard. You got that. Yes, Neha. Now perfect. Now perfect. Chalo, great. Obviously, answer is 34. No one has answered. Chalo, no worries. Why, sir? Beta, for hydrogen atom, energy of an electron in first excited state is given. So this is energy in first excited state. What is first excited state, sir? N equal to 2. Sir, energy is 2. Sir, we learn also. Sir, for hydrogen, for first For hydrogen, it is minus 13.6. Then, sir, minus 3.4. That means, sir, n equal to 2, minus 3.4 energy. That means that it is talking of hydrogen only. But still, kinetic energy of same electron of hydrogen atom is x. Sir, if it is total energy, then we definitely know total energy is nothing but negative of kinetic energy. So I know total energy. That means I directly know kinetic energy will be plus 3.4 electron volt. So if it is saying kinetic energy, I do not know it is x. So I know the value of x, but I have to report this x in this form. So 3.4 will be written as 34 into 10 raised to the power minus 1. A very students start calculating, but yes, you should know these conclusions and definitely it will help you to fetch the correct answer quickly. Moving to the next one. Quick. C. Chalo, perfect. So we have a respondent for the question. Now the question says, let me use white pen only over here. The difference between the radii of third and fourth orbit of Li plus 2 is, let's say, delta R1. So difference between radii, sir. So delta R1 will be equal to what? Sir, R4 minus R3. What will be R4? Sir, R4 will be R0 into N square, as in 4 square is 16, upon Z. For lithium, sir, Z will be 3. Minus R0 into 3 square is 9 upon 3. So this is my delta R1. Delta R1, yes, definitely. And what is delta R2, sir? Beta delta R2 is radius of fourth orbit minus radius of third orbit. This is of Li plus 2. So done that. But this is of He plus. So it will be R0 into, sir, 16 by 2 minus R0 into 9 by 2. Now you have to give the radius. So you do not have to look at the numerator. So numerator is same. So just the difference is this LCM. So what will be the ratio, sir? Delta R1 upon delta R2. Do not look at the numerator, sir, because numerator is same. So it will be cancelled. So this is simply 1 by 3 upon 1 by 2. That 2 will come in the numerator. So it will be clearly 2 by 3 as in option 3. I hope everybody has got their answer. Yes, perfect. 88%. Great, guys. Awesome. Moving to the next one. Yes, definitely over here. Let us practice this question only because you can obviously see. Let's say I'm not giving you an option, but you tell me how to solve this. Very beautiful question. A JEE mains question. Very beautiful question. The question says, for emission line of hydrogen atom from 8 to some n, the plot of wave number, which is nu bar, against 1 upon n square will be. Sir, we definitely know it is not saying beta, it is asking you initial is 8, final is n. It is not telling you that whether it is going up or going down. So you cannot do any you just have to go by your basic. What is that basic? Sir, we know 1 upon lambda, which is actually mu bar, is equal to R, the Rydberg's constant, into Z square, because it is talking of hydrogen. So rather that Z square you should not write also, but still I'm making you remember the formula. So I'm writing into 1 upon n1 square as an initial orbit squared minus n2 square as in final orbit squared. That means this mu bar is equal to R into 1 upon, what is this initial, sir? 8. So this is 64. minus what is final, sir? N. That means this is n square. Now the question is telling you, you have to give the plot between this mu bar, as in between this nu bar and 1 upon n square. So sir, I need 1 upon n square. So nu bar is equal to minus r into 1 upon n square, because that minus will be multiplied, plus r by 64. That means now you can compare this with y is equal to mx plus c. So here x is 1 by n square. So what is this slope, beta? Beta, this slope is, obviously it's a linear graph with slope minus rh, with slope of minus rh. I hope everybody is getting it, because most of the, yes, Neha is saying C. Most of the people think it is C. But actually, beta, you are thinking it because you are considering that this is, you are in fact not considering that this should be 1 upon n1 square minus 1 upon n2 square. What is n1? Initial orbit. What is n2? Final orbit. Once we are calculating lambda, we always do n1 is less than n2. Technically, n1 is the initial orbit and n2 is the final orbit. It is not mentioning you that whether that n is higher energy or lower energy. It is not mentioning that it is releasing that wavelength or accepting that wavelength. It is just generally mentioning you that initial is 8 and final is n. So you cannot do any iteration, and you definitely have to put n1 as initial and n2 as final. So what plot you have got? A straight line, but that straight line is having minus r as your slope. I hope everybody is with me on this. Hello? 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 Chalo, perfect. Now, moving forward. Chalo, good one. Good one. So a statement-based question, I hope you guys can attempt this properly. Time start in 3, 2, 1, go. Quick. Good. Perfect. According to Bohr model, the angular momentum of an electron in a given stationary state is quantized. Yes, angular momentum is mvr, and it is multiple of this. So yes, this is quantized, so definitely correct. The concept of electron in Bohr's orbit violates the Heisenberg uncertainty principle. Now the concept of Bohr orbit, which said that orbit as circular, is it violating Heisenberg's uncertainty principle? Yes, sir, because Heisenberg said you cannot predict exact position and exact velocity. Bohr has predicted exact velocity also, exact radius also. That's why Bohr said that this will be the velocity and it should follow a perfect circular path. How come you are saying that is a circular path? Couple it up with de Broglie hypothesis, that de Broglie even proved that the circumference of Bohr orbit will be n times of wavelength. So it will not be a circle. Rather, you will have wavelength, n times of wavelength, so circumference is n lambda. So definitely this is also correct, that those circular path, the predefined circular path cannot be predicted, because you cannot simultaneously find the position and velocity of an electron. You will definitely do some error. What is that error? H upon 4 pi. And even de Broglie says that because these electrons have very negligible particle nature, so they will be having more wave nature. So uh, in each orbit, the number of waves done by an electron will be 2 pi r is equal to n lambda. So this is also a de Broglie hypothesis. So yes, both are correct. That means option Bombay will be your right answer. Let me see how many of you have done Bombay for this one. Good percentage. Great, beta. Awesome. Great. Yes. Attempt this one. Statement base. 45 seconds. Read the statements properly. Number of following statements which are okay, you just do ABCD. That all this is technically an integer type question, that number of following statement which is are incorrect. So you just tell me how which of the following statements are incorrect. You just take this which is incorrect. So you just answer which is incorrect. A, B, C, D, because there is only one incorrect statement. So you can rest assured there is only one incorrect statement. You have to tell me what is that incorrect statement. Obviously, let us read them. Line emission spectra are used to study the electronic structure. Yes, sir. That's why we said that atomic hydrogen spectrum, helium spectrum, that means you were studying those electronic configurations through the number of electronic transactions that they were having. Yes, sir. So because this is correct, so not an answer. Line spectra of atoms in gas phase show a continuous spread of wavelength from sir, atoms have limited electrons, so they give electrons in packet. So packet will form a line spectrum, sir. It is saying it is forming a continuous spectrum. No, it will be a discrete one. It will be a discrete spectrum, because continuous spectrum is given by a molecule, because molecule is supposed to have so many electrons. Atom per se will definitely give electrons, but they will give electrons in packets, and those packets will form a spectrum which will be discrete spectrum, not continuous. So again, that means that B is my incorrect option. But yes, because we are reading, so definitely I will move forward. So Bombay shall be your answer. Let me check at least. No. Chalo, I hope it is clear. Now let me again read the another statement. An absorption spectrum. An absorption spectrum is like photographic negative of. Remember this. Remember that NCERT page. Remember this NCERT page. Yes. Sir, this is absorption spectrum, and if it is emission spectrum, then this absorption and emission spectrum are photographic negative of each other. Very important page, beta. This is a line spectrum. You can see those line, and this absorption spectrum is a continuous spectrum. An NCERT picture is telling you this. See, don't see over here. See from this area, sir. You are not getting anything, and then you are getting a line. That means emission spectrum is a line spectrum, while absorption spectrum you are having continuous pattern over here. Absorptions. So emission and absorption spectrum are there one of the definitions, but the characteristic of emission spectrum, it is always a line spectrum, and the characteristic of an absorption spectrum, that it is a continuous spectrum. A good point. Oh, definitely your answer in that case is option B. A very good point. I hope everybody is with me on this. Now, moving forward. Yes, a calculative question, rather a calculative one. So giving you 1 minute to attempt this. Acha, this is integer type beta. So I can't give you, because nahin, I can. This is an integer type, but yes, you have to be calculative beta. Although I have done this calculation for you to make this session precise, I have done that calculation for you. So, but yes, you should definitely try it once. Try it once. It will take maybe more time, but try it once. Try that calculation at least once. Aha. Superstar, yaar. Come on. Very awesome, Neha. Awesome. Chalo. Two. Great. Perfect. Chalo. The question says, if wavelength for an electron emitted from hydrogen atom is this. So this is the value of lambda which is emitted by an electron. Then energy absorbed by electron in its ground state compared to energy required to escape from the atom. Sir, here you have to use the wave and particle nature, because first it is giving you wavelength, but then it is asking that the minimum energy required for its escape from an atom. That means if if energy is falling, if this is the incident energy, which will be definitely hc by lambda, and if this is falling nucleus and on an electron, if this electron is getting this energy, that means that you are now taking into consideration its particle nature. That means you are considering photoelectric effect not from a metal, but yes sir, this nucleus will be attracting it, so it will be attracting it with some energy that will be acting as a work function for this electron. And if this energy is sufficient enough, then I can give you that energy which will be freeing you from the nucleus attraction. That means ionization. But ultimately for that you have to think that electron is a particle. So this is relating the wave theory with the particle nature, because see, mass of the electron is also given. So sir, ultimately what we have to do now, I'm just doing that calculation for you, because calculation was actually the reason I was actually congratulating Neha, because the question took calculation. Now see, so incident energy is coming, metal will come to the surface, electron will come to the surface, although this is not a metallic case, but an atom will be holding the electron, the nucleus will be holding the electron. So this work function will be required, which is termed as ionization energy. And if at all some energy is left, then I'll be removing with some kinetic energy. Now the de Broglie relates wave nature with particle nature, which says lambda de Broglie is nothing but h upon mv. So value of h upon what is momentum, so it can be written as under root of 2 mke. So twice of mass into kinetic energy. Very important conclusions, beta. Now how can you calculate ionization energy? Sir, ionization energy is equal to final minus initial. So finally, where you have to use at where you have to go at infinity. So anything, what is energy formula, sir? Minus E naught into n into z square upon n square. So if n is zero, if n is infinity, energy is zero. So this is gone. What is energy of first orbits are minus E naught. So that value we know in terms of joule. E naught is 2.18 into 10 raised power minus 18 joule. So that means you have calculated E naught. That means you have calculated ionization. That means you have calculated work function. Okay, sir. Now, sir, we know incident energy is equal to work function energy plus kinetic energy. So incident is equal to this plus this. This is my photoelectric effect equation. So incident energy will be, sir, I have calculated my work function, so I know phi. Now, can I calculate kinetic energy? Yes, definitely. By using this formula, you can. How, sir? Lambda value is given. So lambda is equal to h upon 2 mke. Just put every value y squared, sir, because under root I have removed. Why removed? Because I have to calculate kinetic energy. Yes, you will put all the values, h, mass of electron, and then lambda, and then you will be calculating kinetic energy in SI unit, which will be coming out to be 2.2 into 10 to the power minus 18. Sir, kinetic energy I know. Sir, phi I know. Now what I need? I need ratio of incident energy upon work function energy. So this ratio, sir, incident I have calculated. Incident energy I have calculated, work function I have calculated. Once you just solve this, this ratio will come out to be double. This ratio will come out to be double. But yes, a very important conclusion also, but rather the calculation is quite heavy. And definitely this is a JE question, but the reason I'm explaining this question is because this is making you revise many formulas. Photoelectric effect also, de Broglie equation also, and the concept of ionization, which is dealt using photoelectric effect also. So a good question to practice atomic structure. Great. Moving to huh, moving to next one. Yes, attempt this one, beta. Quickly attempt this one. Time starts now. Quickly attempt this one. Again, a de Broglie hypothesis, but yes, this will be rather conceptual. Here you do not have to do that much of calculations. So attempt this one. Quick. Quick. Perfect. Yeah, baat hai. Yeah, perfect. Chalo. Sir, the formula you have already told us, sir. What was the formula? I guess most of you remember also. De Broglie wavelength of an electron in nth orbit in hydrogen atom is given. So this is my de Broglie wavelength. And we know if I wish to relate radius of Bohr orbit with de Broglie's wavelength, then this is my relation. So de Broglie wavelength, as in this data, this value is given out to be 1.5. So just put, because now you have to give the value of n by z. So 2 is 2, pi is pi. What is radius? So radius is r naught, which you have to take as a naught. So a naught into n square upon z, because I'm talking of hydrogen, so z is 1. Now this is again n, and de Broglie wavelength is given as 1.5, which is 3 by 2 into pi a naught. This value is also given. Just now you have to solve these. So pi and pi have got cancelled, a naught and a naught have got cancelled, n and n have got cancelled. But yes, I have taken z as 1 because it is giving hydrogen, but still, because it is further asking also, so let me take z as z only. So I am left with n by z. I am left with n upon z on the left hand side, which will rather give me this 3, and this 2 and that 2 will be upon 4. That means this is nothing but 0.75. That means this is nothing but option 4, Delhi. Which still fair enough, beta. 66%. Fair enough. Great. Great, 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 great. Ha. Let us attempt this one too, beta. Time starts in 3, 2, 1. Go. The spin only magnetic moment for atomic structure, for electronic configuration, you should also know how to calculate that spin only magnetic moment. So that spin only magnetic moment calculation is our next job. So kindly attempt. Come on, quick. Yeah, now we have active participants. Great, great, great. Chalo, great, beta, great. Now the spin only magnetic moment of titanium plus 3. So titanium is 4s2 3d2. So titanium plus 3 will be, so these two electrons and one this. That means that titanium plus 3 will be 3d1. So definitely I know, sir, one an unpaired electron. So magnetic moment will be 1 into 1 plus 2 as in under root 3 as in 1.73 Bohr magneton. So these two can be option. These two are gone. Now just check which is 0. Or either let us check for any. Obviously, scandium is 0. Why? Sir, because scandium is 4s2, 3d1. So scandium plus 3 will have no unpaired electrons. So last will be 0. So last will be 0. That means Bombay is your right answer. That means Bombay is your right answer. So clearly done. I hope everybody is clear. Perfect. Perfect. So beta, this brings to the type of questions that we wanted to discuss for atomic structure also. Now I will be saving this PPT, but yes, I'll be doing this like very quickly. So again, taking I'm asking 5 minutes from you, not five actually. Let us take a 10 minutes break, but yes, precisely 10 minutes. So this is 3-7. So this is 3-7, and I will be there with my presentation at 3:17, no 3:20. So let us again meet at 3:20. And what chapter you want me to bring after this? Let us start with class 12th organic or physical chemistry. Class 12th organic or physical chemistry. Quick. Neha, class 12th organic or physical chemistry, or class 11th organic. Let us do class 11th organic first. Okay, chalo. Chalo. So let us start class 11th organic after this. So at 3:20, let me just physical only, physical only, class 11th physical only. See, some are saying physical, some are saying organic. So let me decide. Let me decide. Then it will be a controversy. Physical only, but yes, 3:20, because I have to save these presentations for giving you in the WhatsApp channel. So let me save these because we have again reached 60 slides. So let me save this and I'll be coming back at 3:20. है ना? चलो. Chalo beta, let's start. I hope everybody is back. I have saved the slides for you because obviously the work will not be completed if I will not be saving these slides properly for you. So once you will be downloading them from WhatsApp channel, just make sure that I have given names as 1 2. So whenever we will be taking these breaks, I have changed the name file. I've modified the file name. So once you will be downloading them from PW NEET English WhatsApp channel, the first file will be named as 1, then 2, then 3. So two files I have saved, है ना? चलो. Sir, please tell duration. Beta, uh, we will be see, although I'm also having coffee to energize my body, because yes, extends this was obviously beta, we have planned to cover the complete chemistry, the relevant things of chemistry, so we will take another 4-5 hours beta minimum, although I'll try to finish before 9, but let's see how much it goes. So but yes, obviously around 4 hours more, है ना? Chalo, let's quickly start. Hello. Now volume, sir, volume nahi aata hai. Okay, volume, now it is good beta. Acha, all those who are here, just give me a confirmation that whether I'm properly and completely audible and visible. Guys, confirmation for voice and picture check. So video perfectly audible. Now video perfectly visible and audio perfectly audible. AC, I am also my battery is also getting discharged. So need that energy. Show me that energy. Write your name. Whoever is here with an intention that you will be going to your government medical college, write write doctor as your initial and your name, and show this to the world and to me that what is your name. Dr. Dash. Dr. Dash, I'm going to crack the 21st of June re-NEET. So write your name with this initial doctor, and obviously give that motivation to me also. Chalo. Chalo. Okay. Chalo, let's start beta. So after this we are planning to start equilibrium and thermodynamics, and with this we'll be finishing the complete physical chemistry of class 11th, and then definitely the only remainder will be physical of class 12th. Now uh अच्छा, okay. नहीं 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 बेटा, नहीं 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 नहीं. चलो, thank you. Chalo, start karo sir. Yes, yes, come on. So next is beta, starting with equilibrium. So with equilibrium, the first question, the first we'll be discussing the chemical equilibrium, then we'll be going to the ionic side of equilibrium. So quick, the first question is in front of you, and a doable one rather. So giving 45 seconds for this. Please attempt properly, friends. Quick. Please attempt properly, guys. Hello, beta. Hello, Prince Daksh. Hello, Prince Daksh. A. Let us check. Chalo, I hope everybody have attempted this properly. So, phosphoric acid ionizes in 3 steps. No, I have to explain this. Chalo, let us do it better properly. Now I have phosphoric acid, sir. Phosphoric acid is H3PO4. It is ionizing in 3 steps with K1, K2 and K3 as their dissociation constant. K being the overall dissociation constant or ionization constant. Now you have to give the statement. Sir, definitely, sir. For for any polyprotic acid, H3PO4 will definitely form H plus and it will form H2PO4 minus. This will be dissociation constant. Let me be easy to write it. So rather instead of Ka, I'm writing K1. है ना? So if H2PO4 minus will further dissociate and form H plus, it will be forming HPO4 2 minus with the dissociation constant K2. And when this last guy, which is HPO4 2 minus, will be dissociating and giving H plus, it will be forming PO4 3 minus, which is my phosphate ion K3. Overall dissociation constant will be, if you just add them, beta, you can clearly see, sir, this and this will be cancelled, this and this will be cancelled. So I will be having H3PO4 giving me thrice of H plus and PO4 3 minus. So this will be my overall equilibrium constant K. Sir, if I'm adding the reaction, so equilibrium constants will be multiplied. So it will be K1, K2, K3. I hope everybody is clear till this. Okay, sir. Now just check, sir, if K is equal to K1, K2, K3, so log K will be equal to log K1 plus log K2. That means this is correct, sir. Sir, if it is dissociating, then after this minus has been formed, sir, if minus will, why it will take more electron, why it will become 2 minus. So that's why the first dissociation constant of every acid is not strong. It is very, very large than the later dissociation constant, because this negatively charged species, in fact these negatively charged species, if I'm already minus, the affinity for me to have one more minus will definitely be less, because minus minus will repel each other. So H3PO4 is strongest acid. Yes, sir. That is always the case for polyprotic acid, the first dissociation constant being very high. Now, K1 is very, very acha. K1 is greater than K2 is greater than K3. So definitely dissociation constant is also first is definitely greater. Now, can I do this average thing? No, sir. This is obviously not even possible. Yes, if you have a amphiprotic acid, as in a species which can give H plus also, take H plus also, then for that you can have the average of those dissociation constant. But no, sir, not otherwise. So D is not even a mathematical case for us. That means A, B, C are right option. That means option 4 is your right answer. None of you have attempted it properly, but yes, now Neha is answering. Now I guess everybody is clear with this. Moving to the next one. Chalo. You can do this. So attempt this one, everybody. Giving you 45 seconds for this as well. Quick. 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 Somebody is saying chats off. Yes, you should definitely invest time in studying. C. Okay, Anupama is here. She's saying C. 0.33. Perfect. So let's see. A timer, I guess it is about to end. The forward reaction. %. Great, guys. Great. Reaction is given. The backward reaction rate constant, that is Kb, it is saying is higher than forward rate constant Kf by a factor of 2500. So that means Kb upon Kf is 2500 because question is telling Kb is higher. How much? By factor of 2500. Now, R value is given and you have to give the K for this reaction. Sir, equilibrium constant K is nothing but Kf upon Kb, as in forward rate constant minus backward. The reverse is given, that means it is 1 upon 2500. So, but it will be your value of, but this will be your value of Kc. So if I have to determine Kp, then Kp is equal to Kc into RT raised to the power delta Ng will be 2 minus 1, so 1. So Kp will be equal to 1 upon 2500 into R, which will be 0.083, rather 0.083 can be written as 1 upon 12, and temperature, which is 1000 Kelvin. So I guess this will help you with the calculation as well. So this is nothing but 10 upon 12 into 25. Why I'm writing like this? Because if I multiply 4, this 25 into 4 will become 100. So this 0, 0 gone. That means this is 4 by 120. That means this is 1 by 30. That means this is 0.3 but with a 0. So definitely you can even solve this also practically easily. If you are good with these type of mathematics, that 1.083 can be written as 1.12, 8.314 can be written as 25 by 3. So yes, those mathematics definitely helps a lot while calculations. Chalo. Moving to so a question on Lee-Chatelier principle also can be done. So attempt the next one, guys. 45 seconds for this too. 3, 2, 1, go. Quick. Higher yield of NO. Higher yield of NO. नहीं ज्ञानेश्वरम, why 1 by 12? 20? 500? Because beta, Kc is Kf upon Kb na? And in the question you were given opposite. You were given Kb by Kf. Because Kc is forward rate constant upon backward rate constant. And in your question, Kb by Kf was given. That's why. Chalo. I hope most of you have attempted it. Time is also done. 3, 2, 1, go. So let's check. 100% great. Chalo. So the question says over here is higher yield of NO. So how can I get more of NO from this reaction? Delta H of the reaction is positive. That means this is an endothermic reaction. Heat is absorbed. So if I increase the temperature, then reactant will increase, and once reactant will increase, in order to decrease concentration of reactant, reaction will be forced in forward direction. Yes, sir. In that ways, NO will be produced. So A is good, sir. So A is good, sir. A is good, sir. Now, lower temperature, no, sir. So B is definitely incorrect, sir. So B is definitely gone. This is clear application of Lee-Chatelier principle. Now, higher concentration of N2, sir. If you are increasing reactant concentration, then in order to oppose, I will again try to decrease it. And in order to decrease, I will shift the equilibrium forward direction. So this is also good, sir. Will increase NO, sir. So C is also good. So C not here, C here. So obviously we have got our answer, but still practicing. And higher concentration of O2, sir. That is also a reactant. So if you increase concentration of reactant, reaction will be forced in forward direction. Definitely D is also correct. A very practical and a very probable question for your NEET examination. I hope everybody is clear with this too. Chalo, attempt this one quick. Attempt this one quick. For these physical chemistry questions, I am precisely giving you the PYQs, but yes, the logical PYQs. Cool. Great. About your lunch, beta. I mean, I had whatever I was with the limited time that we had, I mean, yes, I had you study is will be the greatest lunch for today. Even I am feeling that having smaller sessions is better than rather having this extended one. But yes, I wanted to cover this for you today. So that's why pushing limits. Chalo. So I guess time is also done. Yes. So let me see how many have answered correctly. Less. Are superstar? Okay. So let us see beta why you people have not attempted correctly. The question says for the reaction 2A, for this reaction K value is given. At a given time, the composition of reaction mixture is this. So what can you say? So if given time, so this is concentration at time t. So at time t, what can you calculate? Sir, I can calculate Q. Q will be concentration of B into C, all are equal. So B, C upon A squared, sir, all concentrations are equal. So this is also squared. So Q is 1, sir. K value is very less, sir. So that means that Q is greater than 1. That means if K is this, your ball is here. That means ball, who tells the position of this ball, sir? Q. What does K tell you, sir? If Q is more than K, then you can think of a condition like this. So where reaction will proceed, sir? It will proceed in backward direction. Okay, sir. Now, reaction has tendency to go in backward direction. Yes, sir. Clearly, this is correct, sir. So without giving any fault or false hope why you have done this question incorrectly, so I guess now it is clear for everybody. Then we have okay, not required. Then we have okay, not required. Chalo, then we are moving to ionic, I guess. Chalo, before moving to ionic, at least attempt this before moving to ionic, because for chemical knowledge of Lee Chatelier principle, writing that value of K is more than sufficient. Having the knowledge of Q, that if Q is more than K, then reaction proceeds backward. If Q is less than K, then reaction proceeds backward, is more than sufficient for your NEET examination. Now, yes, a thermodynamic fact also, but still for equilibrium also you should know this. So attempt this also for equilibrium, chemical equilibrium. Let me give you time also for attempting this. Quick, 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 everybody. Quick, everybody. A. People have started answering. Someone is saying A. Chalo. I hope everybody has done it. D. Chalo. I hope everybody has done it. Let us check. Answer is Delhi. Less percentage, in fact 57 is saying A. So let us check beta, maybe you have done a bit of error. The equilibrium concentration of species in the reaction A are given. So these value are not at time t. Now this is at equilibrium. So I can definitely calculate K now because concentration. So Kc, CD, C is 10, D is 6, A is 2, B is 3. And all stoichiometric coefficients are 1, and this is concentration, mole per liter. So value of K is definitely 2, 3 is 6, 10 rupees. Now, you have to calculate delta G naught. Sir, value of K I know. So delta G is equal to delta G naught plus RT ln of Q. At equilibrium, once reaction reaches equilibrium, no work is done because rate of forward and backward are equal. That means no work done, as in delta G 0 and Q equals K. So at this situation, delta G naught is nothing but minus RT into ln of K. Because I have to do the calculation, so let us convert ln in log. So minus 2.303 into value of R is 2 because I have to calculate this in calories. Temperature given is 300 Kelvin into log of the value of K, which is 10. Log 10 is definitely 1. So now this is just a matter of into divide beta. This is approximately 2.5. So 2.5 into 2 is 5 rupees. 5 3 is 1500. So more than, because this is 2.303 na. So 3 2 ja 6, 6 2 ja 12. I mean, yes, 1200. Not why 25? This is 2.3 or 2.5. हाँ ठीक है ना. 6 2 3 2 ja 6, 600. 600 double is 1200. But yes, more than double. So around more than double. So more than 1200, what option you have? More than 1200, you are not there. Acha, you are also there. You are not there. You are also there. So magnitude you do not have to compare. You just have to compare size. So this minus sign is also there. So answer 4 will be your answer. You do not have to calculate also. Now see, these are your relevant PYQs where you are not even required to do the calculation. But yes, you have to be very, very, very confident with your logic, hence giving you the complete logic behind it. Complete theory also, all those who have not remembered, for them also I'm telling. Cool. Chalo. Moving forward. Coming to the questions from equilibrium, quickly practicing some questions for equilibrium. Ionic equilibrium rather. So let me make you revise the topics also. So question is in front of you. Please try. Quick. Quick. Arey Henry, you are saying bye. I have seen very less of your comments today. Why is it so? Yes, Superstar is answering 4.57. Chalo, quick. Chalo, I guess people have answered. So, Arey, none? Why beta? Chalo, let's check. The pH of solution containing 50 ml each of this much molar sodium. Sir, this is salt of strong base and weak acid. And I have weak acid. So what is it, sir? So this is a buffer. What buffer? This is an acidic buffer. So what is acidic buffer, sir? It is a mixture of weak acid with its salt with a strong base. Okay, sir. Now, for calculation of pH of a buffer, formula is because it is acidic, so pH will be 7 minus, obviously. But half of what? Half of no, why half of? This is not salt analysis. So it will be 7 minus log of concentration of salt, or rather, hey, 7 minus 7 plus is for salt. I am, my battery is getting discharged. pH of a buffer solution is pKa, the dissociation constant of weak component. So pKa, plus log of concentration of salt, which is giving the conjugate part, upon concentration of whatever weak acid you have. So pKa value of the weak acid is already given, 4.57 plus log of. Now, what is concentration of salt, sir? Sir, this much salt I'm taking. Okay, concentration will be moles, so moles will be molarity into volume upon total volume, but total volume will be this, and this will be added, so hardly matters. So, acha, okay, so rather taking concentration only. So, concentration of salt is 0.1, so 10 is power minus 1 upon concentration of weak acid is 10 raised to power minus 2. So this will be 10. So log 10 is 1 because this will go to the numerator. Log 10 is 1. So 4.57 plus 1 as in 5.57. So 5.57 is option Bombay. But nobody answered option Bombay. I hope now everybody remember the formula for salt hydrolysis, guys. I hope everybody now remembers the formula of salt hydrolysis of an acidic buffer. Guys, chalo, perfect. Attempt the next one. Attempt the next one quickly. B, B, B. Multiple B we are getting. Chalo. So the question says, this is your reaction for the given reaction at 298 Kelvin. Kc is found to be, so K values I know. If the concentration of oxygen at equilibrium is given, then concentration of ozone is what? Sir, value of K is given, sir. Okay, value of K is given how much? Sir, 3, some very small value, sir. That means reaction is not at all moving in forward direction, because look at the value, 10 raised to the power minus 59 means reaction is not at all moving in forward direction. So for this reaction, Kc is found to be this. If concentration of oxygen at equilibrium is given, then concentration of ozone you have to determine. So sir, value of K is 3 into 10 raised to the power minus 59. Concentration of, it will be concentration of ozone, which I have to determine raised to the power 2, which will definitely be negligible, sir, because this is not even moving forward. Just look at the value of K, you can identify that. Upon concentration of reactant, which is oxygen, and oxygen concentration is given out to be 4 into 10 raised to the power minus 2, but cubed. So you can clearly calculate ozone beta. Ozone squared will be 3 into 10 raised to the power minus 59 into 4 is 16 into 10 raised to the power. Okay, why 16? It is cubed. So 16 into 4 is 64 into 10 is power minus 2, 3 is 6, minus 6. So that means it is 10 is power minus 59, so 60 and 5, 65. 10 is power minus 65 into, so this will be 64 into 3. So some value of one, it's somewhere around 200 or maybe more than 200. So let us do that scientific notation thing. So do I have that power? Acha, but this is ozone squared. So ozone will be, this is ozone squared. So rather, let me make this 0 and increase it by 66 and then do the under root. So it will be 64 into 30 under root into 10 raised to the power minus 33. So you will be having some 10 raised to the power minus 30s formats, option 2. That's why I'm not solving also, because these are your exact PYQs. You are not supposed to solve. You are supposed to do your common sense. And I hope making that common sense will definitely give Bombay as your right answer. So perfect. 87% have got it correctly. So great. Great. Moving to So I'm not even attempting it because pH of a salt of weak acid and weak base will be, because this is salt hydrolysis, so 7 plus half of pKa minus pKb. Very important formula, which is calculation of pH of salt of weak acid and weak base. So you can definitely calculate, but yes, very important for revising these formulas. Yes, so this is your next question, and I guess you should attempt this very properly. Try this one, beta. Quick, quick, everybody. Yes, perfect, perfect. So try this one, everybody. You have to calculate the solubility of whom? Of nickel hydroxide. But you have a 0.1 molar solution of NaOH which is creating common ions. So what shall be the solubility of nickel hydroxide? A very popular question, beta, because such questions has loads of percentage in coming in your examination. Chalo, let us do it. D. Great. D. Perfect. Perfect, guys. Perfect. Now, sir, I have nickel hydroxide. So this nickel hydroxide will be dissociating and forming nickel ion and twice of hydroxide ion. Obviously, their percentage will be very less because this is a weak electrolyte now, but it is present in 0.1 molar NaOH, sir. That means this dissociation will be further suppressed, sir. Yes, because this is a strong electrolyte. So how much of this I'm having? 0.1. So in presence of this, its dissociation is much reduced, but still it will be, let's say it is dissociating very negligibly small amount S. So if one will break, 1 and 2 will be produced. So if S has broken, so S and 2S will be produced. But sir, concentration of nickel ion at equilibrium will be this plus 0.1, which will be nothing but 0.1 only, because this is negligible value, sir. So technically, I know OH minus ion concentration. Now, what never changes at equilibrium? Value of K, and that value of K, the ionic product is given out to be 2 into 10 raised to the power minus 15, which will be equal to concentration of nickel ion, which is S, into concentration of hydroxide ion, which is 0.1, but it has to be squared. So 10 is power minus 1 squared, as in 10 is power minus 2. So you do not even have to move your pen for such calculations if you are comfortable with your common sense. And what does that common sense tell you? That, sir, this S is nothing but 2 into 10 is power minus 13. No calculation required, sir. So Delhi is your answer, which I guess perfect. 80% of you have cracked this, so great. Moving to the next one. Nah, not required. Moving to the next one. Now my system is getting hanged, because else you can see these questions, but now you are not seeing this question. Chalo, we can hold for a second because beta, even my system is not helping us today. Chalo. Chalo. So, guys, I guess I have to. No, my system is also uh, hanging. So, chalo, beta. I hope everybody's. Chalo, I'll be bringing this again. Let me just restart the system and then I'll be back. So again, although don't don't mind. Acha, chalo. So let me quickly refresh it here only. Let me do it here only. But how to? नहीं बेटा, आई हैव टू, चलो, व्हाट, लेट अस डू दिस बेटा. नहीं नहीं नहीं, नो बाय. ए सर, रात को ले लेना क्लास. वेट वेट वेट, लिसन, वेट. Let me restart. We'll again, we'll take around 15 minutes of break again, and then we'll again restart. Okay, so don't go from this live. I am just putting the teacher will be back soon sign, and then we'll again meet around 4:15. Good. Chalo. Hello, hello, hello. Yes, guys. So we are finally back. My teaching panel is also updated. Yes. So just give me a confirmation that we are here again, guys. Chalo. Shall we start again? Casper, Samu, Nezu, Narendra is saying he is leaving. Narendra, my max up has started. Now we can definitely start. Chalo. Now, sir, the question, yeah, come on. Now, the question that I guess we have attempted this question, and yes, the notes that you will be getting, my friends, the notes, those few questions of equilibrium that we have solved will not be having the detailed solution because I was unable to save it, rather it hanged. So we will be getting those solutions, but yes, those questions will be there, but the solutions, obviously you can access the recordings for those solutions if you want. So let's move forward. Moving to the next question. Yes, definitely correct. So giving you 30 seconds to attempt this one. Quick. 3 to 1 go. Now let us streamline the process. Let us finish what we have intended to finish today. Quickly, let us finish what we have intended to finish for today's class quickly. Chalo. Perfect. Yes, I hope I'm clearly audible, guys. Chalo. Perfect. See, superstar is back. See, now, so the question says among the following salt solution is basic. So for having a basic salt solution, I need a strong base rather with a weak acid. Sir, this will be given by strong acid, so sir, not possible. This will be given by strong acid, so sir, not possible. This is given by weak acid and strong base, and yes, definitely 3 is our answer because salt of strong base and weak acid will definitely give you a basic salt. Moving to the next one, giving 30 seconds only for this one because let me attempt the same with you with same enthusiasm because beta, ultimately if we just keep the enthusiasm intact, then definitely any and everything can be done. है ना? चलो. So the solubility product of a salt of type AB is given. Okay, sir. What is the molarity of its standard solution? Sir, that means it is talking about the concentration only. So, sir, for this is a simple salt. So 1 So solubility will be S square, and solubility product is given as 4 into 10 raised to the power minus 8. So S will be definitely 2 into 10 raised to the power minus 4. That means this is nothing but option 4, which I hope most of you have attempted properly. Yes, perfect. So moving to the next one. Yes, attempt. Yes, attempt this one, guys. Uh, Giving you 30 seconds for this as well. Attempt this one. The question says the pH of this basic solution is 9. You have to give the solubility product. That means it is a sparingly soluble electrolyte, and for this sparingly soluble electrolyte, pH is given, but sir, pH is concentration of H plus ion concentration. So if pH is 9, then rather POH will be 14 minus 9. That means it will be 5. So you know OH minus ion concentration. OH minus ion concentration will be 10 raised to the power minus 5. Now, sir, this will be giving what? Sir, it will be dissociating and it will be giving calcium ion and twice of hydroxide ions. So the hydroxide ion concentration is this. That means if its solubility is S, if it's or rather, because we have to calculate KSP, so yes, if its solubility is S, so this will be S and this will be 2S. So value of 2S is given. Value of 2S is this. So value of S will be half of this. So what will be the value of KSP, sir? KSP will be concentration of calcium ion into calcium of concentration of hydroxide ion squared at equilibrium, and this is giving you the pH at equilibrium only of the saturated solution only. So what will be the value of S beta? Sir, value of S will be 10 raised to the power minus 5 upon 2 into hydroxide ion concentration is 2s, and the value of 2s, the hydroxide concentration, is given, but I have to square this value. So 10 raised to the power minus 5 squared. So it will be minus 5, so minus 10 and minus 15. And then I will be having 1 by 2, which is nothing but 0.5. So let us check. Obviously option 1. So this brings us option 1 as our answer. 100%. Great going, guys. Great going, everybody. Moving to moving to next question. The question relates equilibrium constant K. Such type of question which discusses about the characteristic of values of K are also very famous. So again, 30 seconds for this one. I hope this is quite doable, because for this question you do not have to move your pen, I would rather say. You do not even have to move your pen for this particular question. I hope you can answer this. Now, the overall reaction is given, and this K you have to determine. Sir, for this I need ammonia, but I need ammonia in left hand side. So here I'm having this. That means I have to reverse this reaction. So if I have multiplied with minus 1, this K will be K1 raised to the power minus 1, so that I'll get ammonia in the left hand side. Now I need 5 by 2 oxygen. Sir, this is half, this is 2. If you just check, I need NO2, so I need 2 NO, so at least I need one of this, but I need thrice of water, so I will be needing thrice of this, because thrice will make this also 3 by 2, so 3 by 2 plus 1 will be 5 by 2. So definitely I need NO on the product side, water on the product side, so I want them as this only, but this is thrice, so this will be K3 will be raised to the power 3 into K2. So what is K ultimately? Sir, K is K1 will just go to the denominator, so K3 cubed and K2, that means option 3 becomes your right answer. Option 3 becomes your right answer. Perfect. 83% of you are correct. I hope everybody is clear. I hope everybody is clear, guys. Chalo. Perfect. Give me a confirmation. Give me a confirmation if everybody is in sync. Yes, perfect. So C, okay. Chalo, perfect. Moving to the next one. Yes, a good question. Try and attempt this one also, beta. Although question of such forms we have already attempted and tried, but still, because the solubility product of a sparingly soluble salt questions are very, very famous. Very, very famous. Chalo, perfect. Next. Chalo. I hope you guys are attempting it properly. Now, the question says the concentration of silver ions in a saturated solution of silver oxalate is this. The solubility product, you have to again determine solubility product, and the concentration of silver ion is given. So this is my concentration of silver ion. How this will be giving me the ions, the twice of Ag plus and C2O4 2 minus. So if its solubility is S, then this will be 2S and this will be S. Now concentration of silver ions is given. So that means I have my value of 2S as 2.2 into 10 raised to the power minus 4. So S will be nothing but 1.1 into 10 raised to the power minus 4. So I know S. If I know S, I can calculate KSP. My value of KSP will be, sir, this 2S, but it has to be squared into S raised to the power 1. Sir, 2S value I already know, so why bother? I just put that same value. That means 2.2 into 10 raised to the power minus 4 has to be squared, and because I have calculated S, which will be 1.1 into 10 raised to the power minus 4. So 4 is 18 and 4 will be minus 12, and 2.2 into 1.1 will give me a multiplier. So if you just go, okay, this is also minus 12, this is also minus 12. Obviously, they are not your option. But yes, if you just calculate it, I guess it will be more than, it will be, okay, this also has to be squared beta. So 2 squared is 4, and 4 will be increased 10%. So it will be definitely reaching around 5. So option 1 will be your right answer. Yes, you have to be proper with your calculations beta, because if you are not, then rather this shall end and result into a negative marking. So whenever you have calculation, just go slow, just be cautious, and then do the calculations. Cool. Then we have basic questions again, which chalo, let us attempt this last question for equilibrium, and then we'll move to thermodynamics, because for equilibrium also we have discussed more or less the probable concepts are related to the questions. So the last question, and then we'll be moving to thermodynamics. Quick. So time for this, because you have to read, but still 30 seconds. Quick. Now, I have My and My3, both are insoluble salts. They have same KSP values also given. Which statement would be true regarding My? Sir, if the KSP values are same, that means whatever ions it is creating M plus and Y minus. But this guy will be creating more ions, N plus 3 and thrice of Y minus. So after creating more ions, it is having the same value of solubility product. While My is creating less, My is creating less ions but still contributing to the same. This definitely means solubility, the molar solubility of My in water is less. Why? Because sir, My solubility will be less because it is only giving this S and this S, while it is giving S and 3S. So because it is creating more ions, it is creating less ions, then whose solubility is lesser, because ultimately their product is same. So ultimately, sir, it is this My is having less solubility, that My is creating more ions, so its solubility is more. Although after giving those, because the value of KSP, the equilibrium constant for both, K represents the characteristic of the reaction, so value of K is same. So who is giving more ions will be having more molar solubility than the species which is giving less ions. So a good question, but let me check how many of you have 50%. So fair enough, beta, fair enough. Chalo, let us quickly move to some basic questions of thermodynamics, starting with the thermochemistry question. Time has already started. So just read and try to give the answer. The question says the standard enthalpy of formation in kilocalorie you have to calculate for barium cation. The heat of formation of sulfate ion is given, the heat of crystallization of barium sulfate is given, and heat of formation of barium sulfate is given. So what is heat of crystallization, sir? What is enthalpy of crystallization, sir? The amount of enthalpy required to either dissociate, because it is negative, so ions must be getting associated. That's as in barium plus 2 ion and sulfate ion must be getting associated to form barium sulfate solid. And therefore sir, because when these ions will meet, they will form a crystal. So the value is minus 4.5 kilocalorie for this reaction. Now what I need to sir, Enthalpy of any reaction, enthalpy of crystallization is given, which is minus 4.5 kilocalorie. Enthalpy of any reaction is equal to enthalpy of formation of product minus reactant. So enthalpy of formation of BaSO4 is given. So minus 349 of the product is given, minus enthalpy of formation of reactants. So enthalpy of formation of barium I have to calculate, let's say that value is X, and I guess enthalpy of formation of sulfate is given out to be, but this plus this, so because it is with a negative sign, so it will go with a minus sign, minus 216. So I guess if you just solve this, you will be getting somewhere around this. Everybody, chalo, let me see how many of you have done that calculation properly. 60%, fair enough. But make sure you remember these definitions for longer duration of time beta. Now, coming to a theoretical, rather a very practical questions on entropy. Again, a 2024 question, again a relevant PYQ for you. Yes. So the question says, in which of the following processes entropy is increasing? So whenever physical state increases, or rather physical state is same, then number of moles increases, then participants will increase. If those participants will increase, then definitely their entropy, their measure of randomness is bound to increase as well. So chalo, perfect. Yes, people are answering. So A, liquid evaporated to vapor. Sir, liquid transforming to gas will definitely increase entropy. Temperature of a crystalline solid lowered from, sir, if you decrease temperature, then definitely, sir, entropy will also decrease. And in fact, 0 Kelvin, which is practically not even achievable, at 0 Kelvin, the entropy becomes exactly 0. So here it is decreasing, so not increasing. The solid is turning to solid, but I'm getting gaseous moles also, so here also it is increasing. And here state is same, but 1 mole of gas is transforming into 2 moles of gas, so here also it is increasing. So a clear cut explanation of increase in entropy, that means option A, 100%. Perfect beta, perfect everybody, you guys are awesome. Moving to the next one. Now yes, a direct relation, direct question has been asked, so I hope no time will be required for you to attempt this. Among the following option, the correct relationship between change in enthalpy and change, a direct formula is asked, so which is definitely delta H is delta U plus delta NCERT. Generally this equation is delta H as an enthalpy change of the system is equal to internal energy change of the system plus pressure volume work of the system. But yes, for a chemical reaction, this delta PV at constant temperature is replaced by delta NCERT. One important point beta, how you change enthalpy of the system by supplying or exchanging heat within system and surrounding at constant pressure. How you change internal energy of the system by supplying heat or exchanging heat at constant volume. So this point you always have to remember, that whenever you exchange heat with the system at constant pressure, it will change the enthalpy of the system, and rather if you exchange heat at constant volume, it will change the internal energy of the system. So obviously this question is done, but yes, the reason I have taken this is because I wanted to give you the theoretical explanation also. Chalo, moving to this one. Now you have to give where you are doing the maximum work, so where you are producing the maximum work, which graph shows that you are doing the maximum work. Sir, definitely yaar, come on. Sir, area under curve. So here area under curve is less. Sir, here area under curve is only, because this is a cyclic process, so area under curve is only this much. Sir, this is a constant volume, sir, so obviously here there is no work is 0. And obviously you have maximum area under curve because PV, pressure volume product, is also work, so you just calculate area under work, and this definitely gives you an answer. I hope everybody is clear. That means definitely this is nothing but option C. Chalo, great. Great, great, great. Moving to moving to the next one. Try and attempt this beta. 3, 2, 1, go. Now the question says, at standard condition, if change in enthalpy for a reaction is 109 kilojoule. So enthalpy change of the reaction is given, which is 109 kilojoule. Now, given that bond energy of hydrogen, bromine are this and this respectively, then you have to give bond energy of HBr. Definitely enthalpy change of a reaction is equal to, in terms of formation, it is product minus reactant. In terms of bond energy, it is reactant minus product. In terms of combustion also, it is reactant minus product. So obviously you have to learn. So let me just give you the formula. So the enthalpy change, which is this 109, it will be equal to summation of enthalpy of hydrogen plus bromine. So for hydrogen it is 435, for bromine it is 192. So this is of the reactants minus product. And how much of product I am forming? So 2. That means it will be twice of HBr enthalpy. So yes, you have to add them, then obviously subtract 109, then divide by 2. Once you do that, most of the students are answering also. I guess after calculation, I'm just skipping those calculations beta, because obviously that will be taking time, and definitely I want you to revise the content. Calculations will definitely be only be done once you practice more, and obviously this is what you will be going and giving in the examination. है ना? चलो चलो, perfect, perfect. Moving to yes, yes. If you have learned that enthalpy thing, try to answer this one. If you have learned that enthalpy thing, try to answer this one. Thank you. Next gen motion. Great energy, sir. Hats off to you. Was watching your hydrocarbons lecture on JE channel yesterday. Yes, beta. I have just finished that late night. So yes, but beta, your work is more important. Thank you. Chalo beta. The bond dissociation energy of X2, Y2 and XY are in the ratio this. Okay, sir. Delta H of formation of XY is this. Then you have to give bond dissociation energy of X2. Sir, enthalpy of formation is given. So we can write the reaction. Half of X2 plus half of Y2 will be giving us XY, because enthalpy of formation is when 1 mole of a compound is formed. So I have specifically found 1 mole of the compound, and the enthalpy of formation is minus 200 kilojoule. That means I know enthalpy of reaction is minus 200. So now I know enthalpy of reaction. What I have to calculate? Sir, bond enthalpy. So just do it. Sir, bond enthalpy of X bond X we have to calculate, but I have been given the ratio of all of them. So I will be using that ratio. How, sir? For X, let's say its value is A. For XY value will also be A, but for Y2 it will be A by 2, because the ratio will be 1 is to 0.5 is to 1. 1 is to 0.5 is to 1. Now you can calculate A. So this is A, but it has to be multiplied by 2. So this is A by 2 plus. Y is already A by 2 and it also has to be multiplied by 1. So this will become A by 4. This is about the reactant minus. Sir, about the product, sir, it is obviously A, so minus A. So this, yes, you can definitely do this properly also. Sir, this is a by 2 and a by 4. That means this is 3a by 4. 3a by 4 minus a is, sir, minus a by 4. So this is minus a by 4. So minus minus gone. That means a is definitely 800. And x2 I have assumed as a. So value of a is 800. So that means option 4 will be your right answer. Eh? 0%. I hope everybody is clear, guys. I hope beta everybody is clear with this, guys. जी हूँ. I hope everybody is clear, guys. I am waiting till I'm getting a confirmation in the comment section, because I read 0% has given correct for this one. I hope everybody is clear. Arya. Yes, chalo. Thank you, Yash. Thank you, Karan. Karan is back again. So, okay. Chalo, perfect. Dolly Das is saying repeat. Beta, see, enthalpy of any reaction is and summation of enthalpy. If you are given bond enthalpy, so it is bond enthalpy of reactant minus product. But sir, reaction is not given, but it is written theoretically that delta H for formation. What is, how you define formation? The enthalpy change when 1 mole of a compound is formed. So for 1 mole of a compound, you write the reaction. And this is my enthalpy of, this is the delta H value given. So that will become my enthalpy of reaction. Now, although bond enthalpy is not given, but ratio is given. So take a variable a. So if it is a, this is a by 2, this is a. Then use the value, put the value, you will definitely land to your answer. Cool. Chalo. Moving to another good, yes, beta, conceptually a very relevant formula, because this formula we haven't revised. So let us revise and practice question also. So let us revise and okay, somebody is typing postpone NEET. Nahi beta, please don't postpone. Please don't. Chalo. Chalo. Now, I hope you guys are attempting it properly. Now, the question says for a given reaction, delta H is this, delta S is this. The reaction will be spontaneous. Sir, the very famous reaction, which is delta G, is nothing but delta H minus T delta S. So if I want this reaction to be spontaneous, that means I want delta G to be negative. That means I want this value to be negative. This value can only be negative when T delta S, as in this thing, will have greater magnitude than delta H. You can obviously see this is also positive, this is also positive. So T has to be greater than delta H, which is 35.5. Always have a look at the unit. This is kilojoule. So it has to be multiplied by 1000 upon, this is joule. So it is 83.6. Yes. So after solving, you will get temperature, and that temperature will definitely give you, acha, 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 acha. Okay. Okay. Technically, assume delta H do not vary with temperature. So technically, beta, here I guess this is a printing. Nahi, 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 nahi. If you just solve this beta. Let me do this with calc. You guys, please solve this. Let me also just check the calculation, because I guess the answer would be 355 with a 00 divided by 83.6. Ha beta, it will be coming out 425. It will be coming out 424 point something. So T has to be greater than 425. That means option B will be your right answer. Yes, you have to be calculative for this one. 88% of the students are right. I hope everybody is clear. Moving to the yes, a good question, a good one again. Yes, good one as in conceptually sound. It will help you to revise properly the relevant thing of thermodynamics. So I have deliberately taken those questions which will help you to revise the formulas also. So this will be the last question for thermodynamics, and then we'll be moving to organic chemistry of class 11th, alkanes, and with alkanes we'll be covering alkyl halides as well, because sir, alkanes is hydrocarbon is definitely a chapter which will help us to learn more about alkyl halides in class 12th organic. Cool. Chalo. So Karan is there. Perfect. Study hard is here. Everybody's saying D. Chalo. Great. Superstar is back. Superstar is also saying D. Chalo. So let us. Time is also done. And definitely D is your answer. Why? Because again, making you revise the very important formula of entropy change. The entropy change for a system can be calculated using the formula NCV ln T2 by T1 plus NR ln V2 by V1. Now, if you just read the question is telling you that I am having a isothermal system. That means T1 and T2 are equal. So this will become 1 and log 1 will be 0. So this is gone. But it is talking in terms of pressure. So temperature constant. So for ideal gases, if temperature is constant, then P1 V1 will be equal to P2 V2. That means V2 by V1 will be equal to P1 by P2. So instead of V2 by V1, you can write P1 by P2. Now P1 is my initial pressure and P2 is my final pressure. So this becomes Pi upon Pf. That means Pi upon Pf. That means option 4 becomes your right answer. I hope everybody got it. I hope everybody got it. Now this brings us to the chapter of hydrocarbons. Now this brings us to the chapter of hydrocarbons. So sir, 11th physical we have revised relevant topic. I'm not saying I have given you all the because beta, you obviously cannot do everything in a single day, but yes, all the relevant high probable formulas application with the exact question I have tried to give you. Now let us move to organic chemistry. With organic, I mean first I'll be covering hydrocarbons, then we will be moving to class 12th organic quickly. With hydrocarbons, you can obviously mix all the organic chapters of alkyl halide, alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, amines, biomolecules, so on. So let us start with the process of hydrocarbon. So the first question, but yes, it is not precisely hydrocarbon. It is because GOC we have discussed, but we have discussed less of physical structural isomers. So the first question is for structural isomers only, so that you may have a quick revision and a start. So you have to identify the correct statement. Quick. Correct, beta, not incorrect. You have to identify the correct ones. C. Okay, let's see if answer is C. Chalo. The question says these two are metamers. So, sir, this is a ketone. This is also a ketone, but here this is methyl and 3 carbons. This is both side ethyl. So, whenever you have a polyvalent functional group and nature of alkyl group changes, they are definitely known as metamers. So, A is definitely correct. That means A is my one of the probable answer. Now, what about B? Sir, let us beta always calculate number of carbons. So, this is 4 carbon. Sir, this is 1, 2, 3, 4 and 5 carbons. It is saying they are position isomers. So definitely the molecular formula is also not same, so they can't be position isomers. Now cyanide and isocyanide, let us calculate carbon chain. 1, 2, 3, 4. What about this? So this is 1, 2, 3, but the carbon is already there. So cyanide and they are definitely functional isomers. So A is correct, C is correct. It is saying B also. Then I guess This is 1, 2, 3, 4. This is 1, 2, 3, 4. Acha, chalo, let's see. Beta, here, this is carbon chain is 1, 2, 3, 4, and carbon chain is 1, 2, 1, 2. Sir, although carbon is increasing, but you should understand you can only call homologue to those compounds which have same functional group. So 1 degree and 2 degree amines have different rate of reactivity. They are actually functional isomers. So if I am a functional isomer, then I can't be termed as a homologue. For homologue, you should have same functional isomers. So actually, A and B you do not have. Acha, A and B, okay, that is C. Okay, that is C beta. So A is correct and B is correct. These two are correct, and definitely A, B you have an option C. So yes, I thought that was B. So don't think you have definitely not thought it was my bad, but I thought that was. Chalo, moving to a question, a JEE mains question, but it will rather help us. Integer type question, 60 seconds. Time starts now, although I'll be attempting it with you. You have to give the number of geometrical isomers that it is producing. The number of geometrical isomers that it is producing. The number of geometrical, sir, incorrect. The first structure is, okay. Nahi beta, actually, Neha, it was C. I thought A and B will be that side, but A and B was at the bottom. So no worries. It was right. So that's why it was right. No issues. Okay. For this one, people are answering 6. So let us check beta. Now, see beta. Whenever you have a symmetrical structure, whenever you are supposed to have a symmetrical structure, please make sure that you are doing your commons, you are taking your common sense into account. See, why I'm saying symmetrical structure. So this is carbon number 1, 2, 3, and 4th carbon is getting, I mean, these 3 carbons are connected with this alkene. Similarly, sir, 1, 2, and 3. These 3 carbons are connected. So second is having methyl, second is, so they are symmetrical. You can number from that side also, this side also. So if you just think about this double bonded carbon, it is definitely having a methyl. So that means a hydrogen, but the 2 groups it is having, they are definitely itself alkene. But if at all, it is cis and it is also cis. Yes, definitely it can't be termed as, yes, it can be hydrogen, this is methyl. So it can either be termed as EZ, but no worries, because we are not here to name this alkene, rather calculate the isomers. So beta, if this is cis, can this alkene be termed as a geometrical isomer? No, sir. Similarly, if I have this, and if both these groups are same and are trans, then can I say this is optically geometrically active? No, sir, because for this alkene, this carbon, both groups are same. If both groups are same, then you are not geometrically active. You are also not geometrically active, but although not geometrically active, but I am one of the isomer. So this will be structure 1 and this will be structure 2. And when they are different, only then it can show geometrical isomers. So if they are different, then what about this C double bond C? One is methyl, one is H. So if they are different, then sir, either this can be 1 or this can be 1. You can't say this is that, or sir, both are same. So if any one is cis or the other is trans, then this guy will become geometrically active, and it will show, so 2 isomers, cis opposite to H or cis opposite to trans. So you will be get 2 options. So that means beta, you will not be having 6 isomers. The formula, that's why I say do not learn those formulas. You have to go by basic. Technically what we do, we just see geometrical stereocenters, we just check all the groups are different, and we do 2 raised to the power geometrical stereocenter. That will definitely land you to a wrong answer. I hope everybody is clear. Guys, I hope everybody is clear. If this is Sir, if they are same, I am not putting any condition on them, na. If they are same, whatever you can be trans, you can be cis. If you are same, this is geometrically active. And if they are different, then whatever your configuration is, I can't number you specifically, because I can number from this side also and that side also. So instead of 6, your answer will definitely be 4. I hope everybody is clear. Now, moving to, acha, okay, answer was 4. So let me check. Anu has just given the right answer. Now, sir, RS configuration, we have done EZ in our GOC when we have discussed GOC. So yes, no worries, no worries. Now, sir, that means, sir, we can even use that. Then we can even use that CIP rule, that sequence rule, and decide the RS configuration. How to decide it? For example, this is my chiral carbon. Now, this chiral carbon is attached with oxygen. This is also carbon. This is most prior. This is also carbon. This is also carbon. But this carbon is connected to chlorine and that carbon is connected to oxygen. So after getting tie, you again check the highest, the next atom which is having most highest atomic mass. So sir, then this will, okay, let me make this carbon separately. This is first and this will be second. This will be third and this will be fourth. Sir, how to assign RS configuration? Beta, if horizontally present functional group, if the lowest priority functional group is at horizontal position, then don't worry, just go from 1 to 2. Going from 1 to 2. How you're going? How you're going? Sir, clockwise. But because it is horizontal, so invert. So because it is clockwise, so technically clockwise means you should give a configuration R. But because it is horizontally, so I will say this is S. Beta, make sure R does not mean it is dextro-rotatory or levo-rotatory. This is just a configuration that we give theoretically. Yes. If S is experimentally dextro-rotatory, then R will be levo-rotatory. Definitely they are optical isomers, but what optical rotation it have can only be determined through polarimeter. Now, so that means, sir, if I have numbered this compound by IUPAC naming, because that is functional group, so second carbon is S. That means 2 is S. 2 is definitely S. Now let us check this third carbon. This third carbon. So this third carbon is having chlorine here, so it is 1. This is also carbon, top is also carbon, but top is connected with O, so this is 2. This is lowest priority, and this is third priority, this is lowest priority. Again, sir, lowest priority is on horizontal position, so whatever you get, just invert it. So move from 1 to 2, how you're moving? Sir, anti-clockwise, so anti-clockwise is S. So because it is horizontal, so reverse your answer, so S will become R. So actually 3 is R. 3 is R. So Bombay will be your right answer. So Bombay will be, acha, I have not checked the poll. Where is that poll? Acha, I have not given the poll. So Bombay is your right answer. I hope everybody got it. Moving to preparations for alkyl halides also, for alkenes also. Moving to preparations for alkyl halides also, for alkenes also. So what is the increasing order of reduction of alkyl halide with zinc? Answer, definitely we know alkyl halide reacts with zinc in acidic medium to form alkane. So that halogen has to move. So which halogen will move is these are greater be the bond length. So Ri will be moved easily because bond length is more, then RBr, then RCl. That means option B will be your right answer. Now, quickly do this. Time starts 45 seconds now. Quick. Normal butane on chlorination under photochemical condition gives an optically active compound P. P on further chlorination gives dichloro compound. Now you have to give the number of dichloro compounds obtained. So what is the number of dichloro compounds that you obtain after this is your answer, is your question, and then you have to accordingly answer. Quick. Chalo, let us explore it together. Sir, N-butane is this, sir. On chlorination, it gives an optically active. So remove hydrogen and add chlorine. Sir, if you add chlorine here, if you just add chlorine here, this will become optically active because this carbon will be chiral. Okay, sir. So that means this is my compound P. Now P on further chlorination. Now I have to further do chlorination in order to form dichloro compounds. Now how many dichloro compounds I can form is my question. So sir, let us use this. So let's use this beta. So if I use this P, then let me decorate this P. What are the possibilities by which I can decorate this P? So let me create few possibilities and then we'll try if we need more or not. So let me take another color for chlorine. So chlorine can come here. So chlorine can come here. So chlorine can come here and chlorine can come here. Okay. Now it is not talking about the including stereoisomers. So you just have to give the structural isomers. So sir, obviously I can see you have 4 structural isomers. So answer is definitely 4. Yes, rather if it would have been asking regarding all the isomers including stereoisomers, then you have to check those chiral carbon as well. I hope everybody is clear. I hope everybody is clear. Chalo, perfect. Percentage is less beta. So I hope everybody is clear with this as well. Next question. Where again we are supposed to give the reactions of alkanes now. Very famous reactions of NCERT alkane. Karan Bohra is saying wrong. Why, Karan? What happened? Karan, what happened? Any doubt? Karan, rather you guys attempt. By the time, let me watch that comment section. Acha, Karan, okay na? Chalo. Acha, the people are replying for this one. Keep attempting. Okay, no issues. Are yaar. Wrong cup. Acha, timer ended. Yes, definitely answer for the question is D. NCERT reaction. Sir, alkane with oxygen. This is complete combustion, so definitely correct, sir. Methane with oxygen, sir, partial oxidation takes place under copper at heated condition of 523 Kelvin, 100 atm pressure. Is an NCERT reaction. Yes. Methane with oxygen with molybdenum oxide. Beta, it will form aldehyde. So this is also correct. Every reaction is correct, but this is showing B and C only. A is also correct. Methane on combustion. Some oxidation reactions of methane are given below. Which of them is acha? It is saying controlled. So why this is wrong? Why this is wrong? Because this is complete combustion. So because question is asking controlled, hence it is wrong. These both are definitely correct. So answer is C. Perfect. Great. Attempt next one, guys. So this is isomerization. So I have 6-member carbon. So just you remove one carbon and form all the possible isomers. So what 5-member chain you are seeing? So this is my 5 for 2, 3, 4, 5, and this is a branch. So definitely C is your answer. The basic isomerization reaction of alkane. Similarly, so you can have aromatization also using vanadium, chromium or molybdenum oxide at heated temperature at 1020 atm pressure. So if you have 6-membered carbon chain, it will form benzene. Let us calculate how many carbon chain I have. So I have 1, 2, 3, 4, 5, and 6. But yes, I have a branch, so no worry, that branch will become a methyl branch, and that will definitely create aromatization, but with a methyl branching. That means you will be having toluene as your answer. Now, attempt this one, beta. Attempt this one. Giving you 45 seconds for this. Quick, attempt this one. Sir, now we have moved to alkenes after this. Now we have moved to alkenes after this. Quick. Neha is saying B. Let's check. Sir, a basic application of Sitzef rule. If I have, yes, perfect. If I have more than one beta carbon, this is also beta carbon CH2, this is also beta carbon CH. So technically I should remove this hydrogen. But if I'm having a conjugated alkene, then hyperconjugation or inductive stability is of no use. So I will be preferring this aromatic stabilized, this conjugated alkene. Hence, B will be your answer. Although this will not be a Sitzef product, rather it will be termed as a Hoffman product. So 70%, great. Moving to the next one. Try and attempt this one, beta. But yes, you have to put in your calculations cap. So this is an integer type question where integer can be obviously more. So you have to calculate also. So this is what student fear. So let us do that calculation in organic. Because yes, highly probable. Logic, it will help for mole concept questions also. है ना? Because I still remember, whenever a teacher do calculation error, I still remember that limiting reagent question I have left. Which Neha was saying, sir, answer is this only. Yaar. Why you are doing? Beta, sometimes calculation make people go mad at some point of time. Chalo, 184. Yes, superstar. Yes, superstar. Awesome. Chalo, let us do it, beta. Calculation, obviously, superstar has done for us. So you have to consider the reaction that 151 gram of 2-bromopentane. So 2-bromopentane as in 5 carbon. And at second carbon, I'm having bromine. So obviously 5 carbon as in 5 into 12 is 60 plus 80 because bromine. And I will be having 3, 4, 4 to 6, 6 to 8, 8 and 3 is 11. So I guess this mass is also 151 only because 8 and 6 is 14 plus 115. Yes, this is 151. So actually this is how many moles I have. So number of moles is given weight upon molecular mass, which is again 151. So I have 1 mole is made to react. Yield of major product P is 80%, whereas Q is 100%. So this is allowed to react. How much of this is allowed to react, sir? 1 mole. But once P is formed, efficiency is 80%. And once Q is formed, efficiency is 100%. So 1 mole would have produced 1 if efficiency was 100%. Here 0.8 moles of P will be produced. But because P to Q is 100%, so I'll be getting 0.8 mole of Q because complete will be forming this now. What is P after alcoholic KOH, sir? Now you have this beta also and this beta also. So this will be strong alkene. So I will be forming this alkene. And this alkene once reacted with Br2, so 1 second and third carbon. So second and third carbon. So let me make that here only. Second and third carbon will be getting Br. Just now moles I know and I have to give the weight. So what is the moles produced, sir? 0.8. So how much weight will be produced? Because question is asking us the weight, mass of product. So weight will be W upon molar mass. Now you do not have to just, sir, just add 80. Remove hydrogen. So 150 plus 80 is, sir, 150 plus 80 is 230 rupees. So if you just do the math now, 23, 50 for 23 is 46 rupees. If you just subtract 46 rupees, I guess you will be landing somewhere around 184. So this 184 will be your beautiful answer. I hope everybody, acha, let me just check. 184 will be your beautiful answer, not 54. Perfect. Neha, Srinidhi, perfect. Moving to, moving to a question from ozonolysis, a classic question, a traditional question. I've used this question a lot of time to help everybody remember what is ozonolysis. So what is this ozonolysis? You see the double bond. First of all, it is talking about oxidation. So ozonolysis and oxidation. What is reductive ozonolysis? You see the double bond, you break the double bond, you add double bond O. If it is oxidative ozonolysis, then you should parallelly convert all the H also in OH. So this is product of oxidative ozonolysis also and of strong oxidizing agents also. Now, here I'm using strong oxidizing agent. And this compound X absorbs 2 moles of hydrogen also. Because it is absorbing 2 moles of hydrogen, that means that it is having 2 double bonds, or rather 1 triple bond, but yes, 2 double bond is more probable because I am getting more number of products. And on oxidation with KMnO4, these are formed. That means that it is definitely having double bond. Now, approach the question with opposite sense, sir. If it is oxidative ozonolysis or strong oxidizing agent, you must have seen the double bond, broken those double bonds, and have formed these double bonded O oxygens. And if this guy is having R, or rather H, this H will be replaced by OH. So you just check these structures and then proceed in backward sense. So this is my carboxylic acid group. So this guy will be nothing but H. So this will be nothing but H. And this will be a double bonded carbon because it has got oxygen. Now, what else, sir? Sir, then I have CH2, then again I have CH2, then again I have C, sir. So that means that this will also be a double bond with methyl group because it is having no H. So this will be this only. Okay, sir. What about this guy? Now, obviously, I have 2 molecules more, but it is saying it is one same compound. So it has to be cyclic also. Yes, it has to be cyclic also because it is having 2 double bond, but still I am getting parts. So I have to connect this with something. So this will be one thing, this will be another thing, added here, added here. Okay, sir. So let me make this carbon like this. So double bond, sir, it will be done. This is OH, that means it must have been oxidized. So this will be H, and this will be having this CH3 group as well. What about this guy, sir? What about this guy, sir? Sir, this is also C, sir. So justified, sir. Now, this shall be your structure. Now, what I have to do for the structure? The total number of sigma bonds present in the compound X. Now, if this is my compound X, then how many sigma bonds I have over here? So let us count them. So 3 hydrogens, 4, 5, 6, 6 and 3 is 9, 9 plus 1 is 10, 10 plus 1 is 11, 11 and 2 is 13, 14, 16, 17, 18, 19, 20, 21, 21 and 6. So that makes 27 as your number of sigma bonds. I hope everybody is clear. A good question, a practically good question. Moving to after alkenes, moving to alkynes. After alkenes, moving to alkynes. 32, 31. No, Neha, 27. I hope everybody is clear. Guys, chalo. Perfect. Chalo, great. Attempt this one, beta. Giving you 30 seconds because I guess I was not giving poll. So let me start that process again because it makes you indulged more. C, C, okay, okay. I guess beta you should check because I guess answer is not right. Try. Chalo, let's see. Sir, I have geminal dihalide. Sir, this is a strong base. So, sir, strong base will create 1 carbon, 2 carbon, 3 carbons, 4 carbons. That means, sir, I will be getting a 4 carbon alkyne, a terminal one, because this is geminal dihalide and strong base. So, this shall be my X. Now, after this, sir, you are again using sodium sodium amide, sodamide. Sir, it will be reacting as a acid because sir, this is having H plus, acidic H plus. So ammonia gas will be released and ultimately you will be forming this nucleophile. And this nucleophile will definitely love to do SN reaction. We'll go here, remove bromine. So this 4 carbon will be added to this isopropyl group. Or what isopropyl? So to this to secondary propyl. So, acha, I have to name also. So you have to draw that structure. So let us form that structure. And this is added to this carbon who is having 2 methyl groups. So let me do the numbering, obviously from this side. So 1, 2, 3, 4, 5, 6. Second carbon is having methyl group. Then hex, then 3 ine. So second carbon having methyl, hex 3 ine. Clearly option 1. 10%. Arey, what happened? I hope everybody is clear now. Let me just give another question and I'll check if you have any doubts. So you can definitely ask them. This being the next question, try to attempt this one, beta. By the time, let me check how many of you are facing doubt. Neha is saying C ही होगा sir. Okay, still Neha, you feel so? Because I guess beta, answer is A. Chalo. Chalo, perfect. Now, the question says, I have sodium salt of carboxylic acid and because of soda lime decarboxylation, this will be released in form of Na2CO3 and I will be getting nothing but ethane. This is A. Once this reacted with Cl2 in presence of sunlight, it will be doing free radical substitution. So I will be getting chloro-substituted product. Alcoholic KOH will convert this into alkene. So this is B. Br2CCl4 will turn this alkene into vicinal dibromide. So this will be C. And alcoholic KOH followed by sodamide will convert this vicinal dihalide to acetylene as in CH triple bond CH. So definitely option C is your correct answer. Percentage is less, but I hope this is basic structuring of NCERT, which you should definitely know, how to do, how to attempt. And I hope everybody is clear now, guys. I hope everybody is clear now. Chalo, perfect. Moving to the next one. Chalo, attempt this one. Attempt this one as well. Attempt this one as well. Chalo, quick. Crystal clear. Okay, Miss Dangerous. Dangerous. Chalo. I guess time is also about to. I just want to check how many of you have attempted it properly. Chalo. Fair enough. Fair enough. Now, let me just give you a brief. Sir, this is hydration of alkyne. Markovnikov addition, sir. So here is positivity better. So first H will go here and OH will go here. But after this, sir, it will undergo isomerization. Why? Because, sir, after this it will be enol form. Let me show you that enol form again properly. Sir, here OH, this will be double bonded and this will be CH2. So after that, sir, double bond will move here, hydrogen will move here, and it will tautomerize and will give you ketone. So, sir, definitely what is A? If you just number this, this is 1, 2, 3. So I have propane, prop 1 ene with 2 second carbon having functional group, and it is undergoing tautomerism. That means Delhi is my right answer. Now, moving to the next one. Yeah, quickly attempt this one also, beta. Quickly attempt this one as well. Yes, Karan, perfect. Yes, Karan, perfect. Chalo. Quick. Now, the question says, I just want to check how many of you have done it correctly. Chalo. Less, but still, let us discuss. The question says, sir, for the given reactant X, you have to give the preferable site where electrophile can attack. Sir, electrophile is a species which wants electron richness. So this carbonyl group is electron withdrawing group. So this ring is highly deactivated. So this nitrogen is a plus R group, although cross conjugation, but this ring will also get a share of pi cloud. Now, so at S also it can go, at U also it can go. So both S and U can be a preferred position, but U will have very less steric hindrance also. And because of that, U shall be the most preferred site. I hope everybody is clear now. Chalo. Moving to some questions from aromatic hydrocarbons. This will also help us to learn aryl halides, or rather have a feeling around it. So the first question around it is in front of you. Yes, you have to read through the question. So please try. You have to select the correct statement, beta. Please make sure you are reading it properly. You have to select the correct statement. Yes. A good one, beta. Rather, this is a good one. Less percentage. 75% have said B and C. So people are confused between C and D. Yes, probably yes, you should be. But please make sure you are listening to me very properly. Now, sir, definitely anhydrous AlCl3 is a Lewis acid. It will create carbocation in these 3 carbons, and carbocation will be created over here. Sir, 1 degree carbocation is very unstable, so it will rather rearrange the hydride shifting will make this carbocation a 2 degree carbocation, and this 2 degree carbocation will be attacked by this benzene ring. And obviously what you will be forming, your beautiful cumene, which is isopropyl benzene, a starting material for phenol. The very famous reaction of phenol is subjected to this. Now, major product is normal propyl benzene. No sir, not at all valid sir, this is wrong sir. Now, isopropyl carbocation intermediate is also generated. Yes, definitely it is. Multiple substitution is inevitable. What does multiple substitution mean? Is this benzene ring, or rather is that carbocation? Because ultimately you will think, ultimately what carbocation is formed, sir? 1 degree. Is 1 degree formed? No. So is carbocation very easily generated? No. Is benzene ring activated? No. So multiple, it is saying multiple substitution is inevitable. That means multiple substitution will definitely happen. No sir. Why you are saying multiple substitution? Is this benzene very activated or not? So is multiple, sir, there may be a case multiple substitution may take place. Like for example, if this has been formed, do you feel this one hydrogen yes, this is definitely electron donating, but only because of one hyperconjugating hydrogen. So do you feel one hyperconjugating hydrogen is so much electron donating that again one electrophile will attack? No. So it is inevitable. It may or it may not take place. So this I will not say is perfectly correct, but yes, looking at option D, if you use electron withdrawing substituent on benzene ring, then any alkyl okay, if you use any electron withdrawing group on benzene will not produce an alkyl benzene. Yes. Let's say if I substitute this by NO2, then sir, this electrophile is also generated with, because 1 degree is not stable. And if I add electron withdrawing groups, sir, then electron withdrawing group may do this, that no alkyl benzene is formed. See, introducing electron will not produce any alkyl benzene. This may take place. This, because if I add a very strong electron withdrawing group, this may happen that electrophile is not even feeling motivated to do so. I hope you're getting it now. So that means B and D is your better choices. But yes, a good question, a better question to understand the theory. Moving to the last question, and after that we will again I again have to change slides, because see, I again reached 106. So whenever my max hub reaches to a maximum of 100 slides, it gets hanged. So I will not do that mistake again. So this will be the last question for hydrocarbons. Then what we are left with, sir, class 12th, complete class 12th, as in sir, the 3 chapters: solution, electro and chemical kinetics, and then sir, organic. But yes, we can browse through them very quickly, and that class 12th topic we will be taking combined. But yes, for starting that class 12th thing, let us take a 20 minutes break, because that will be an extended session, because after that I'll not be taking any breaks. So you also have some coffee, and then we'll be meeting at 6. Cool. So then we can proceed forward. Hana? So let us finish this question quick. Statement 1 says, boiling point of 3 isomeric pentane, follow the order. Normal pentane as in straight chain, then isopentanes are branching happening, neopentane branching happening a lot. More be the branching, lesser be the boiling point. Yes, this is definitely correct. When branching increases, the molecule attains a shape of a sphere. This result in smaller. Sir, this is a topic of alkane, sir. So definitely this is also correct. Actually, this is the reason also. Although it is not assertion reason, it is just asking about the correctness or incorrectness. So definitely this will give you one of the option. Now, this is 10, this is 535 beta. So let us reunite 45, 50. Let us meet at 550 now. This will be the last break, because after that I'll be having an extended session where we'll be discussing the complete class 12th, the remainder part for our chemistry revision. So last, a tea break for everybody. And yes, I want each and every student to return, because high yielding topic is waiting for us. So chalo, tea break. We'll be meeting at 5:50. Bye bye. I mean, come back, है ना? चलो. Yes, guys, I'm back. Let's start again. I hope I'm clearly visible and audible, everyone. Just give a confirmation. Yes, so I guess I just need to set the comment screen again. That means, yes. So, am I clearly visible and audible, guys? Shall we restart and successfully finish what we have planned to do? So, just give me a confirmation that okay, perfect, सही है, okay, thank you. चलो, now board, yes sir, perfect. So beta, let's start with the chapter of solution and colligative properties, and with this let us begin the discussion. The first question is in front of you. Because it is physical chemistry, so giving you 45 seconds to attempt these one quick. By the time I guess everyone would be joining in a bit. Quick beta. Yes, perfect. Chalo, perfect. Now the question says, now the question tells you that 2 moles, 5 moles of liquid X and 10 moles of liquid Y makes a solution having vapor pressure 70 torr. If pressure of X and Y at pure state is given, that means 63 and 78 are the P naught values, then what can you say? So then definitely we can calculate total pressure as P naught of X component into mole fraction of X component plus P naught of Y component into mole fraction of Y component. P naught value of X is given out to be 63, but it has to be multiplied with its mole fraction. I have 5 of these and 10 of these, as in 5 by 15, as in 1 by 3 is of X plus 78 into 2 by 3 of Y. If you just solve this, I guess PS will come out to be, this will be 21 plus this will be 3 2 is 6, 3 6 is 18, so this is 52. That means this is 73. That means, sir, it is having more pressure. So PS is more than okay, this is my PS value. So this has to be there ideally. This has to be there if it is a perfect ideal solution. But what pressure it is showing me? Sir, it is showing me 70. That means it is less. So what deviation it is showing? Sir, it is definitely showing negative deviation from Raoult's law. A very classic, a very traditional question, because yes, the question will be there, but obviously the options may change. So Karan, Sejal, perfect. I hope it is clear to everybody. Moving to the question on Henry's law. So attempt this one, beta. Obviously, I mean, you do not have to move your pen. Sir, if KH value is more, then solubility of the gas is less. This is as per Henry's law, we know. And because K of A is highest and K of this B is lowest, so B, K is lowest, as in B will have highest solubility. So highest solubility will definitely be of B, then it will be of C, and least will be of A. That means option 4 will be your right answer. I hope everybody is in sync with this. Now, I will not be indulging in the question of concentration terms, because more or less in mole concept we have done that. So quickly moving to, yes, relative lowering of vapor pressure. So Giving you 45 seconds to attempt this as well. Quick, beta. Quick. Everybody, quick. It's kilobar, beta. Yeah, yes, it's kilobar. Sir, explain how can less than A. How can less than A? I didn't get that, Karan. How can less than A as in? Okay, the previous question. I'm sorry. It was just telling beta that if you have any gas, partial pressure of that gas is equal to Henry's law constant kH into its solubility. Now, whatever concentration term you use, generally we use concentration term as mole fraction. Now, definitely beta, if a gas is more soluble, then the value of K will be less, because you will make compare two gases once you keep their partial pressure same, and then you see who is more soluble. So K into mole fraction is definitely a constant for all the gases if you're comparing them. So if X is KH is more, then solubility will be less. Chalo. Chalo. Now, moving to this question, let me see how many of you have got the correct answer for this one, which is definitely Delhi. Less percent, zero. Or yaar, what happened, guys? Come on. See, 8 gram of a non-electrolyte solute. That means that this is weight of solute and this is my weight of solvent. Solvent is octane, sir. So for octane, sir, C8, H8 2 ja 16, 16 plus 2 is 18. That means that 12, 8 is 12 times of 8 plus 18 will definitely fetch you a molar mass of 114 only. So number of moles of solvent is nothing, 118 upon 118, as in it is 1 mole. Now, I want to reduce its vapor pressure to 80%, not by to 80%. So relative lowering is P naught minus PS upon P naught is equal to mole fraction of solute, which will be number of moles of solute upon number of moles of solute plus solvent, because options are far apart. So I need not worry, because definitely it is valid for dilute solution, and dilute solution has very less of solute. So this will be approximately N1. It will ease our calculations. So P naught, let's say, is 100 rupees. Then I have to reduce this to 80%. So 280 rupees. It is pressure is reduced not by 280%. So let's say from 100 it is 80. So upon 100, now this will be weight of solute, I know, is 8 gram. Molar mass, I guess that molar mass I have to calculate. So this is M into, yes, molar mass of this octane is given also. So number of moles of solvent is 1. So that means that this is clearly 20 rupees. So 0 0 gone. So this is 1 by 5 and this is 8 by M. That means M is definitely 40 rupees. I hope everybody is clear. Moving to yes, Van 't Hoff factor calculation. So Van 't Hoff factor calculations are also very, very famous in your NEET and JEE examination. So quickly try and attempt this as well. Beta, for solution on colligative properties, you just need 4 formulas. P naught, the relative lowering, delta TB is equal to I into KB into molality, delta TF is I into KF into molality, and osmotic pressure pi is equal to CRT, that to ICRT. How to calculate I? Sir, that is Van 't Hoff correction factor. I is nothing but 1 plus n minus 1 into alpha for case of dissociation, and 1 plus 1 upon n minus 1 into beta for case of association. That's it. That's it. These 4 formulas will make your job like anything. Karan, thank you, beta. But yes, chalo, Karan is giving answer also. Perfect, my friend. So let us check. The Van 't Hoff factor I for dilute aqueous solution of strong electrolyte, barium hydroxide. What is barium hydroxide, sir? BaOH whole twice. So beta, as I already told, it will be dissociating as barium plus 2 and twice of hydroxide ion. So this is 1 plus 2, as in how many moles it is forming. One guy is forming 3 moles. So I will be, sir, it will be 1 plus n minus 1 times of alpha, because it is a strong electrolyte, so alpha will be 1. So, sir, 1 1 gone. That means for strong electrolyte, I is nothing but the number of ions given. That means it is nothing but 3. So Bombay will be your right answer. Perfect, 100%. Great. Moving forward. Now, some question on delta TB, delta TF and osmotic pressure. So quick, sir, reduce to 80% means reduce it by 20, right? No, beta. Study hard. In that case, it should be written in English, reduce by 80. Then reduce to, as in from 100 it is 80. 280. Reduce by 80 as in from 100 it is becoming 20. So by and to is the preposition which actually confuses students. So I hope everybody is clear now. Study hard. I hope that doubt is clear, beta, because that preposition definitely disturbs. But reduce to and reduce by, you should definitely have an idea how to approach it properly. Cool. Chalo. Quickly, next one. Yes, perfect. Let us explore, beta. The question says, at 100 degrees Celsius, the vapor pressure of a solution of 6.5 gram of solute. So this is solute. 100 gram of solvent. So this is solvent. Is this much, 732 mm of Hg. So this is vapor pressure of solution, 732. Sir, of solvent will be, because it is water, so this will be 760 mm of Hg. Not written, but you should know this. 180 mm is this much of mm of Hg. Kb value is given and you have to give the boiling point of the solution. For this, you need to calculate delta Tb. Sir, it will be I, because it is showing, giving no information, so do not bother about I. So it will be I into Kb into molality. Sir, Kb value is given 0.52. Molality will be weight of solute, which is 6.5. Upon molar mass of solute, no sir, I do not know that. Into weight of solvent, yes, that I know, but because it is in grams, so I need 1000 in the numerator. Now everything I know, the only thing I require is this. Obviously, what will be delta Tb? It will be boiling point of solution minus boiling point of solvent, because it is in 100 degrees Celsius. So rather let 100 only, because whatever you get, just add 100. So, but sir, beta, in change it do not even bother, because change in Kelvin also or degrees Celsius also is the same. So whatever you require, just directly use that. Now, sir, I just need molar mass. So molar mass, how you will find beta? From RLVP data. How? Sir, P naught minus PS, sir, this is 8. That means this is difference is 28. Upon P naught, sir, it is 760. Is equal to number of moles of solute. Sir, it will be weight of solute upon molar mass of solute. This I want to calculate into, sir, weight of solvent. Weight of solvent is 100. Number of moles of solvent is 100 upon 18. But yes, this is an approximated answer. This is an approximated answer, but no worries, options are quite far apart, so you can still do this approximation. Or else, I always tell my student, if you do not want to do any extra approximation, then don't do P naught minus PS upon P naught, rather do P naught minus PS upon PS. So if you exactly use 732 instead of this, if you exactly use 732, it will be exactly equal to this. So this will give you the value of M. Once you find that value of N, you can put, yes, calculation. This is a calculative question. Most of the time when colligative question comes, beta, you have to do that extra calculations from your end. If you definitely, this will be a practice for you. So if you do it, I guess delta T will be coming somewhere around 1. So add 100. So 101 will be your answer. I hope everybody is good. Chalo. Moving to the, acha, not this one. I want a question from osmotic pressure. I want a question on osmotic pressure. Okay, rather let us attempt this also. Let us attempt this also. Let us attempt this also. Quick. Let us attempt this also. Quick. Yes, option B. Perfect, beta. Great. Perfect. Chalo. Great. Chalo. So let's see, beta, what we have got here. How many of you are able to attempt it properly? Are 100%? So great. Anu, Arya, Ananya, study hard. Chalo. Let me just give you a briefing. Boiling point depression Kf is given. That means value of Kf. You have the freezing point depression for solution of molality. Sir, molality also I have containing non-electrolyte. That means I, you do not have to bother. It is 1 in benzene is. So you have to calculate the delta TF value, which will be equal to I, do not bother, Kf into molality. Sir, this is simple, but why you? Because beta, I'm just trying to tell you that solution and colligative property only ask those 4 formulas: RLVP, delta TB, delta TF, and osmotic pressure pi, which is pi is equal to ICRT. I hope everybody is clear. So Kf value is 5.12, molality is 0.078, and once you have, obviously most of you have already solved it, so once you solve this, you will be getting delta T as 0.8. Perfect. Chalo. So this brings us to the concepts of electrochemistry. So let us begin electrochemistry with this. The first question is in front of you. 3, 2, 1, go. Quick. 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 Chalo. Let's let's start. The question says, if the molar conductivity lambda m of this much molar, so concentration I know of monobasic acid is given, so that is my value of lambda m. Beta, please make sure you're seeing its unit properly. So lambda m unit is Siemens centimeter square per mole. Its extent of dissociation will be, so sir, in order to calculate alpha using Kohlrash's law, we know molar conductivity at any concentration, which we'll be solving upon molar conductivity at infinite dilution. How can I calculate molar conductivity of infinite dilution of a weak acid, let's say Ha? Sir, it will be the cation and anion. So you just add this. So this limiting value will be 349.6 plus 50.4. So this will be the added value, will be the value of lambda m infinity molar conductivity. I need to find this numerator. How shall I find this numerator? This numerator is already given to me. Why? Sir, value is given. What? Why? So this is 90. So why concentration given? Most of the time some data is given maybe to disturb you, but yes, its extent of dissociation, as in its alpha, is calculated. If you are supposed to give the value of Ka, then K for this will be C alpha square upon 1 minus alpha. Then you definitely need value of concentration, this. But it is only asking about the extent of dissociation, that is alpha. So I guess now after this, this is just I'm not saying it will be easy, but yes, you have to be careful with your calculations, and definitely you can practice you should practice these calculations. 60% of you have already done it, so great. Moving to the next one, a question from electrolysis. There are two analysis. One is the quantitative analysis and another one is the qualitative analysis. So asking about the quantitative analysis, as in how much is produced. The formula that we use is weight of any product, the electrolysis product that is obtained at electrode is directly equal to the charge that has been passed through that electrolyte. The proportionality constant becomes electrochemical equivalent, which is Z. So the formula that is given as per Faraday law is W becomes equal to ZIT. What is Z? The electrochemical equivalent is equal to E by F. What is F? Sir, F is Faraday's number. What is E? E is molar mass upon valency factor of whatever is getting extracted into IT. So please remember, because yes, a very famous formula, and this will definitely have an application in your examination. So rest is just calculation. You have to give mass of copper deposited by passing. Sir, current I know. That means value of I is 9.6487. So value of I know, I have placed. Current through a voltmeter containing copper sulfate solution for 100 seconds. So time also I know, 100 seconds. Now I need to find what is getting deposited. Sir, copper, whose atomic mass is given to be 63 grams upon copper has a charge of +2. So this will be multiplied. The valency factor will be 2 because it will be transacting 2 electron. Yes. Value of Faraday's number is approximately 96500, but they have given you exact value, which is 96487, which will also help you to do this calculation easier, because this will be clearly the 0 used, so 2 decimal over here. So in fact, add 100 over here, it will be just getting cancelled. So that's it, beta, because M, valency factor, F, IT, everything you have used. So this will give you the value of W. For calculation also, this is quite easy. This is 3, this is 1, and then a 5. So 31.5, but I have 2 decimals. So this will be 0.315. So no calculations also, beta. Good data. This is your PYQ, exact PYQ. So good, 83% of you have attempted it properly. So great. Now, yes, because we were unable to use relate conductivity with specific conductance, so attempt this one. Again, a very probable and a very highly asked formula, because here we are only discussing about concepts, beta. We can't do more questions on one concept, so rather I'm focusing that I should discuss all the relevant formula along with the questions and its application. Great. Sir, will ethine make ethanol with HgSO4? Karan, ethanol, as in you are trying to produce a double bonded carbon with an aldehyde, because ethanol will be this. Ethanol. No, beta, how can you form ethanol? This carbon need to have an H, no? But its valency, all the valencies are satisfied. No. Ethanol? Come on. You can have propanol, propene, you can have prop. Let's say for aldehyde, I need a terminal position, huh? But yes, not prop 1 ene, but it can be prop 2 ene and 1 al. First carbon cannot have both double bond and aldehyde and carbonyl group. Chalo. So I hope, Karan, is it clear to you now? Talking about this question, the question says the conductivity of a centimolar solution. So what does centi mean, sir? Centimolar as in 10 raised to the power -2 molar. So molarity is given. of KCl solution, this L has to be small, has to be this. So this is my value of beta. Please make sure you're looking at the unit also. This is Siemens per centimeter. That means this is my value of kappa. The resistance of the cell containing same solution is 60 ohms. So value of R is also given, and you have to give the value of cell constant. Very famous formula beta. Specific conductance or conductivity K is equal to G into G S stick. What is G? Conductance, which is nothing but 1 by R because the resistance is given, and G S stick is my cell constant. So value of K is given. So cell constant will be K into R. So K value is given out to be 0.021 into my resistance is given out to be 60. So you just have to do the calculation, and I guess quite easy to do as well. Let me see. 70% have calculated also. So great. Now, beta, one more thing. Let me just iterate over here only. Molar conductivity, on the other hand, is actually K. The conductance of 1 cc is K. So conductance of VCC is KV. Now, sir, this VCC is that much large volume, sir, which is containing 1 mole of electrolyte. So this V can be replaced as, sir, 1 upon this V can be replaced by 1 by molarity. So molarity will therefore come in the denominator. But now why I am saying always look after the unit because of the fact that beta unit of lambda m. Okay, if it is Siemens centimeter square per mole, then what does this mean? The molarity is mole per liter. If it is liter, then that liter will come in the numerator, and we know 1 liter is 1000 centimeter cube. So that's why the centimeter will be managed. So you use this formula. But beta, if lambda m is given in the question in Siemens meter square per mole, then most of the student make this error. Beta, now molarity is moles per liter. If liter has gone to the numerator, 1 liter is having how many meter cube? It is having 10 to the minus 3. So once it is meter cube, you have to use a multiplier 10 to the minus 3. Then obviously K also will here be Siemens per meter, and here it will be Siemens per centimeter. So that's why I'm iterating this again and again, because students do not look at the unit. Beta, please, you know everything, and if you do not use the unit properly, it will be okay. Null means CH3CHO. Ethanol, beta, that's acetaldehyde. Yes, there may be some general names also, but yes, okay. Some doctor was writing something, so yes, beta, maybe. But yes, those general names are actually quite trivial, so we rather don't focus on them much. But yes, whatever are there in NCERT, we definitely focus on them. Chalo. I hope everybody is clear with this logic. Now, moving forward. A very famous question which asks to have a conceptual understanding of electrochemistry. So redox also, and redox also, and electrochemistry also. So kindly attempt this one, beta. By the time, let me just answer some doubts, because Karan is again asking something, and I definitely have to answer and clear the doubts of the students who are regular. So Karan is asking, acha, ethanol. Okay, Karan is asking if I can form ethanol with ethyne. So yes, but yes, if you're just going to do acidic hydration, na beta, then then you can. Acidic hydration, you will add first H plus and then OH. So H plus will form a carbocation, and let's say this guy got H, so this got OH. Yes, beta, you can tautomerize now. And after tautomerization, double bond comes here, H goes there, so this is CH3CHO. Yes, definitely you can, no issues. But yes, if it is unsymmetrical, then obviously ketone will be formed. This is the simplest alkyne can produce an aldehyde. Yes, Karan. You wrote ethanol, that's why I said no. Cool. Chalo, people are answering. Chalo. Karan, I hope it's clear, beta. Chalo, people are answering. So let me just give a clarification on the option, which is Bombay, I guess. Percentage is less. Ananya is right. Let us explore why. Now, the permanganate ion MnO4 minus will liberate oxygen from water in the presence of acid, whether it will happen or not. So yes or no is because of that. So I need MnO4 minus reacting with water and form oxygen gas. That means I want oxygen to undergo oxidation, and this guy will undergo reduction. And definitely in presence of an acid, so in acidic medium, it will be reduced to Mn plus 2. Now let us see. So this value is given. Okay, the Mn plus 2 to MnO4 minus as in plus 7. Sir, that means this is oxidation potential. So what we are interested in, reduction potential. So reduction potential, standard reduction potential will be, sir, it will be plus 1.51. So this is a reduction potential of this manganese, which is actually acting as a cathode. Now, sir, what about this? From 0 to minus 2. Ha, sir. This is reduction potential, because what we compare, generally we compare the reduction potential. So who will reduce, who will have more reduction potential? So this, its reduction potential is 1.2, its reduction potential is 1.5. Sir, the reduction potential is more. That means E cell, or rather E naught cell, will be equal to E naught cathode, which is 1.51, minus E naught anode, which is 1.223. So obviously this will come out to be positive. So my cell can definitely work. And what will be the potential? Just the difference, which I guess will be 0.2 something, because 5 and 20, 0.5 and 0.2 will be definitely landing around 0.3. So Bombay will be your answer. I hope everybody is clear. Guys, I am Gujarati media. No, Divya, come on, beta. No, sorry, yaar. Come on, beta. We are here for interaction. So I really enjoy when students interact. So no, sorry, beta. Please. A teacher is a teacher because of students. So we are here because if we are able to help one, so the job is done. Chalo, perfect. Moving forward. Sir, then you move to some nursed equation question, sir. Okay, so attempt one nursed equation also. Attempt this one also. Let us practice nursed equation also. Quickly attempt nursed equation also. B for this one. Very fast gaming. So please, okay, Megan, beta, can you be precise what you want me to repeat? I will definitely do that, but be precise. I mean, complete thing. Recordings will always be there because we have to finish by 9, beta. Yes, I will. Ashraf, I will. But you just be precise. What? Chalo. Let me come to nursed equation. Sir, this is going from 0 to plus 2. If you want that explanation, beta, this is almost the same question. This is getting oxidized. Okay, sir. And who is getting reduced? Sir, silver is getting reduced. So this is oxidation, sir. And this is reduction, sir. Ashraf, the same thing I'm repeating again. Now, if you want to have this cell working, then how can you calculate EMF of the cell? The E cell of a reaction as per NERST will be equal to E naught cell, which will be E naught cathode, as in E naught of, who is acting as cathode? E naught of silver minus E naught of nickel. But E naught as in beta NCERT says you only take electrode potential as reduction potential, and that is how they have defined and decided that electrochemical series. So because it becomes a habit, so we also compare only reduction potential. Although you cannot do it, you can have an idea that's oxidation, but that minus plus sometimes confuses. So rather, what I make my students do, I always ask them to actually calculate reduction potential and then see what is which electrode, which reduction potential is more. So the cathode, if it has a greater electrode potential, it can definitely form a positive E naught cell, and then the cell can definitely function. So E cell is equal to E naught cell minus 0.059 upon number of electron transferred, which will be definitely 2 in this case, into log of concentration of product. Now for that you have to write the reaction, which is already written. So concentration of Ni plus 2 raised to the power 1, which is 10 to the power minus 3, upon concentration of silver ion, which is again 10 to the power minus 3, but because it is squared, so this becomes 10 to the power minus 6. That means this will be 10 to the power 3 plus 3. So this will be 3 log 10. E naught cell is given as 1.05 minus 0.0, rather let us say it is 6. So 0.06 upon 2 will become 0.03 into 3 log 10. Log 10 is 1. So if you just do that calculation, it will be obviously lesser than 1.05. So this can't be a case. 3 is 9. So this is 0.09. So this is 0. If it is 0.1, so it will be 0.95, 0.96. So do I have 0.96? Yes, I have 0.96. So 4 becomes your right answer. So 4 becomes your right answer, 90%. Fair enough, beta. Great. Great going, guys. Now, attempt this one. Quick. Again, a Kohlrash's law application. So molar conductivity, what is beta dissociation constant? Okay, now it is asking Ka. So you have to do that. K is equal to C alpha square upon 1 minus alpha. Alpha you will find how? Sir, this is lambda m, which is 20 upon lambda m naught. Lambda m naught, how you will calculate? Just add them. So this will be 400. So put the value, get the answer. Moving forward, because such question we have already done, I need more type of questions for you. So I need more type of questions for you. That's why I am moving forward. Yes, for delta G, I guess we have not done any question. So rather, let us attempt this quick. Let us attempt this. For delta G, we have not done any question. So let us attempt question for delta G. Quick. If you want, sir, I want to practice more questions, then beta, definitely this PDF will be there with you. Just after the live, go to PW NEET English WhatsApp channel and download these notes. So do not have to write anything, just yes, practice in your rough copy. That will be more than sufficient. Cool. B for BMW. Now, sir, for reaction this, you are supposed to tell me what is E naught cell. E naught cell is given. Okay, sir. The standard Gibbs free energy change for the reaction. So ultimately, beta, we know thermodynamically delta G is nothing but delta G naught plus RT ln of Q. At equilibrium, cell will cease to function. So at equilibrium, delta G turns 0 because no work. Q turns K. That means delta G naught becomes equal to minus RT ln of K. And similarly, as per Nernst equation, sir, cell potential will also die down. So E naught cell as per Nernst equation will be equal to plus RT upon NF into ln of K. So definitely you can relate E naught cell and delta G also. Why? Because RT ln K is nothing but delta G naught. So I'm intentionally trying to make you derive this so that you can learn it for longer duration of time. So this RTLNK will be minus NF E naught cell. Okay, I've replaced RT upon NF, so this will be rather delta G naught. So this is a very beautiful formula beta, which will also help you to know that if you add reaction, E naught cell never adds, because E naught cell is an intensive property, do not depend upon amount. But this guy, this is work, this is actually dependent upon amount. So if you add reaction, this gets added, that doesn't. But this is how you can relate that addition and subtraction. So for this question, E naught cell is given, number of electron transferred will be from +3 to +2, as in 1 electron transferred, because I'm having 2, so it will be 2. So n is value is 2. So delta G naught will be -2 into 96500 into the value of E naught cell, which is 0.24. You just have to do that. Okay, yes, but you then have to divide by 1000 also, because all the options are in kilojoule. Obviously, answer will be negative. So third and fourth can't be your answer. I guess once you solve it, option A will become your right answer. 60%. Fair enough. Fair enough. Great going, guys. Great going. Great going, guys. Huh. Yes. Attempt this one. Attempt this one. Quick. Because such questions you are definitely going to land in electrochemistry. Such numericals you are definitely going to land in electrochemistry without any doubt. So make sure you are practicing it to the T, with the formula, with the application, with the some irregularities, that whenever question plays with unit, so that lambda m thing I've already told you. Chalo, quick. Chalo. Let's check. So I hope most of you have answered it correctly. Yes, because I've already given you the formula. Molar conductivity, sir, concentration. I know this was a, sir, this is per decimeter cube. Beta, 1 decimeter cube is nothing but 1 liter. So these are some nuances that you have to learn, which obviously NTA makes. So, sir, this is just mole per liter, and electrolytic solution, which has, this is my value of kappa. So the unit of kappa is in centimeter. So lambda m will be equal to K, which is 5.76 into 10 raised to the power -3 upon molarity, which is 0.5. But because it is in centimeter, so I have to multiply 1000. So this is gone. Whatever you have, the unit will be Siemens centimeter square per mole. So I guess this is just calculation, which most of you have already done and have got option 4 as your answer. Yes, attempt the last question from electrochemistry. Attempt this last question from electrochemistry. Quick. The pressure of hydrogen gas required to make potential of hydrogen electrode 0 in pure water. How much pressure is required if I want to make the not standard potential beta, but the actual potential. Standard potential of hydrogen is always 0. It is assigned as 0. So apply Nernst equation on hydrogen electrode. So what will be, how you will write hydrogen electrodes are reduction. So reduction as in from H plus gaining electron forming hydrogen gas. So let's say make 2 and 2 over here. So this will be your reduction reaction. Sir, then electrode potential will be equal to standard electrode potential minus 0.059 upon number of electron transferred is 2 into log of. Sir, the question is asking about the pressure. So actually gas pressure will definitely account for equilibrium reaction. So partial pressure of this hydrogen gas raised to the power 1 because its coefficient is 1 upon, for ions we take the concentration. So upon H plus ion concentration, but it has to be squared. Now, sir, what I need? Sir, this is always 0 because this is standard value. This is taken as 0. I want this to become 0. So if you want this potential to become 0, then sir, this can never become 0. So only log can become 0. When log will be 0? Sir, log will be 0 when this will be 1. So if this is 1, that means pressure of hydrogen should be equal to H plus ion concentration squared. I hope everybody is clear. So now it is, sir, but I need H plus ion concentration beta. So to at 298 Kelvin for water, what is H plus? Sir, water is a neutral solvent. So H plus ion concentration is 10 to the power minus 7 molar. Because for water pH is 7, sir. So concentration is, so minus 7, that means that this will be minus 14. So pressure should be this much ATM as in minus 14 as in option Bombay. A good question, a rather conceptual one. Let's see, less percent. So I hope now people, you are clear. Guys, I hope you are clear. Chalo, perfect. Now, perfect. Chalo. So let us quickly move to the questions on chemical kinetics. Sir, chemical kinetics is also very, very traditional, sir. You just have to remember, three formulas. Let me revise. Let me make you revise those three formulas. Just chemical kinetics is a case of three formulas, sir. First, integrated rate law, which says the for first order, it says Kt is equal to ln of initial concentration upon concentration of reactant left at time t. Formula number 1. Formula number 2, for this is for first order kinetics. For zero order kinetics, sir, it is always equal to concentration of reactant at time t is equal to minus Kt plus A naught. Third formula, sir, Arrhenius equation, which says rate constant K is nothing but the pre-exponential factor, which is A, which depends upon the collision frequency, which depends upon the probability of how they are getting collided, that is deciding the number of effective collisions, and then their activation energy barrier crossing, which is decided by the exponential factor, which is minus E upon RT. Many times you will be only asked questions around these formulas only. And last one is T half, as in the time required for making the concentration of the reactants half, is directly proportional to initial concentration raised to the power 1 minus N. Sir, if N is 0, then it is directly proportional. If N is 1, then it is independent. If N is 2, then it becomes inversely proportional. Hello? I hope everybody is clear now. If you just use these formulas, chemical kinetics is done. Let us attempt few questions like this one. Quick formula, I've already told you. You just have to do that application. So let's see how many of you are going to do it properly. Quick. Study hard is saying D. Karan is saying D. D. Okay, let's see. Yes, beta. Definitely answer is Delhi. So because people are answering, so let me not wait. Stop the poll. Delhi. Check 100%. So formula I've already told you. So that gives you D as an answer. I hope everybody is clear. Some graphs also you should know. So let us practice this question in order to understand the graphs. So try it out. So reaction is given, delta H is given, it is exothermic. Okay, sir. Which of the following diagram gives an accurate representation of the above reaction? Reactant giving me product. Okay. So if you just look at the reaction beta, you cannot say about the rate. What you can just predict, because it's an exothermic reaction, accurate representation of the reaction, the kinetics of the reaction is also not mentioned, but we are only given with graphs. Let me just see. I guess information is less or what? Rate of reaction, it is showing what is X. Which of the following diagram gives a accurate representation of the above reaction? And for the reaction, you are only given the reaction and value of delta H. That means it is exothermic. So even if it is exothermic, then you should definitely know this, that rate of a reaction, which is rate of decomposition of, let's say, X moles are getting decomposed. So this is minus dx by dt. It is equal to rate constant K into concentration of reactants raised to the power order. So if it has to be constant, that means it has to be a zero order kinetics. And definitely in that case, beta, but we do not know anything about order. The only thing we know, yes, this value we know, so we can calculate in terms of activation energy that reactant are forming product, and because this is negative, so delta H is enthalpy of product minus enthalpy of reactant. So reactant enthalpy will be more in magnitude, which is definitely shown over here that it is more in magnitude. And but value of delta H as in beta, this shall be the value of delta H. The magnitude of delta H will not be this, because that becomes the activation energy. Although it is not showing the graph from, it is showing you graph from somewhere around here. This is no man's land. This will be your activation energy. So yes, beta, I guess this question has some typo error. So let us not indulge in misinterpretation. I guess this has some maybe graph. I guess this was typed by the DTP. So maybe it is having some error. So so that is what I'm not saying, beta. I'm not saying, because that graph is also not relevant. Although this enthalpy of, but this only this shall be delta H. It is showing that is delta H, and what is this? It is not mentioned. So obviously it has some typo error. Obviously the main NEET would not have asked question of this sort. So let me just stop the poll and say sorry. Still people are saying C. No, beta, I'm not saying it's C. It has some typo error, so be it. Now, rate constant of reaction is given. Now look at the value. Achha, one more thing also. So attempt this by the time I should tell you this logic also. That sometimes, like in the previous question, nothing was mentioned. Here also nothing is mentioned, but unit of K tells about order of reaction. How? Sir, unit of K will be what? Sir, unit of rate upon unit of concentration raised to the power order. Unit of rate will be moles per liter per second, because rate is change in concentration upon time. This is mole per liter raised to the power n. So that means unit of K will be mole per liter raised to the power 1 minus n into second inverse or time inverse. Beta, if your value of K is only having time second inverse, that means this is not present. That means this is a first order kinetics. So definitely, sir, first order kinetics, now you know everything. You can use the formula KT is equal to ln of A naught upon AT. And once you do that, you will definitely get 69.3 as your answer. So I'm not indulging in all those calculations, because in initial only, I've given you the formula. I hope now this is just the application of the formula. The more you apply, the more confidence you get, beta. है ना? And in order to get that confidence, you have to work more and more, practice more and more questions. So now, let us do one question on Arrhenius and collision theory. So a numerical, yes, definitely asked. I've already given you the formula. So yes, please do the calculation and have the confidence, the relevant confidence of attempting those questions in the D-Day, which is just 5 days from now. Quick. Quick. A. Okay, A. Everybody's A. Okay, so A. Let me also do A. Perfect, perfect. But still, let me iterate the question. The rate of reaction quadruples. Quadruple means it becomes 4 times. When temperature changes from this to this, that means this is delta T is 30. Calculate the energy of activation. So I have to calculate energy of activation. So we definitely know, sir, K2 upon K1, because I'm using two different temperatures. So A will be gone. So I'll be having E raised to the power minus activation energy is same, but this is EA upon RT. So rather, let us first write the logarithmic form. So we know K is equal to A into E raised to the power minus E upon RT. So ln K will be equal to ln A minus E upon RT. So if you write K2 and K1 at T1 it is K1, at T2 it is K2, then obviously you subtract it. So you will get ln of K2 by K1 is equal to, this will be getting cancelled. You can take out EA upon R common. So it will be T1 minus T2 upon T1 T2. I hope everybody, I guess T2 minus T1, I'm sorry, T2 minus T1 upon, because T2 you are generally increasing temperature. So this is the form we remember, T2 minus T1 upon T1 T2. So just take it as log. So log of this is getting 4 times. So 4 by 1, because if it is K, it is 4K. Question is telling you. EA value I do not know, sir. R you can put as 8.314, rather for your ease of your calculation, write 8.314 as 25 by 3. Sometimes it helps like anything. T1, T2 difference is 30 rupees. But yes, the value you have to put in Kelvin. So this is 300 degrees Celsius, which is 27 degrees Celsius. And then add to it, add 30, so 330. So yes, now calculation you have to do, whatever EA you will be getting, divide by 1000, and then you will be getting A. People are saying A, so obviously A is your answer. But yes, you have to be vigilant regarding your calculations, beta. Now I hope we have done this type of question we want. So let us attempt this. Sir, this is one another type of question you get from chemical kinetics, which is differential form of rate law. Now, what is this differential form of rate law? This differential form of rate law just tells you that rate of a reaction is equal to rate of decomposition of reactant, which is the reactant as in minus d by dt, because it is getting decomposed or disappear upon stoichiometric coefficient. So what is the stoichiometric coefficient? 1. So I have 1 in the denominator. It will be equal to rate of disappearance of another reactant, which is hydrogen in this case, upon stoichiometric coefficient, which is 3. It will be equal to rate of production of product, which is d by dt of the product, which is ammonia, upon stoichiometric coefficient, which is 2 in this case. So just remember, you have to use these stoichiometric coefficients very, very properly. I hope everybody get it. I hope everybody get it. Now, how the question can trick you, just giving you an idea, because yes, I feel it's a very probable question for your NEET also. Like for example, I'm telling you that x times of A is giving you y times of B. है x times of A is giving you y times of B, and I am telling you that minus d by dt of A is equal to plus d, or rather log of d by dt of A minus d by dt of A is equal to log of plus d by dt of B plus 0.3. So can you tell me what is ratio of x by y? Yes, definitely such questions can trick you, because this is just mathematical playing. Sir, then definitely I can say log of this is equal to log of, but sir, what is that? That is 0.3. So beta, you can obviously predict that 0.3 is nothing but it is log of 2. So if that thing is log of 2, so log of a plus b I can apply. So this will be log of a into b. So this will be twice of d by dt of concentration of b, and it is equal to nothing but this. So if log of this is equal to log of this, that means values are also same. That means this is equal to this. That means minus d by dt of a will be equal to plus d by dt of b. But sir, I have a 2 also, but beta, you will not use that 2 over here, na? Rather bring that 2 over here. That means this is that coefficient and this is that coefficient. What coefficient? Which I'm talking of. So x shall be 2 and y shall be 1. So x is to y shall be 2 is to 1. I hope you get it. I hope you get it, guys. So these are just mathematical playing. These are just some mathematical playing. I hope everybody get it. Guys, I need confirmation. I need confirmation. Guys, I need confirmation. Whoever has got that, at least say yes, because with this, I will be moving forward with chemical kinetics too. Then we'll be moving to organic chemistry of class 12th. But I will not be moving until unless I am getting confirmation of either one student who is actively listening to me out of these 80-90 students. Jain Sahab is here. Thank you, Jain Sahab. Then I have Dhruva. Then I have Yash Raj. Then I have Parv. Then I have lot of I have lot of serious students. Okay, beta, okay. I am happy. Beta, master just require this much. If you give so much, then master will be overwhelmed. So thank you. Chalo, moving forward. Now beta, that means we are done with chemical kinetics, because then these are the same questions. Chalo, attempt this one. Attempt this one. Attempt this quick. Attempt this quick. Value of x and y you have to give. Differential rate law is given, the correct statement among the following. So obviously you have to give the value of x and y. This becomes very easy. We have done good question than this. But yes, see, that's why I said that was a quite probable question. That's why I said it was a very probable question. So see, but yes, mathematical playing will definitely make your question good, better. B. Arya is saying B. Now everybody is saying B. Just check, beta. I guess this is not B. C. Rate of decomposition of A is equal to B is equal to C. But sir, I do not need coefficient here. So this is 1.5. So obviously this has to be 3 by 2. So if it is 3, then I have a 2 in the denominator. So if I compare value of y, this y, 1.5 is definitely 3 by 2. So it will be 2 by 3. So this guy will be 2 by 3. So this will be 2 by 3. Okay, so let us compare first A and C. So minus d by dt of A will be equal to 3 by 2 times of d by dt of C. So 3 will come here. So I will be having 1 by 3 minus d by dt of A will be equal to plus 1 by 2 d by dt of c. That will clearly suggest that if I compare A and C, then stoichiometry is 3:2. For A and C, stoichiometry is 3:2. Now, comparing it for B and C with another pen. So comparing it with B and C, so I can again say minus d by. So obviously you can say with that sense only that d by dt of B will also be equal to 3 by 2 times d by dt of C. So 3 by 2, so 2 I am again keeping over here, like in case of comparing with A, and 3 will be gone here. So ultimately 2 moles of C I am getting if 3 and 3 of these are taken, because with each the proportionality shows the same. So this shall be the best possible scenario. So Y is 2, no sir, definitely incorrect. All are equal, definitely incorrect. X and Y are equal and equal to 3, yes sir. X is 2, definitely incorrect, as in C is your answer, beta. See, 46%. So see, the same question I have given you, and the reason, because yes, a very probable one. So I was not seeing this question, so I just made by myself. Okay. Sir, can you please the previous question? Okay, Yuru. Previous question, which one, beta? The same concept I was telling, beta, but yes, with some mathematical tricking. So see, log, you if you give log also, so log of anything plus 0.3, so 0.3 is nothing but log 2. So log A plus log B is log A into B. So you compare the value and then again do this cross multiplication and get those coefficients, so you can have a prediction of the ratios of the coefficients. That's it. Hai. Done? Chalo. So beta, this brings us to an end of chemical kinetics also, starting with the basics of the high probable, and the question which you should never leave, just see, tick and move forward, the organic chemistry, the good old organic chemistry of class 12th. So physical class 12th also we have finished. Yes, not many questions, but yes, all the logics, all the probable logics I have definitely tried to communicate. And with this, we are moving to the organic side of chemistry, starting with alkyl and aryl halides. Although most of this alkyl and aryl halides we have already seen where, sir, once we have discussed hydrocarbons. Chalo, moving to the first question, which obviously I feel not even 30 seconds will be required, but still question is there in front of you. So please have that confidence and try to give an answer. Now, which the compound that will undergo SN1 reaction with fastest rate? Sir, for SN1, I need to form a carbocation. So who will form the stable carbocation, sir? This will be benzylic carbocation, sir. So this will be most stable, sir. That means Delhi is my answer, sir. Perfect, 100%. I hope everybody is good. Moving to next one. Quick. The question says, the incorrect statement regarding chirality, as in whenever you have an optically active compound, you will definitely have an optical stereocenter. That optical stereocenter will be a chiral center, an asymmetric center. So racemic mixtures shows zero optical rotation. Yes, this is correct. Although not about chiral, but still it is correct. SN1 reaction yields 1:1 mixture of both enantiomers. Yes, sir, because SN1 actually creates a racemic mixture. So yes, so correct. So not an answer. The product obtained by SN2 having chirality at show inversion. Yes, sir, inversion, Walden inversion, sir, we definitely know. And fourth one is enantiomers are superimposable mirror image. No, no, sir. Enantiomers are non-superimposable, sir. They are non-superimposable. So this is incorrect, and because incorrect, so an answer. So that's why I'm saying, beta, you beta, I hope 40% only. I hope everybody is clear. Beta, in organic chemistry is very, very doable in your boards also, in your mains NEET examination also. You just have to be confident with your NCERT. That's it. Anna? So I'm just trying to make you practice the relevant questions. Bringing us to the next one. Yes, attempt this one, beta. Quick. Quick. Which of the following biphenyl is optically active? Now, the most famous stereo center you know is a chiral carbon. The most famous is a chiral carbon. But chiral carbon is not the only stereo center, beta. Apart from chiral carbon, you can have many other stereo centers as well. Now, sir, who are those stereo centers? Sir, if you have cumulated alkene, sir, pi and pi just next to each other, then, sir, even number of pi cloud are also having asymmetry, hence they are also chiral center. Again, a very famous compound which is biphenyl, because when biphenyls are ortho substituted, these groups will repel each other, and because their repulsion, what happens, this biphenyl, like for example this is like this, so this one of the group gets inverted, so one is in the plane only, one has got inverted. So what does this bring, sir? Repulsion has reduced. So because of this, the plane of one ring is, let's say, let me remove that pen or else pen will fall. So let me use my hands. Okay. So whenever you have bulky groups, the one of the ring becomes perpendicular to it, so that the groups can freely orient in three-dimensional space. But now, if you make the mirror image of this, it will not be superimposable. That means that it has become an achiral center. So these ortho substituted biphenyls also act as an optical stereo center, a basic, but yes, not a traditional one, but yes, you should know. So 76% of you know it, so I'm happy. Moving to most of the questions we have discussed, beta, for alkylides in the chapter of alkanes only. So acha, chalo, do this one quick, although from alcohols, but yes, now I am giving you a mixed packet of all organic chemistry, because sir, you can't restrict a NEET, and NEET actually does it, JE actually does this, NEET, NTA actually does this. They couple whole of your organic chemistry and constitute questions which are not chapter specific, rather they are conceptually specific. I hope everybody is good. Chalo, perfect. Okay, beta. Even now I want to actually make I want you to have best possible time with yourself while practicing these questions by yourself. Just after the live is done, download them, and yes, definitely practice them hard, because they are very, very selected questions. But yes, I will be definitely telling you one thing, that we are just left with approximately class 12th chapters. That too, organic we have done, organic we are doing, physical we have done, inorganic we have already discussed in chemical bonding and periodic table. But yes, some coordination and D block questions we will be doing, the highly probable questions. So it will be taking around another 1 hour or maybe 1.5 hours. That's it, because after that even I don't feel I'll be able to stand. Chalo, so है ना, चलो, बस लो फील कर रहा. Okay, चलो. I hope everybody has attempted this one. Now, the structure of intermediate A in the following reaction is, sir, first of all, on oxidation, this benzylic hydrogen will get oxidized, and you will be having cumene hydrogen peroxide. This is also methyl, and this is also methyl. Post hydration, sir, rearrangement will take place, and I will get phenol and acetone. So this is classic method of preparation of phenol using isopropyl benzene called tumene. That means, sir, definitely this is NCERT fact, sir. Bombay is my answer. Perfect. Moving to the next one. Yes, quickly attempt this as well, beta. Very, very probable questions, very, very logical, and NCERT demanding questions. Quick. Divya is saying there is no poll in the chat. I guess we have, but why you want me to show that poll? Let me see. Okay, after the poll I will see. Beta, we have very less time. Matlab, yes, you have very less time. So rather invest that valuable time in attempting our logic. Cool. Chalo. I hope most of you have attempted it correctly, which is definitely C, less percentage. So let me give you an analogy. Why? Identify the major product. Okay, sir. First, I have benzene. Then this is beta. Same question we have seen in the chapter of hydrocarbons. Once we have discussed, sir, carbocation will be formed, but sir, this is 1 degree, not at all stable. So hydrogen hydride shifting will take place, and I will produce a secondary propyl carbocation. Now this shall be reacted, and I shall be forming a product which we have just seen as a reactant for preparation of phenol, which is nothing but cumene. So this is P. So then this is the same reaction, sir. So see how much it is important, but still less percentage was there. So Q and R, that means, sir, again phenol and acetone. So P is cumene, P is not this, P is cumene, yes, sir. Phenol and acetone, okay. This will not be oxygen. Obviously, you can see the carbon is having already 4 bonds. So how come it can make a bond with this oxygen? So this is a typo error. I hope everybody is clear. Now, again, some very, very important reactions of phenol. So talking about the next important reaction, which is obviously Riemann and coal-based reaction. One forms salicylaldehyde, one forms salicylic acid. So here we have salicylaldehyde. Why it is so? Once chloroform is reacted with a base, then this chloroform, which is acidic because of 3 electronegative chlorine, hydrogen is removed as H plus, and this carbon is capable enough to take the extra electron, or else carbon never acts as an acid. But because of demand of these electronegative group, this will rather act as an acid, but the moment it will gain a negative charge, Cl minus will be departing, producing dichlorocarbene. Although this carbon is having 1 lone pair, but still it is having 6 electrons in its valence shell. That means it is still electron deficient, and it will definitely act as a electrophile. This electrophile will be attacked by the benzene ring. Why? Because in basic medium this will also form phenoxide. It will form electron density at ortho and para position. At ortho position, the reaction is favored because the product after hydrolysis will be intramolecular hydrogen bonding stabilized. Hence the kinetics takes the reaction to that direction more. So definitely who is my attacking species, the electrophile, which is definitely dichlorocarbene. Moving to comparison of acidic nature. So sir, again sir, this also we have done in GOC, but still we have done GOC also, the relevant questions. So yes, please beta, all those who have not been there since morning, since afternoon. Why morning? I've started at around 11:10 or 11:15, but yes, please make sure that you download these notes and watch these recordings beta of especially today's session. It is definitely going to help because I have been highly specific with the relevant content, very, very relevant content. Cool. Chalo. Perfect. So people are answering. I'm happy. Answer for this one is time is about to end. Yes. The answer is C for this particular case, 87%. So just let me give you an idea, but still 12% have not attempted it correctly. Beta, hydrogen is not applying any group, any effect. It is applying plus I. So sir, electron donating group will decrease acidic nature. Sir, more plus I, sir, very much plus I. So definitely a very easy question. But yes, I would definitely like to educate you on one thing, that if you compare any aliphatic carboxylic acid, if you compare any aliphatic carboxylic acid with aromatic carboxylic acid, then I definitely have this for you, that this will apply minus I, and because of this it's minus I, aliphatic carboxylic acids are always strong acid, and they are always aliphatic are always weak acids. But if you compare this benzoic acid with formic acid, then I would rather say this is a more stronger acid. Why? Sorry, it is minus I. Beta, this is minus I, but this is plus R also. This, it's minus I as, because obviously we have defined these acidic nature on the basis of the values of dissociation constant Ka. So if you compare this with formic acid, then hydrogen is doing no profit also, no gain, no profit also, no loss also. Although phenyl is applying minus I, which is comparable if you compare with aliphatic carboxylic acids, but once you compare with it formic acid, you will say because this is minus R, that means this is plus R also. So for hydrogen, because none is happening, so formic acid is even a stronger acid than benzoic acid. I hope everybody is good. Chalo, moving forward. Moving forward. Yes. Yes. Sir, questions of ozonolysis are also very, very famous. So kindly attempt one, because they will be method of preparations of aldehydes and ketones. So kindly attempt this one quick. Chalo, quick. You have to give the major product. Sir, KMNO4 is a strong oxidizing agent. So what does strong oxidizing agent do with alkene? It break the double bond and add double bonded oxygen. So double bonded oxygen added here also. Rather, let me make it beautifully. Double bonded oxygen added here also, here also. And because, sir, it is a strong oxidizing agent, so it will not leave that carbonyl carbon. It will now convert that carbonyl carbon into OH. That means that if this is H, it will turn into OH. If this is H, it will also turn into OH. That means both the compounds are same, as in you will be getting a cyclohexane attached with COOH, but 2 units. So, acha, हाँ, not okay, okay. I'm sorry, I'm sorry. C bond C will not break, beta. C bond C will not break, because oxidizing agent has a function, has a property of breaking of. Acha, हाँ यार, come on यार. Double bond will definitely break यार. This will be broken. This will be broken. Hey, come on. See, see. I guess. Chalo. See. Alkenes, sir, it will be broken, double bonded. Oh, this can even be done by reductive ozonolysis. But yes, strong oxidizing or oxidative ozonolysis will further convert all the H also in OH. So this is the action of strong. So this will definitely be broken, and hence Bombay will be your answer. Perfect. So Bombay will be your answer. Hey? Beta, this is KMNO4, yaar. Come on. It is not written cold aqueous alkaline. It is not written cold aqueous alkaline. It is not written cold aqueous alkaline KMNO4, because cold aqueous alkaline KMNO4 is Bayer's reagent, which will just break the pi bond and form vicinal diol. Formation of aldehyde is nowhere possible. Aldehyde will be formed once you will be having reductive ozonolysis, as in ozone followed by zinc and water. So if this is, although it may have typo error, but if this is your question, that is what I'm saying, vlogs, you must be seeing, or I remember, but if there is a typo error, then I will consider this as my question. I will not even consider there is some extra information given. So if point blank KMNO4 is given, I will definitely take it as a strong oxidizing agent. I hope everybody is clear. Chalo, moving forward. Chalo, next one. Attempt this one. Attempt this one. Chalo, perfect. Attempt this one. Time starts in 3, 2, 1, go. With this, we are practicing, I guess, aldehyde ketones now. With this, we are practicing aldehyde ketones. So make sure you are attempting it with whole of your heart and soul. Right? Chalo. Quick. Chalo. Complete the following reaction. Okay, sir, completing. So Cn minus will first attack and form cyanohydrin. So this will be CnNOH. Perfect, sir. And post post reaction of consent. Sir, concentrated sulfuric acid is a dehydrating agent also. So if you see this alcohol, then beta carbon is this also, this also. So this will give OH, this will give H. So I will be getting an alkene also. But sir, hydrolysis can also be, oh, sir, this will do hydrolysis also of nitriles. So nitriles, once hydrolyzed, will form ammonia gas and COOH. So double bonded carboxylic acid is option 1. So A is your answer. Perfect. 93% of you have got it. Awesome. Moving to the next one. Attempt this beta. Quick. A statement based question. Rather, reading statement is sometimes very not doable for students, but please make sure that you have a habit of reading question properly. Please make sure you have a habit of reading questions very properly. Boiling point of aldehyde and ketone are higher than hydrocarbons of comparable molar mass because of weak molecular association in aldehyde and ketone due to dipole-dipole attraction. So definitely beta, boiling point of aldehyde and ketone are higher than other hydrocarbons because carbonyl compounds are highly polar because of this carbonyl group. So they have strong dipole-dipole attraction. That means this is definitely correct. Now, statement 2 is saying boiling point of aldehyde and ketone are low than alcohols. Yes. So this has high dipole-dipole attraction. But sir, alcohol has a tendency to do hydrogen bonding, sir. So definitely, if you compare them with alcohols, comparable mass, then alcohols will have higher boiling point. So that means this is also correct. That means both your statements are correct. That means option Bombay is your right answer. So let me check. Chalo, I hope everybody is clear now, beta, because I have got chalo, attempt this question, beta. Let us revise Cannizzaro and aldol condensation. Again, a very probable question for your examination. So attempt this one quick. Quick, very probable beta. This Clemenson, Cannizzaro, Cannizzaro and aldol condensation, self aldol, cross aldol. So let us practice those questions as well. Quick. People are saying C, C, C. People are saying C, C, C. Chalo, let's check beta. Now the question says, which of the following is not formed when acetone react with 2-pentanone in presence of dilute NaOH? So I have to make reactions of acetone. And what reactions of acetone? Sir, aldol. So let us learn aldol condensation with this beautiful question. Yes, a basic NCERT question, but still. This is, sir, acetone. When acetone reacts with, okay, so you do not have only acetone, you have acetone, and what else you have, sir? I have 2-pentanone. So pent as in 5 carbons. And at second carbon, I'm having this double bond O. Sir, what will be the major product? Beta, major product it will be whenever you will be having cross product. So let us first make the cross product. Sir, how to make cross product? It is very simple. How? So let's say this alpha carbon will attack this carbonyl group. So ultimately, when this carbonyl group will be attached, this carbon will get this double bonded O will become OH. Now, OH of this carbon because this will be the carbonyl group, this will be alpha carbon, and that will be beta carbon. So that beta carbon will lose OH and this guy will lose H. So ultimately this has lost 2 hydrogen. So this will be double bonded with this carbon. This will be double bonded with the attached carbon, and you will be forming your alkene, alpha beta unsaturated product. So let us first make this nucleophile, let me call it as A. So once A nucleophile will attack B, once A nucleophile will attack B, how will it look? Sir, CH3. Sir, this C having double bonded O, this carbon will become CH, 2 hydrogens gone, and it will be double bonded with this carbonyl carbon, sir. I hope everybody is clear. Now, it will definitely be having one methyl group, sir, and it will be having 3 carbon chain. Now, let us quickly, let me quickly, yes, obviously answer, let me mark answer and see how many of you have got it. 85%, but still better. But still, I want you to actually just revise Eldol with one question. So I'm making this question properly for all those who do not know. So this is 1, 2, 3, 4, 5, 6, 7. That means, sir, I have 4 methyl at 4th carbon and then 7 carbon chain. So methyl at 4th carbon, and let me number all of them. So this is 1, 2, 3, 4, and then 5. So I have a 4th carbon methyl and 3rd carbon ethyl. I'm just seeing because I have to check all. This is 1, 2, 3, 4, and 5. So this is methyl. So I guess you are visually seeing this because at 4 carbon you should have a methyl. Okay, but I have a 7 carbon chain. So no, sir. What about this? Sir, this will be 1, 2, 3, 4, 5. Then 6, 7, you can go anywhere. So this is 6, this is 7. 5th is having ethyl and 4 is having methyl. What about this guy? Sir, 1, 2, 3, 4, 5, 6, and 7. 4th carbon is methyl. So I guess you can see 7 carbon, 4th carbon having methyl, 2nd carbon. That means, sir, this is formed. So because it is formed, so not an answer. What is this? When A nucleophile is attacking B. Okay, sir. Now, when, sir, other thing is happening, so A nucleophile attacking B, we have done. Now, if B nucleophile, first let us make cross product. So if B nucleophiles are attacking A, sir, how you will form that? I guess you know the process now. So B nucleophile, sir, this will attack or this will attack. Now you tell me, sir, if this carbon will attack, sir, let's say it has formed a carbon ion. So this carbon ion will be 1 degree. That carbon ion will be 2 degree. But sir, it will be having more affinity to give electron. That guy will be having more affinity to give electron. This guy can also form, that guy can also form, but this guy will be having more affinity. Sorry, this will be 1 degree carbon ion, this will be 2 degree carbon ion, and ultimately when this carbon ion is giving electron, who has more susceptibility to give electrons? Sir, this guy. So let us make this carbon attack. Okay, sir. That means, sir, 1 carbon, 2 carbon, and double bonded O. Then this is my carbon, sir. It'll be having these carbons and as ethyl, and it will be double bonded, sir. This will be double bonded with this carbon, and this carbon is having 1 methyl and another methyl. Now let us number this. So this will rather be 1, 2, 3, 4, 5. 5-membered carbon chain with 4 having methyl and 3 having ethyl. So 5-membered carbon chain I have here and here. This is again 7-membered. So 5-membered carbon chain having, so this is 5 at 4th position methyl, at 3rd position ethyl. So this is also formed once B has attacked A. Now I need self-aldol. So self-aldol of acetone and acetone will form a 6. Okay, let us do self-aldol of A. So when A minus will attack A, what I am going to form? This will be quite easy. CH3, this C having the CH3 branch, this carbon will be double bonded with itself only, as in with this only, which is having C and C. So, sir, how many carbon chains you are having? Beta, I'm having 1, 2, 3, and 4. Do I have any 4-member chain? No, sir. So this is not given, sir. So let us do self-aldol of this in over here only. So once this compound will form, so this C double bonded C, 1 I'll be having ethyl and okay, why 1 beta? Why 1? Let me make it again. This is double bonded O. So this carbon can also do, but this will be a better base. So I will ask this to attack. So this is double bonded. Once this carbon will attack, I will be having 2 ethyls, and it will be double bonded with whom? With this carbon, which is having 1 methyl and which is also having 3 propyls. Let me number this. So this will be 1, 2, 3, 4, 5, 6, and 7. Third is having ethyl and fourth is having methyl. So 7 member. Yes, 7 member, but I don't see, so this is done, this is done. This is 5 membered. So this is 5 membered, na? Acha, acetone once have attacked acetone. Okay, I guess this I have made improper beta, because acetone once attack acetone. This is CH3, this is CO. This guy will attack, no? This CH will be double bonded with this carbon which is having methyl methyl. Okay, I am sorry. So that's why beta you need practice, because I'm clumsing everything, that's why. So at fourth carbon I'm having methyl, at fourth carbon I'm having methyl. That means this is also formed. So obviously this is my answer, because all of them has been formed. You do not have to form that, but still I have done it. So let us see. 7 member chains are 7 member chain. Third is having ethyl, so third should have ethyl. So this is not obviously that structure, so obviously this is my answer. But a very good question for practicing, a very good question for practicing. So at least make this question, attempt this question few times in your rough copy. It will give you great amount of confidence. I hope everybody is clear. I hope everybody is clear. Chalo, perfect. Now, sir, that means for aldol also we have done quite bit of practice. So quickly moving to amines. Quickly moving to amines. Now, for amines, the major product of the following reaction, sir, this is phthalic acid. So phthalic acid, sir, any carboxylic acid, once it react with ammonia, followed by strong heating. If it is only reacting, product will be salt. Post heating, you will be forming amide. Definitely understood. But you tell me, because heating is strong, so can't one more ammonia molecule will be released? Yes, sir. Because, sir, compound also wants to form a stable 6-membered cyclic structure, which it is successfully making. 1, 2, 3, 4. Okay, 5-membered structure. 5 or 6-membered structure. 6 is actually free from any type of Bayer strain, but 5 and 7 are also fair enough. So where you find this compound? Option 2. So option 2 becomes your right answer. Moving forward. Yes. Let us quickly attempt this one as well. Time starts in 3, 2, 1. Go quick. Of the following, the options that you have, which is the product formed when cyclohexane undergoes aldol condensation? So you want cyclohexanone. So this is cyclohex and then cyclohexanone undergo self, sir. Then ultimately this guy will be attacking. So, sir, let us make the attack, sir. So this guy will attack. Let us explore step by step. So this is your cyclohexanone. This carbon will become CH and it will attack the double bonded O. So it will become OH. So OH of this, H of this will be gone. So why doing more labor? Rather remove H directly and form double bond. So this is it, sir. So 2 rings, the carbon having carbonyl group, the next carbon, the carbon having carbonyl group, the next carbon is forming double bonds. So obviously C is your answer. Good. This is just a drawing. Eh? Beta, I hope everybody is clear now. C is your answer, guys. Guys, 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 guys. Guys, 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 guys. Chalo, let me check your comment screen. How you guys are doing. Okay. Okay. Chalo. Anybody? Any doubt? Okay. Perfect. Keep on attempting. Chalo. Perfect. Now, sir, the correct order of strength of carboxylic acid you have to give, sir. The correct order of strength of carboxylic acid you have to give, sir. So let us check the carboxylic acid strength, sir. Sir, this is a carboxylic acid which is, I mean, no substitution. Simple cyclohexane and carboxylic acid. Okay, sir. Sir, this is a carboxylic acid which is having oxygen. Although this oxygen can't do any resonance, but ultimately because this is oxygen, so it can apply minus I. That this can also apply minus I. But here, this minus I is 1 carbon, 2 carbon away. This is 1, 2, 3 carbon away. So this can apply the inductive effect to a lesser extent, but yes, still better than first one. So because if it, sir, because obviously if oxygen is applying plus R, then it will be bad. But because oxygen is not in conjugation, so definitely it can apply minus I. So, sir, second will be most acidic, then 3 and then 1. That means option Delhi is your right answer. Less percentage, but I hope now, guys, you are happy and clear with this too. Moving to the next one. Yeah, quickly attempt this one. 3, 2, 1, go. Identify the major product C formed in the reaction sequence. So I have a reaction sequence and you have to identify the major product that you can form. Okay, sir. Sir, this is iodopropane. Then NaCN will do Cn minus, so substitution will take place. So I will be getting 3 carbon, but the 4th carbon will be triple bonded N. Now, sir, partial hydrolysis will make it amide because partial hydrolysis will not release ammonia. The sigma bond will be waiting. So this is 4 carbon amide, sir. That means this is B, sir. And NaOH in presence of, sir, this is Hoffman bromamide degradation. So this carbonyl group will be removed and I will be getting amine, 1 degree amine with 1 carbon less. That means propane 1 amine. So propyl amine is my answer. That means C is my answer. Beta, I guess maybe poll is not working or there is some issue. I guess everybody is clear, guys. Now I'm not going to move till I get yes, yes, yes in the comment section, and then definitely you can answer this. But please, I need your confidence now because I feel the percentage was initially was very great. So I need yes, 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 or else if you have any doubt, please ask. Okay. Yes, sir. So KHXN, Caxon. Thank you, beta. Manish, good. Sudha, good. Manish, good. Acha. Okay. Now once you start writing, yes, yes, I can't even read your name. Then such is then gone. Chalo. Keep on interacting so that at least I remember names. So actually, although we can't, you can see, but I can't see you. But so actually, let me give that blessing by saying that name. Sometimes, even it is said in a 24-hour frame, everyone has a duration where whatever they say comes true. So today we have been together for practically the whole day. Chalo, great. Rockstar has taken break. Neha is gone. Chalo. I hope most of you have answered. So the answer for this one is obviously Delhi. 93%. Great. Sir, reactions U which will not give primary amine. Sir, obviously this will give a 2-degree amine. Hence, this is my answer. Most of you have attempted it quite properly. So moving to the next one, 3, 2, 1, go. Quick. The product formed from the following reaction sequence. Sir, with LiLH4, I'll be getting 1-degree amine. 1-degree amine. Sir, with NaNH2, that 1-degree amine will turn into diazonium salt. And with hydrolysis, so let me make it. So with LiAlH4, this will be benzene, sir, CH2, NH2, 1-degree amine. With diazonium salt, this will be phenyl, CH2 and N2 plus. And post hydrolysis, it will be phenyl, CH2 and OH. So I'll be getting benzylic alcohol. So I need a carbon also over here. That means 1 is my right answer. 50%. Chalo, I hope it is clear to everyone now. Moving to the next one. Yes, although very probable question. Beta carbylamine test is formation of isocyanide, which is a characteristic test for 1-degree amine. Please remember, very important, very important, very, very important. Answer this. 3, 2, 1, go. Beta, basic nature of amines is decided by inductive effect, solvation effect and steric effect. Inductive being most dominant makes 2-degree the strongest amine. But yes, in order to exactly know which is a better base, you have to judge the value of Kb. So once we do that, we have seen 2-degree is always the winner, either with methyl or ethyl. So with methyl, which is a smaller group, 2 is always the winner. With ethyl being the relatively larger group, 2 is always the winner. But point is, students, remember what comes second. So methyl is smaller, so that's just a mnemonic to learn. So with methyl, I give 1, 3, and with ethyl 3, 1. Why? Because 13 is a smaller number, 31 is a larger number. So with larger group, larger. So if you just learn that, then we definitely know 2-degree is most. Then because it is methyl, so then 1-degree and then 3-degree. That means option 1 is your right answer. Percentage is less. I hope everybody is clear now. Guys, moving to the next one. Again, a very probable, but beta, same questions. I'm intentionally giving you the same questions from amines, from that aldehyde, that aldol condensation question, because beta, they are very, very probable. PDF of this session, beta, you can get from PW NEET English WhatsApp channel. So yes, you can just go to the WhatsApp channel. The link to the WhatsApp channel will be there in the bio of the channel also and of the video also. है ना? Chalo. Great. Great. Quick. Chalo, sir. Sir, that means, sir, this is also same, sir. This is Hoffman bromamide degradation, sir. So CO will be removed, sir. So I will be having CH2 and NH2, sir. And post heating, sir, this will give H, sir. This will give CH3OH. So ultimately not water, but methanol will be released. And I will be having benzene ring, sir. And then this is CH2. This is having NH, sir. It is now connected with carbonyl carbon, which is connected to here. So you just have to explore the picture, which is given in option 4. That means Delhi is your right answer. I hope still percentage has declined, but I hope everybody is now clear. Chalo. Moving to... chalo. Let us do this last question of amines. Time start in 3, 2, 1, go. Because then we'll be moving to biomolecules. Yes, biomolecules are beta. See, actually we'll not be moving to biomolecules. I'll be skipping biomolecules. Why? I will be giving you those questions, but I'll be skipping biomolecules. Why? Because beta, in your biology, you obviously read that biomolecules to a larger extent. But yes, you should know, you should learn what in biomolecules. For chemistry, you should know carbohydrates, the reactions of glucose, the Haworth projection of glucose and fructose, the the disaccharides, the polysaccharides, that too, that maltose, lactose, and galactose. That's it. Polysaccharides, starch, and cellulose. That's it. And then the alpha amino acid, which are polymers I mean, which are monomers of proteins. There are 20 alpha amino acids, essential, 10 non-essential. What are non-essential? For them, I have a rhyme: CGSA, CGSA protyro. So all names that are starting with C, G, S, A, protyro. All these alpha amino acids are non-essential, whose name are starting with either C, G, S, or A. But yes, you should also couple with a more mnemonic, which is Argentina zaruri hai, as in all A are non-essential except arginine. So for learning that, Argentina zaruri hai. Yes. And yes, their structure also you should know. And then the famous table of vitamins of NCERT, that also you should remember. And then yes, biomolecules is done. So I will be not giving any biomolecules here. We'll be directly jumping to inorganic, carbonyl compounds, and D block and coordination complexes. Cool, cool. Chalo, perfect. Now, sir, here let us explore this question. When, sorry, a given nitrogen containing aromatic compound A reacts with SnCl2 and HCl. So, sir, this is a reducing agent. Sir, this reducing agent will followed by nitrous acid to give now, because who will react with nitrous acid? Sir, amine. Who will what get reduced by metal and acid? Sir, nitro group. That means A is definitely a nitro group. So, can I see a nitro group? Yes, I can see a nitro group. So once it is reacting with metal and acid, sir, it is forming 1-degree amine, aniline. With nitrous acid, it is forming benzene diazonium salt as an N2 plus. Hey, come on. So that means answer is D. I'm just explaining. 60% of you got it. So this will be N2 plus Cl minus after HNO2, which is unstable compound. Be on treatment with phenol. Okay, but I'm using this diazonium salt with phenol. So that means, sir, phenol in basic medium is giving a beautiful colored complex. That means this is a coupling reaction. So at para position of phenol, because phenol is a strong activating group, at para it is least hindered also. So this para position will be attacking, I mean this electrophile will be attacking this at the para position. So this N double bonded N, which is there in itself with benzene ring. So this is your coupled dye. So yes, this will be a beautiful colored dye, and this my compound is C. Molecular formula is given. I do not need this formula. The structure of the compound is obviously option A. Cool, cool. Chalo. Perfect. Perfecto. Now let us move forward, beta. After this, sir, as I told, biomolecules you should definitely read, but I have iterated what you should do for biomolecules. And then I'm quickly and directly jumping to the last and most famous chapter of our chemistry, which is the inorganic side of class 12th. Just 2 chapters, D block and coordination compounds. For D block and coordination compounds also, beta, questions are very expected. For coordination compounds, first thing is, sir, you should know how to write those electronic configurations. 1, 2, sir, you should know. After that, you should obviously, if you know how to write electronic configuration, you can very well find the number of unpaired electrons. If you find those number of unpaired electrons, you can find paramagnetic and diamagnetic nature. And then, sir, hybridization, whether inner orbital or outer orbital. Then, sir, IUPAC. Then, sir, after that, that crystal field splitting energy stabilization calculation, that for octahedral which attains high energy, sir, T2G set, EG set which attains lower energy, sir, T2G set. Okay, sir. Now what about tetrahedral, sir? Splitting happens opposite, sir. What opposite, sir? T2G occupy higher energy and T2 occupy higher energy and E occupy lower energy. Why not G? Because they are not J-rate, they are not symmetrical. What's tetrahedral? What about the splitting? Sir, tetrahedral splitting is less, sir, because ligands are only 4, sir, and obviously magnitude. Sir, in case of coordination number 4, but you can have higher splitting also. When you increase lone pair of electrons, so square planar complexes is formed. With inner shell, how you increase lone pair by forced pairing. So that forced pairing will increase number of lone pairs. And apart from that, last, which were less, but yes, you can get questions from isomerism and in structural isomerism and stereoisomerism. Stereoisomers are very specific. Stereoisomers are only seen in coordination complexes with coordination number 6, and those examples, those 3 examples, that cis will definitely show geometrical isomerism, and trans, because it is having element of symmetry, so trans will rather not show geometrical optical isomerism. Yes, it can show geometrical, है ना? So that's it. And the structural isomerism, those naming, so that those questions. And talking of D block, obviously nothing is left, sir. If you have read all, for coordination you should know synergic bonding also, that metal carbonyl, apart from sigma bond, they can form pi bond also. So that's why carbonyl, although CO is neutral ligand, but still it is having maximum crystal field stabilization. Last but not the least, crystal field stabilization do not only depend upon ligands, sir. It depends upon the metal cation also. So if the metal cation is large, then crystal field splitting is also large. With this beta, with this, I guess, with these 5 minutes of things that I have said, you just practice questions and you are done. Last is said for K2 D block elements are just learn the 3 pages of KMNO4 and K2Cr27, all the complete reactions, K2Cr27 and KMNO4, those 2 and 3 pages of NCERT, and you are done with at least 3, maybe 4 questions. I hope everybody is with me on this. Cool. Chalo. Now let us begin. Let us continue. What begin? Let us continue with the question discussions. Chalo. Okay, perfect. Now let us continue with some question discussions. Again, the first question is in front of you, which I guess most of you have already attempted. So let me quickly do this for you. Which of the following is paramagnetic? So, sir, nickel, because everybody is nickel, so nickel is atomic number 28. That means this is 4s2, 3d8. If nickel, I guess every nickel is in +2 oxidation state, so 4 is gone. That means this is 3d8. Now, sir, chlorine is a weak field ligand, so this will definitely be paramagnetic. Sir, carbonyl is a strong field ligand, and here oxidation state is also 0. So the 4s electrons will be forced inside, although the hybridization will be sp3, but it will be diamagnetic, so not paramagnetic. Now, sir, again, Cn is a strong field ligand. This is also +2, so only 8 electrons are there, but the cyanide will do forced pairing. So these are my 8 electrons, and definitely this will be forced because this will be dsp2 hybridized, hence it is also diamagnetic, therefore not paramagnetic. Now next is sir, nickel +2 weak field ligand. So yes, sir, this is also definitely paramagnetic, and because nickel is in a 0 oxidation state, and this nickel present in 0 oxidation state, so ultimately this is 4s2 3d8. And okay, coordination number is 4, but yes beta, triphenyl phosphine also act as a strong field ligand, so rather this will also do forced pairing, so these 2 electrons will be forced inside, and this guy will also be, although it will be sp3 hybridized, but will be diamagnetic. So also this is a good example, So A and D, that means third is your right answer. So these are the type of questions that you are going to get for your 21st examination. I hope everybody is with me on this. Now, sir, make us practice some question on isomerism, structural isomerism. Definitely, beta. Answer the question is in front of you. Hit it. Hit it. Sir, quite easy, sir. Sir, this is NO2, so it can ligate. Nitrogen can also ligate. Sir, ONO, oxygen can also ligate. So this is nothing but linkage isomerism. That means A is Q, sir. That means A is Q, sir. So this is gone. This is gone. What about B, sir? B can be either R or B can be S. So let us check B. Sir, this is sulfate bromine, sir. They can interchange, sir. So because they can interchange, that means they can show ionization isomerism. So B is definitely R. So that means you have got your answer, but revising. When both the complex cation and anion are complexes, then they can show coordination isomerism where they can exchange ligand, and when water act as ligand can act as water of crystallization also. This forms the solvate isomers. Yes, technically when solvent is water, you can also call it hydrate isomers. I hope everybody is clear. Moving to the next one. Acha, let me check how many of you have participated. 80%. Great, beta. Fair enough. Now, a bit of naming. Okay, these are not even naming, just basic definition that when all the ligands are of same type, then such complexes are called homoleptic. When the ligands attached are of different types, they are heteroleptic. So homoleptic complex is what? So here I have amine also, eca also, sir, this is heteroleptic. Here I have only oxalate, yes sir, this is homoleptic. Here I have amine also, chloro also, so heteroleptic. Here I have amine also, carbonato also, so heteroleptic. So obviously this is single, correct? This is single, so we have got, but still learning. Moving to the next one. Yes sir, naming, sir. So beta, like you name a salt, first you name the cation, then you rather name the anion. First you name the cation, then you rather name the anion. So how can I name the cation, sir? This is also complex, this is also complex. Okay sir, so I have first you name the ligand, naming the cation first. Sir, it is having two, that is di, ligand is water, so aqua. So this much is good, so I'll not checking the next because this is, I'll go when this is wrong. Sir, silver, and then I write in parenthesis the oxidation state. So because silver definitely form compound is in +1, so that means this is 1, this is 1, so this silver is definitely in +1 oxidation state. That oxidation state I write in parenthesis, cation, done. Now anion. I'm sorry. then comes anion. So this is di-CN is cyanido, and silver is argentate. Why? Because when complexes are used, now when complexes are used as a anionic complex, then the metal is not named as it is named using a suffix called ate8. And yes, if the metal is known by its Latin name, like for silver we don't write S, we write Ag, that means silver, for silver you have its Latin name, so use their Latin name. So for silver, Latin name is argentum, so it is suffixed with 8, so this becomes argentate, and in parenthesis you write its oxidation state. So this is perfectly correct, option 1 only is perfectly correct. Yes, so I hope everybody is clear. Chalo. Now, sir, apart from that, you should learn the spectrochemical series also, which relates the strength of a ligand, that how ligand, on which ligand is strong or which ligand is weak. If a ligand is strong, then crystal field splitting is more. If ligand is weak, crystal field splitting is less. Sir, can you give us a trick to learn it? Yes, definitely. Beta, generally carbon donors are best donors. After that, nitrogen donors are better donors, then oxygen donor, then halogen as in fluorine, chlorine, then sulfur donor, and then the remainder of the halogens as in uh, fluorine, chlorine, bromine, and iodine. So if you just remember this much, I guess most of your job will be done. But yes, if you can at least learn the NCERT spectrochemical series, because if a ligand is weak, then the splitting that they will will also be large. So if splitting is large, then the whatever unpaired electrons will be getting energy and getting dd transition and showing colors, but sir, more energy will be required. If more energy is required, that means sir, splitting is large. So in the same, it is asked that energy absorbed, so more energy will be absorbed when ligand is having strong splitting. Yes, the splitting not only depend upon ligand, it first depends upon the charge density of the metal cation also. But see, all the metal cations are same. So generally your NEET question are more focused. Generally your NEET questions are more focused on the strength of ligand. So sir, here I have 2 ethylene diamines, here I have 1, here I have 3. Moreover, sir, Sir, whenever you have a bidentate ligand, then the bidentate ligand can also have a chelation effect, which provides more and more stability. So, sir, and obviously nitrogen donor is a stronger donor than oxygen donor. So, if I have I have three ethylene diamine, then definitely, sir, splitting will be more. So, most energy will be utilized in option C. So most is utilized in option C, then in A because it is having two. So that means option 4 becomes your right answer. I hope. Array, percentage is very less, beta. I hope everybody is clear, guys. 4 is your right answer. Now, attempt this one quick. Attempt this one quick. Attempt this one quick. Now, what does this question tell us? Sir, again the same thing. Sir, you just have to calculate number of unpaired electrons. Here, oxidation state of iron is +3. Here also, sir, it is +3. Here also, sir, here it will be +2, and here it is +2. Now, sir, Fe is 4s2 3d6. Okay, so Fe +2 will be, this is gone, that means this is 3d6. And sir, if 6 electrons are forced to pair inside, then they will have no unpaired electrons. So in case of Fe+3, like in this, and in these two, if I have a strong field ligand, then definitely, sir, I will not have any magnetic moment because I will be having all paired electrons. So I'll be damning. Don't even dare to calculate for all. Use common sense of exploring options. So option A is Q. Option A is Q, na? Okay, this I'm talking of Fe+2. I beg your pardon. This two electrons are gone, na? So this I'm talking of Fe+2. That will definitely. So where I have Fe+2 here, and this Fe+2, this is a strong field again. So C will be Q. So C is not Q. C is not Q. C is not Q. C is definitely Q, and you have got your answer. I hope everybody is clear. Beta, in such questions, please make sure you are giving a very, very strong observation on the options first, because options will make and save your time like anything. I hope everybody is clear. Chalo. Now, moving forward. Acha, let me check how many of you have attempted and given C as an answer. The percentage has reduced, but still it's good because participants also has increased, I guess. Chalo. Doing some questions regarding isomerism. Time start in 3 to 1 go. Now, the type of isomerism shown by complex this, sir, you have already told us. Now, sir, this is having a complex of the form metal symmetrical bidentate ligand 2 and A2 as in monodentate ligand of two types. So it will be, sir, this is M. If I have those symmetrical bidentate ligands, so that AA will be coordinating like this and it is bidentate. So this AA is coordinating like this and it is bidentate. So sir, here I can have, this guy can have chlorine or that unidentate ligand, monodentate ligand A as this side, but this guy in this sense will definitely, this will be a planar molecule. If you cut along this plane, sir, it will be symmetrical. So this will be optically inactive. So the type of isomerism that this guy can show will only be geometrical, because this trans isomer will be optically inactive, but it is not asking you which isomerism. It is just asking you, so sir, optical, it may not show, because if it is cis, you don't know, but it can show cis trans isomerism because this is trans, so you can definitely form its cis form. Unable to, okay, sorry, this is trans, so you can obviously form the cis form. So that means what isomerism it can clearly show? Geometrical. But yes, the cis form will also show optical isomerism, but yes, question has to give specifically cis form. So obviously answer is option A. A. 69%. Fair enough. Great. Which brings us to Acha, coordination done. Okay, let us, nahi yaar, I want to you to make one more question for that. T2G and EG. T2G and EG calculation. So, do I have? No, I don't have any T2G or EG calculative questions, but I guess I have segregated one for you. So let me make you attempt this at least. Make attempt this beta. This one. Attempt this, and then we will be moving forward. Attempt this one. Quick, quick. Attempt this quick. Which is the correct electronic configuration of the central atom K4FeCN6? Now, based on crystal field theory. So which is correct, sir? Let us explore the cation, sir. Sir, here Fe is again in +2. You have already explored it, sir. Fe in +2 oxidation state will definitely have a splitting, which is this is T2G and this will be higher EG set. So this splitting will be large enough. So because this is large enough, so electron will be, it will be difficult to electron to occupy that high energized EG subshell. So it will be covering this lower energy T2G set. So it will be T2G6 and EG0. I hope everybody is clear. That means option 2 is clearly your right answer. Yes, but now if I ask you, I hope everybody is clear. Chalo. So guys, I guess this is it then in that case. Because yes, we have finished D block also, we have finished coordination also, and with this I guess let's call it a day. All the very best, because all the very best. You know why I'm ending it with just a bit? Because yes, obviously after this you have your biology class, and yes, if you require any other clarification, any other help you want in these coming 4-5 days, then you can obviously just go to the comment section and put whatever doubts you have over there. We will definitely try to cover whatever related help we can do from our side, because you have to perform to your best of your efficiency, and for that whatever it takes we will definitely do it. So I hope nahi yaar, I hope everybody will be, just after the live is done, which is definitely done now, I will be putting all these lecture notes in PW-NEET English WhatsApp channel. So download them, practice them. If you have any doubt, come to the live section, come to this live video. It will be there in the live section of PW-NEET English. Ask whatever doubts you have, and definitely the moment I'll be coming, I guess day after tomorrow, I'll be definitely taking those doubts. Okay, so this is it. This is Gaurav Singh Arora signing off. Please take very good care of yourself and study as much as you can. Bye bye, take care.